understand. Go to open the hatch.
You are go to open the hatch.
EV1 functional.
EV2 functional.
Good morning and welcome to NASA TV's live coverage of U.S. Spacewalk number 36. That's going to install a new gateway on the International Space Station for our commercial crew partners. I'm Brandy Dean and I'm going to be your host for the day. We've got a great lineup of features and expert interviews coming up for you, but it's all revolving around what's going on in space right now. Astronauts Jeff Williams and Kate Rubin are getting ready to go outside the hatches of the International Space Station. They'll be performing a 6.5-hour-long spacewalk to install an adapter that will let American companies building new vehicles to launch astronauts from Florida to dock to the International Space Station. That's scheduled to start in about an hour and a half from now. And between now and then, we'll be talking with robotics and spacesuit experts and answering your questions if you send them in via social media using the hashtag AskNASA. But following along with the preparations from Mission Control is my colleague Rob Navius, and he'll be giving us regular updates and commentary throughout today's spacewalk. So we'll let him kick it off now. Rob?
And good day from Mission Control here in Houston, where the Orbit 2 team of flight controllers has just completed a shift handover from the Orbit 1 team. The Orbit 2 team on console now, ready to execute this planned 6.5-hour spacewalk by Jeff Williams and Kate Rubins that will set the stage, a pathfinding spacewalk that will open the gateway for the launching of U.S. commercial crew vehicles to the International Space Station. You are looking live in the equipment lock section of the Quest airlock, where our two NASA astronauts on the right, Expedition 48 Commander Jeff Williams, and on the left, Flight Engineer Kate Rubins are suited up. They are ready to begin the final preparations with the assistance of Japan Aerospace Exploration Agency astronaut Takuya Onishi and Russian cosmonaut Anatoly Ivanishin to move through the hatchway that you see at the top of your screen into the crew lock section of Quest, where they will close the hatch behind them and begin preparations for the depressurization of the crew lock that will set the stage for them putting their suits on internal battery power to mark the official start of this spacewalk, which is the 194th spacewalk in support of space station assembly and maintenance. For veteran astronaut Jeff Williams, this is the fourth spacewalk of his career. 3 previous spacewalks have garnered a total of 19 hours and 9 minutes of EVA time outside, dating all the way back to May of 2000, when he conducted his first spacewalk on the STS-101 mission aboard Atlantis with astronaut Jim Voss, a 6-hour, 44-minute spacewalk in the early days of space station assembly. For Kate Rubins, this will be the first spacewalk of her career. She has been preparing and training for this for several years now. The crew was awakened just after 1 a.m. Central Time. 2 hours later, they were all suited up, beginning their pre-breathe procedures to breathe pure oxygen, thus cleansing the nitrogen out of their bloodstreams to prevent any condition known as decompression sickness from occurring when they step outside into the vacuum of space about an hour and a half or so from now. The spacewalking team here in Mission Control conducted all of the checks with the astronauts of their suits. Their suits are airtight. They're in good shape. All of the systems appear to be in excellent shape, and the crew is in great spirits as they prepare to begin what will be the first U.S. spacewalk out of the Quest airlock since January 15th this year. The focus of attention, of course, is the final hookup of the International Docking Adapter, the International Docking Port that was launched in the trunk of the Dragon spacecraft, the SpaceX Dragon spacecraft that lifted off from Cape Canaveral back on July 18th, arriving at the International Space Station on July 20th. The IDA, as it is known by its acronym, was extracted from the trunk of Dragon through the use of the Canadarm2 robotic arm and its special purpose dexterous manipulator, nicknamed Dexter. They plucked plucked the IDA out of the trunk of Dragon late Wednesday night, maneuvered it into its pre-install position, and just within the last hour, the robotics officer here in Mission Control pushed the IDA in for a surface-to-surface, structure-to-structure contact with pressurized mating adapter number 2, the black structure that you see on the right side of your screen that was originally launched on the first assembly flight of the International Space Station, STS-88, back in December of 1998, attached to the Unity module, or Node 1 of the International Space Station. This international docking adapter, although diminutive in size, just 1,021 pounds, 42 inches tall, 63 inches wide, with an outer diameter of just 94 inches, is the key to the arrival of U.S. commercial crew vehicles for both the SpaceX Crew Dragon and the Boeing CST-100 Starliner spacecraft that are under development. They are being designed specifically to be able to dock to the international docking adapter. Also present here in Mission Control, now that the shift handover is complete, we'll set the stage for you with the personnel on console. The lead flight director for this spacewalk, which is the, as we said, the 194th spacewalk in history of space station assembly and maintenance. On the top of your screen, that's Zeb Scoville, a former spacewalk officer in his own right, now a veteran flight director. In the middle of your screen is astronaut Christina Cook. That is spelled K-O-C-H, but pronounced Cook. She will be on the space-to-ground loops talking to the crew during the final preparations through the depressurization of the crew lock. She will then turn over the communications chores to the two spacewalkers, Williams and Rubins, to Tom Marshburn, the veteran astronaut that you see on the left side of your screen, a veteran of 4 spacewalks himself. Also here is the lead spacewalk officer, Glenda Brown, a veteran spacewalk officer. She is in the back row of Mission Control, not present at the moment, but she will be a short time from now. Glenda has been choreographing this spacewalk for several years, working with the astronauts during their training exercise periods, and she's now ready to take over with the flight control team in Houston as they walk through all of the procedures that will first close the hooks between the IDA and pressurized mating adapter number 2, the docking port to which space shuttles used to dock, and the IDA to which the new U.S. commercial crew vehicles will dock. A few days ago, Glenda Brown had an opportunity to narrate for us a very comprehensive animation that will walk you through the steps of today's 6.5-hour spacewalk. Let's take a look at that video and our EVA for today.
We start out our EVA at the Quest airlock. Jeff will be EV1. He'll be coming out wearing the red stripes, and Kate will hand out an ORU bag to him that contains all the IDA tools. She'll egress, and then they'll begin their translation forward out to the very forward end of the space station to do their work. Jeff will translate around the starboard side of the external stowage platform number 2. He'll wait there just a moment while Kate finishes her initial translation adaptation and then translates over the top of the stowage platform out to pick up her foot restraint, which is on the very forward edge of the ESP-2. Once she's got that, Jeff will translate forward on the lab and that up over the top of the Node 2 and finally onto the PMA-2 that's at the very forward end of the space station. He'll position the ORU bag on a couple of handrails that are right on the zenith side of the PMA, and then open the bag so that they've got access to their tools and equipment. In the meantime, Kate begins her translation. She's going to translate up over the top of the lab, and then forward onto the Node 2, and finally forward onto the PMA-2, where she translates down toward the nadir side and locates the socket where her foot restraint will go, or worksite interface. Once she has her foot restraint set up there, she'll be able to access the cables that were pre-positioned by Butch Wilmore on a prior EVA. They're tied off to in a bundle to a couple of handrails that are located on the PMA. While she's getting set up, Jeff will also get his foot restraint and get it set up. It's currently located on the top of the Columbus module. He'll retrieve it from there and then move it down to his worksite interface on the PMA, which is more zenith and a little bit toward port. From there, each of them have access to be able to reach their cables. Jeff's cables have also been pre-positioned on a prior EVA. Terry Burtz left 2 bundles of cables there for him to access. Once they get into their foot restraints, they can attach their adjustable equipment tethers loosely to the IDA. Kate has 1 adjustable tether, and in order to be able to reach between the handrail and the IDA-2, Jeff actually has 2 tethers in series. When they're in position, they'll give the go to the robotics operator on the ground to release the IDA-2 and back the Dexter arm away. At this point, the crew has complete control of the IDA. They'll cinch the tethers down into place, and then they'll begin mating the cables. This is Kate's cable configuration on the nadir side. Here we see her at the neutral buoyancy laboratory practicing those cable mates. And while she's mating her cables on the nadir side, Jeff is mating his on the zenith side. He has 3 cables to initially mate. These cables are providing heater power to the docking adapter, as well as the hook drive power and the sensor power. The switches will be commanded by the internal crew member, IV crew member. TOC will work at the IDA control panel, which is in the node 2 pressurized volume. As he operates the switches, it commands the hooks that are on the docking adapter to extend out, rotate around, and engage the passive hooks that are on the pressurized mating adapter. There's 2 sets of hooks, and while they drive the first set of hooks, the crew needs to remain still. But during the second drive, it's stable enough that they can begin work installing a cover on the hemi-reflector that's on the nadir part of the PMA-2. Then they're into their final cable mates. These final cable configurations remove the power from the hooks that we're driving to engage the PMA and provide visiting vehicle hook power. Here you see Jeff working in the neutral buoyancy laboratory. He's removing a couple of jumpers that are required to do his final cable mating. Once the cables are mated, they have some outfitting to do. First, they'll be covering up the H fixture that the Dexter robot arm was holding on to. Then there is another hemi-reflector that is on the PMA. They'll install a cover over the top of it and then move the tether that was holding that cover in place up to tether to the large protective cover that's covering the IDA-2. That was in place for launch in the SpaceX Dragon. There are several straps that they need to work together to remove. It's very similar to the PMA covers that we've been installing and removing in the past. Here you see Kate working in the NBL to remove the straps from the handrails holding it in place. The 2 of them need to work together to stuff that cover into the ORU bag. At that point, they can install the 2 hemi-reflectors onto the docking adapter, and then the final thing that they need to do is mate up the visiting vehicle power. It's 1 final cable configuration that needs to be made. Jeff will complete that mating, and at this point, that docking adapter is ready to receive our new crew vehicles. The crew can pack up and clean up this work site. Kate will pick up her foot restraint and return it to the ESP2 from whence it came. Jeff has to pack up the ORU bag and also return his foot restraint. His foot restraint goes back from where it's located, where he's been using it on the PMA. He'll take it back up to the top of the Columbus module. It'll be staged there in place for the IDA-3 installation that will be happening in late 2017. They return the ORU bag back to the airlock and then Kate will go out to the lab nadir to a bag that's already there and route the cable for IDA-3. We call it the white-green cable because we put some tape marks on it in white and green to indicate which one it is. She routes it forward to the Node 2, where it's in position for the IDA 3 installation. Jeff has some work to do back in the area where the Z1, the Node 1, the Node 3, and the lab all come together. We refer to this area as the rat's nest because of all of the cables and electrical lines and fluid lines that route through that area. He'll pick up the cable bundle that was left in position at the end of EVA 35. He'll make a couple of connections down on the Node 2 and then route that cable across the Z1 tray over to the starboard side of that tray and then leave it in position there where it will be ready for its final routing on a future EVA. The last scheduled task for this spacewalk will be to remove a couple of caps from some connectors that are located just underneath the Z1 on the outside of the Node 1. At that point, the crew will return to the airlock and ingress. If we've been particularly lucky and efficient throughout the day and the hardware cooperates, rather than ingressing the airlock, we've got a couple of get-ahead tasks that we can do. One of them is to configure the port CETA cart. We'll tie down the brake handles to keep them out of the way for long-term operations on station. And then we also want to get some photos of the alpha magnetic spectrometer. From the windows and from all the cameras on space station, we cannot see the outboard side of the AMS. And we'd like to get some photos of that area, see how it's doing, so they can get those photos from the top of the logistics carrier that's located right next to it.
That was lead spacewalk officer Glenda Brown narrating a brief video outlining all of the activities that lie ahead for Jeff Williams and Kate Rubins over the next several hours on US EVA 36.
All right, welcome back. As I promised, we do have some interviews coming up for you, but just in case you prefer your commentary uninterrupted, you can find the uninterrupted version of today's spacewalk online at nasa.gov/NTV. That's nasa.gov/NTV as in NASA TV. But as Rob mentioned, we've had a lot of robotics work that went into getting ready for today. So next we're going to turn to the Canadian Space Agency in Quebec, where we're going to be joined by Matthew Caron, who is the Senior Operations Engineer joining us from their Mobile Servicing System Complex in Quebec. Matthew, thank you so much for joining us.
Good morning.
All right. Now, I want you to give us kind of a status of where everything is, but before we do that, since Dexter, the Special Purpose Dexterous Manipulator, is kind of the star of the show as far as robotics go today, maybe you can start by explaining exactly what Dexter is.
Well, Dexter is a boat that's operated at the end of the Canadarm2, so the big station robotics system. And Dexter's main role is to try to reduce the number of spacewalks the astronauts have to do. So its primary purpose is to remove and replace failed components outside the pressurized volume of the space station and replace them with a new replacement unit. We've also used Dexter extensively in the past in order to move around some of those spare parts or experiments in order to prepare spacewalks or configure some space station scientific payloads.
All right. Now that we know what Dexter is, why don't you tell us a little bit about what he's been doing the past few days and this morning?
Okay, well, 2 days ago, the flight controllers on the ground, both located in Houston and at the Canadian Space Agency, sent commands to the Canadarm2 and Dexter in order to reach into the Dragon's trunk in order to extract the newly delivered adapter. So that was a very complex operation because the adapter is fairly big. It's equipped with a handle that's specially designed to be itself manipulated by Dexter. And through ground control, they extracted the adapter from the trunk and reconfigure it such that it's now hovering roughly a few feet away from the interface where it will be installed today. So right now we're waiting for the spacewalkers to be in space before Dexter moves in and presents the adapter and hands it off to the spacewalkers.
Why wait until today to move into the final position for the installation?
Well, unfortunately, Dexter is not able to complete the installation all on its own. It can present it, but the astronauts outside will have to complete the connections and solidify the interface. Once Dexter will hand it off to them, Dexter will then release them, and the astronauts will complete the installation. We had to stay. Typically, when we stow pieces of equipment off of the space station, we try to move back a few feet in order not to interfere with other space station operations. For instance, if there were a need to reorient the space station's attitude, then we want to make sure that as they fire thrusters, it will not induce any motion that will possibly bring the adapter a little too close to the station. So for that reason, we always configure the robotic systems and whatever it's holding in order to be a safe distance from the space station.
That makes sense. And I guess really the use of Dexter during a spacewalk is kind of new. Do you feel like that's a big milestone for the team, or is it a complex operation for Dexter?
Absolutely, because initially when we thought about how we were going to operate Dexter, we thought about it would be operating on its own. When the astronauts are in the safety of the space station, Dexter would be performing, I hate to use the analogy, but sort of replacing the spacewalkers and completing the removal and replacement or repair on its own, or performing logistic tasks on its own without necessarily support from the astronauts. And with the big arm, with the Canadarm2, we have had support of spacewalkers. However, with Dexter now, Dexter was never really, it's the first time that we use Dexter to present something to astronauts and during a spacewalk. So that's a different aspect, because clearly the arms, the handles that Dexter's using, its arms, had never been tested with a spacewalk. So for us, it involved a lot of analysis and making sure that the operation would go smoothly and safely, and that we have a good chance of success. That's one aspect. The other aspect is Dexter is controlled exclusively from the ground. So we're very familiar with ground-controlled operations of Dexter and the Canadarm2. However, typically, astronauts are far away from it. Even during spacewalks, when we've used the Canadarm2 and Dexter's cameras to monitor the spacewalk, we always remain a far distance away to make sure that we didn't interfere with the spacewalk, and we set at a safe distance. Now it's the first time that we have ground controllers controlling a robot interacting directly with astronauts during an EVA, and that in itself, we had to really carefully rehearse the sequence of operations to make sure that everything would go smoothly and safely.
Well, I'm sure it will today. It sounds like things are going very well so far. And we are taking questions via social media if you send it in using the hashtag AskNASA. And we've gotten one already today from Naur on Twitter, who's asking, will we always have spacewalks, or are we planning on just using robotic technologies in the future?
That's a very good question. Well, Dexter's designed to interact with components that have themselves been equipped to be handled robotically. So when I was talking about some of the space station's components that can be replaced by Dexter, well, they're equipped with special markings, with special handles, fixtures, interfaces that make it easier for a robot to do that. However, as we gain more experience with the space station, we've realized that these interfaces, or these features that allow something to be what we call robotically compatible, are not always perfect. So sometimes we've really had to scratch our heads and look at what we can do different with Dexter to try to manipulate something that's not quite robotically compatible. And it's a little tricky, but we found that a robot gives you a lot of flexibility in order to perform those operations. Now, clearly, I don't think we'll ever have a robot that's as flexible in terms of being able to do different things than a human being. Because to do anything with Dexter, it takes a very, very long time. However, the big thing is we can't take a long time with Dexter to do things. Spacewalks, typically, we talk about 6-7 hours. Well, for Dexter's operations, we can spread them out over several days, because whenever we reach a convenient stopping point, we stop and resume later. We can't do that from a spacewalk. But I suspect that whenever manned spaceflight is involved, that we'll have will continue to have spacewalks because of the increased flexibility of human beings.
Well, I hope so. Dexter's definitely fun to watch, but I wouldn't want to give up spacewalks either. Now, I actually remember when Dexter was delivered to the space station back in 2008 on STS-123, and it seemed like at the time there was a lot of ideas for things that maybe it could help with, but also a lot of speculation about whether or not it would actually be able to do them. It seems like Dexter's really lived up to the hype, so I wanted to see if you could have imagined this looking back in 2008, or if you want to give us kind of some of the ways Dexter surprised you over the years.
Looking in 2008, we understood, as I mentioned, we plan on Dexter interfacing with robotically compatible hardware. But as we started looking a little closer at the operations, we realized that they would be very, very complicated. Initially, for instance, Dexter was supposed to be operated by onboard astronauts, but then we realized that the operations were so complex that it would take so much time that it would divert the astronauts from doing the important scientific work on the space station. So that's when we said, well, maybe if we shift its mode of operation to ground control, then it would help us do more. And that really it opened up the doors to do a lot more things with Dexter. And every time we tried a new operation with Dexter, we realized that, it's a little more complicated than we thought. However, the flexibility within the robotic system allowed us to overcome those difficulties. And to illustrate that, NASA wanted us to see, well, if we were to take a robot like Dexter and send it over to a satellite, could we possibly repair a satellite or refuel it, even if that satellite was not designed to be handled or manipulated robotically? It was a robotics refueling mission. So in 2011, on the last space shuttle flight, NASA delivered a sort of a toolbox with a set of activity panels that were designed to mimic the exterior of a satellite and see if the new tools provided to Dexter would allow it to really do tasks that are similar to what we'd have to do to refuel a satellite. So cut tethers, remove thermal blankets, unscrew fuel caps, bring a fuel nozzle, pump fuel. And we were quite happy to conclude that, yes, it would indeed be possible for robots such as Dexter to perform very complex refueling and maintenance tasks on hardware that was not itself designed to be robotically compatible. So that's really promising for the future, not just the space station, but future projects after that.
So maybe we won't see him taking over spacewalks in the future, but it sounds like there are a lot of amazing uses in store for Dexter or robots like it. I mentioned when we started talking that you're joining us from Quebec, and I feel like a lot of people know that the Canadian Space Agency has a lot to do with robotics because Canadarm is emblazoned with the name, but they might not realize that not all of the robotics work actually goes on in Mission Control Houston. So why don't you explain to us what you do there from Canada on a day-to-day basis?
Well, the Canadian Space Agency is highly involved with all aspects of the space station's operations of the Canadarm2 and Dexter. And for instance, Dexter is operated by a joint team of Canadian Space Agency and NASA flight controllers, some of whom are located in Houston in Mission Control Center, but others are operating the robots right here from the Canadian Space Agency in our control center. For instance, for the spacewalk today, you have the lead flight controller is a NASA flight controller operating out of the front room. However, he's assisted by one Canadian flight controller in Houston and another one sending commands from the Canadian Space Agency. So over the years, over the past, since 2004, roughly half of all the operations have involved one or two of the team of 3 flight controllers supporting operations from here. But that's just the tip of the iceberg, because in the planning of all the operations, we have engineers that will carefully analyze all aspects of the operations to make sure that the forces of moments that are imparted on Dexter or that Dexter will impart on the space station are all within safe bounds. We constantly tweak the software, Dexter's software and the Canadarm2 software, in order to make sure that we optimize their performance for whatever tasks are at hand. All astronauts or all flight controllers that are going to handle control the robotic system, the Canadian robotic systems, come to the Canadian Space Agency for a few weeks in order to receive training on how to operate that. So we're happy to be able to work very closely with our NASA counterparts in order to make sure that robotics operations are very successful on the space station.
All right. Well, I know you've got a busy day, or at least the robotics team working with Dexter today does. Why don't you give us one more look at what's coming up for Dexter today?
Yeah, well, today Dexter will move in and present and bring the adapter almost to the fully installed position, stay there, and then it will let the astronauts complete the various connections and solidify the interface, at which point Dexter will just let it go and move back. And then next week, we have a busy week of operations slated where we're going to flew ground control, stow Dexter back on the mobile base elsewhere on the space station before the Canadarm2 goes on to grapple the SpaceX 9 Dragon capsule in preparation for its release next Friday, August 26th. As soon as Dragon has departed, then we will go back and get Dexter again in order to get into we're going to change out of our operation of a circuit breaker on the outside of the space station. When that's done, we're looking forward to performing a survey of parts of the back of the space station. And once that's done, well, we're going to start thinking ready about the next spacewalk that's tentatively scheduled for at least September 1st.
A lot going on, right? We really appreciate you joining us, Matthew, and good luck today and on those future operations that are coming up. It sounds like you've got quite a bit of work ahead of you. That again was Matthew Caron, who is a senior operations engineer joining us from the Canadian Space Agency in Quebec. Thanks again, Matthew.
Thank you very much.
Now, just a reminder to keep sending in your questions using the hashtag AskNASA. Not only are we going to answer some on the show today, but astronaut Doug Wheelock will also be answering them on Twitter. And at 9 a.m. Central Time, veteran spacewalkers Sonny Williams and Bob Bankin, who are also assigned to NASA's commercial crew cadre, are going to be answering questions in a Facebook Live that will air here on NASA TV and also on the International Space Station Facebook page. But before that, in just a few minutes, we're going to be talking with a spacesuit expert. So if you've got any questions for him, again, send those in via Twitter with the hashtag AskNASA. First, though, let's check in on what's going on as the spacewalk preparations continue.
Back at Mission Control in Houston, for those who are just joining us, you're looking live into the equipment lock section of the Quest airlock of the International Space Station, where the two spacewalkers for today, Jeff Williams, the Expedition 48 commander, on your right, flight engineer Kate Rubins on your left, all suited up, ready to make their way through the hatchway at the top of your screen into the crew lock section of Quest to have the hatch closed behind them, for that crew lock section to be depressurized down to vacuum, and for the crew to place their suits on internal battery power just over an hour from now to begin the 194th spacewalk in support of space station assembly and maintenance.
Houston on Space to Ground 1 for Anatoly.
To set the stage for those just joining us, you'll be hearing several voices here in Mission Control. Two spacecraft communicators working this spacewalk. The voice you'll hear during the pre-hatch open preparations before the crew places their suits on internal battery power will be that of astronaut Christina Cook, the astronaut who's on console with lead flight director Zeb Scoville. She is joined by veteran astronaut Tom Marshburn, a veteran of 4 spacewalks himself, who will be the spacewalk IV or intravehicular communicator today, and he will be the choreographer essentially working through all the timeline procedures with Williams and Rubins after they step outside into the vacuum of space. As you can see with his back to the camera, Jeff Williams as EV1 or extravehicular crew member number 1 is wearing the suit bearing the red stripes. Kate Rubins on the left is EV2, extravehicular crew member number 2. She has no stripes on her suit. This is Williams' fourth spacewalk coming up. His three previous spacewalks spanning more than 16 years of spacewalking experience. He has 19 hours and 9 minutes of spacewalking time to his credit. The first coming in May of 2000 on the STS-101 mission. He also conducted two spacewalks during Expedition 13 in the summer of 2006. One of them in Russian Orlan spacesuits with Pavel Vinogradov, the other with European Space Agency astronaut Thomas Reiter. You can see the two crew members in the airlock with the assistance of Onishi on the bottom of your screen and Russian cosmonaut Anatoly Ivanishin on the right side of your screen, who launched with Rubins and Onishi just 44 days ago. They are about to start the work to affix the simplified aid for EVA rescue, or safer jetpacks, to the back of the two spacewalkers' suits. Those jetpacks would be used in the highly unlikely event that the spacewalkers would become untethered during the spacewalk and would have the ability then to propel themselves back toward the safety of the International Space Station. The International Space Station and its 6 crew members currently flying 254 statute miles above the Earth, actually over the Ukraine, about to cross the border with Russia, moving in an orbit inclined 51.6 degrees to either side of the equator. All of the station systems in excellent shape. This is the first spacewalk, by the way, for Williams and Rubins, of 2 that are planned. The next scheduled 13 days from now on September 1st, in which the duo will venture back outside the Quest airlock for another 6.5-hour spacewalk that will retract a thermal radiator on the P-1 truss of the International Space Station that was unfurled a few years ago during an effort to try to isolate a coolant leak and the cooling system of the International Space Station. That leak was solved through other methods, and it will now be retracted during the spacewalk coming up on September 1st by Williams and Rubins. They also will install the first of a series of enhanced high-definition cameras on that second spacewalk on September 1st. We will be holding a briefing to preview that second spacewalk on NASA television this coming Wednesday, August 24th at 2 p.m. Eastern Time, 1 p.m. Central Time. So everything continues to move along very smartly, just right about on the timeline. The 2 crew members are beginning the work, as you can see, with the assistance of Onishi and Ivanishin, to have their safer backpacks affixed to their extravehicular mobility units. All of the checkouts of the suits have been good so far. No problems reported for either Jeff Williams or Kate Rubins. Kate Rubins today, by the way, becomes the 11th U.S. female astronaut to walk in space, and the 12th overall. Russian cosmonaut Svetlana Savitskaya conducted a spacewalk, of course, more than 30 years ago. Rubins today becoming the 11th U.S. female astronaut to walk in space.
Welcome back. Welcome back to live coverage of on NASA TV of the U.S. Spacewalks number 36. Once again, if you want to watch uninterrupted coverage of the spacewalk, you can find that on nasa.gov/NTV. That's N as in NASA TV. But of course, we've got a lot of fun stuff coming up for you here, starting with Keith Johnson, who is a spacewalk officer, has been on console in mission control many a time for many a spacewalk, and he's going to tell us a little bit about what the crew has been doing today, what's going on, and what's left to do before they start their spacewalk. Thanks for joining us, Keith.
Well, thank you. I'm happy to be here.
Yes. Well, we really appreciate it. So why don't we start with that, though? What has gone on so far today? What's ready to do? It seems like they've been up for a long time preparing for this spacewalk today.
Well, so the crew gets up first thing in the morning and they eat a good breakfast because they're going to be in the spacesuit for a very long time without any food while they're in there. So they'll eat a big breakfast, they'll take care of their hygiene, and then they'll start getting suited up. And that entails putting on the undergarment, the thermal undergarment, and getting their suits ready to go, and then climbing into the suits, buttoning up, and pre-breathing oxygen.
Okay. And that takes about how long in all?
They get up first thing in the morning, and that probably takes them about 4 hours to get ready to go out the door.
Okay, that seems like a lot of time, but they're out there for 6 hours, so I guess that makes sense that it takes a while to get ready to go out into such a harsh environment.
That's correct.
But I guess let's back up. You, on the ground, have probably been getting ready for this spacewalk for a lot longer than 4 hours, probably something like months?
Well, okay, so long ago when they decided that they were going to have this international docking adapter, our team started following along with the development of that hardware to figure out how crew members can help install this on the pressurized mating adapter. So that's been quite a few years that we follow the design, the development of the hardware, and we make sure that it's compatible with a crew member in a spacesuit.
Wow, that's really interesting. That long ago, before they even really start building it, you're a part of it, getting ready, thinking ahead for a spacewalk.
That's right.
Very cool.
And then, when they decide to do the spacewalk, we build up our procedures on how we're going to install it, where we're going to put the crew members, what tools they need to use. We start developing that about a year before, maybe a little longer than that. With this particular docking adapter, we've had the hardware. We were prepared to do this EVA a year ago or more, and then we had to postpone it until this one was ready to go.
Sure. And then now that you've got the adapter there on orbit ready to install, and you've got the crew ready on orbit as well, they've also been getting ready for the past few weeks, kind of reviewing procedures and getting their tools together. Why does it take that much preparation even once all the pieces are in place?
Well, I think it's the fine details. We start sending up the very detailed procedures. They've trained on it. They've seen this hardware in the pool. And now we officially send them the final paperwork that they review. They think about where they're going to translate. They get out a virtual reality device and look to see where they're going to be translating. And that takes several weeks. They've got to interlace that with all the other work that they have to do on board station for science and the rest of their work.
Just a few things going on, right?
Right.
And now they've actually got another spacewalk coming up on September 1st. So when that, when they're lumped together like that, is that when you really love your job or when you're just not getting any sleep at all?
Well, we've got several teams that work these different EVAs, so we kind of spread the wealth around several people to keep everybody busy. But yeah, it's a very busy time when, depending on how this EVA goes, they have to react to what happens during this EVA. If the crew gets a lot done and more, that may affect what happens on the next EVA. If they don't get quite done, then we may have to move some of the tasks onto that second EVA as well.
Okay.
So they're constantly planning.
And so we can kind of keep an eye on what actually happens today to get an idea of anything that might be left over for the next spacewalk.
That's right.
All right. Well, getting back to today, can you give us, based on all your experience, any insider tips on what to listen for just in the preparations today? We've got a suit here if you want to point out anything that they'll be working on. Tell us what you know from behind the scenes.
Well, okay, so first of all, the crew right now is hooked up on an umbilical that's attached to the front of their suit, and that's providing them with the oxygen and the communications and the cooling. But once they get down to vacuum inside the airlock, they'll remove that umbilical and they'll start outside. And one of the very most important things in doing a spacewalk is making sure that you are safe and that you're attached to station. So they'll have what are called safety tethers attached to them. They're kind of like dog runs. They attach to a part of station and they're allowed to extend out. And that attaches to what are called D-rings, these metal fixtures down here on the suit. You'll hear the crew talk about having two of these hooked together in series, and they'll talk about the hook. So you'll hear them call out a red hook or a green hook, and they're verifying that the hooks are mated and they're attached and that it's locked, and they can verify that it's locked. And the two of them will look at each of their hooks, and they'll communicate how they're connected, and that ensures their safety when they're out there working. You'll also notice that they'll have tools attached. They have a mini workstation that goes into these probes right here, and it has extra tools and extra tethers that they'll be using throughout the EVA, and you'll hear them refer to those tools.
Okay. And it always seems like they've just got this massive toolbox that they have to keep careful track of the whole time. It seems like really that's one of the harder parts of the spacewalk, is just doing the constant inventory to make sure everything's in there and that you haven't lost anything, you know where everything is, it's not going to float away. Is that, I'm thinking somebody in y'all's team is keeping track of that on the ground as well? That's
right. We have experts. We have a very detailed list of what all of those tools are, where they're located, what they're attached to. They're all attached to tethers, so all of them have a hook that's got a reel that'll allow them to use the tool without disconnecting it and put it back again. So you'll hear a lot of discussions about how they're connected.
All right. Well, what would you say that Glenda Brown, who is the spacewalk officer on console today, what is she thinking at this point? What's going through her mind as they get ready?
Well, I think she's making sure that she has all of her procedures ready in front of her, that she's got good communication with her team and with her flight director. She's getting mentally prepared for the first steps that the crew will be doing and making sure that that they're right on track with what they're doing.
All right. Well, we can't ask the crew what they're thinking right now, but Rob Navius did get a chance to talk with them a little while ago before they were making their plans for today's spacewalk. And we're going to take a look at that video next. When we come back, though, we're going to be taking some questions from social media, so send yours in using the hashtag AskNASA. Now we'll take a look at that video from the crew.
As far as worldwide interest is concerned, no shortage of that when it comes to your upcoming spacewalk to install that first international docking adapter to the forward end of the U.S. segment of the station. Tell us a little bit about, first off, the extraction process, how the IDA will be pre-positioned to set the stage for your excursion outside.
That highlights one of the capabilities that has been developed over the years, and that is how we do robotic arm operations. In the beginning, the crew on board did virtually all of the operations, with the exception of maybe just setting the arm up, getting it operational, and then putting it away, so to speak. But over the years, the ground has developed more and more capability, and now they do 90-some% of the robotic arm operations from the ground. And that includes the extraction of this IDA from the external bay in the Dragon cargo vehicle. So they will pluck it out of the bay and they will put it at the very front end of the space station on the pressurized mating adapter where the shuttle used to dock, and approach that PMA and be just very close to it when we go out the door. And as we go out the door, they'll bring it in to within a couple of inches of its mating interface, and then we'll go out there and do the final attachment of the docking adapter, and then of course they'll ungrapple and move it away. So that'll be the big picture of the choreography to get it out there in place, and then of course we'll finish out the installation of cables, power and data cables and whatnot on the IDA itself during the course of the spacewalk.
And in that regard, for both of you, if you could give me a bit of a detailed rundown on what tasks each of you will be responsible for, how you work in tandem, how you work apart from one another to get the IDA actually physically mated to that pressurized mating adapter at the forward end of Harmony.
Yeah, it's actually, we've got the Olympics coming up here, and it's actually a little bit like a synchronized swimming operation. So we're going to work in tandem with the ground teams, and Jeff and I will be going out. We're going to be on clock positions at the IDA. So it's actually quite a huge piece of equipment when you see it up close. It's meters in diameter, and so we'll be holding it from either end of the clock position, and the robotic arm's going to bring it in towards us. We'll continue to bring it in station, and then ground teams are going to do some complicated operations to drive the hooks. That's going to be controlled from our internal crew member, Takuya Onishi. Will be working that, and ground teams will then do some operations to bring that adapter all the way into station and establish that mating compartment, that docking adapter, for future commercial crew vehicles.
Kate, if we can get the mic back to you for a second, this will be your first spacewalk, always a prime milestone for any astronaut. What are your thoughts and expectations? What are you looking forward to the most as you step outside and become a satellite in space?
Well, quite frankly, I'm not sure how the view can get any better than it is from the cupola already. So I don't know that I have any expectations beyond, I can't even conceive of what this is going to be like. In terms of the actual work, we train for hundreds of hours, and there's a huge amount of effort on the ground that goes into this. We have teams in our neutral buoyancy lab that help train us. They weigh us out, so we have all 6 degrees of freedom, and we can learn how to use the tools and all the operations. There's an entire EVA team on the ground that's helped us get ready for this spacewalk and has done the training for both of us for a number of years. And of course, Jeff is experienced at this, but I think I'm just going to rely on the training and the experience that I have on the ground and the preparation that those ground teams have given me. And definitely, we're going to be working hard, but I will try to take a few moments to enjoy it and get a few pictures of this beautiful new hardware that we're adding to the front of Space Station.
And Jeff, for you, this will be your 4th spacewalk spanning 16 years in both U.S. and Russian spacesuits. What sense of history do you have? You're the history buff on board. What sense of history do you have in yet another milestone being added to the chapter of the International Space Station?
Oh my goodness, well, in the context of doing a spacewalk, of course, spacewalks are a big part of the history of the ISS, made it possible. We've, in the program, I think to date have accomplished, going on 200, 180 some or 190, maybe now more spacewalks in the construction and maintenance of the space station. And as you mentioned, in both U.S. and Russian suits, and participants from all of the partners have been in the core of the cadre of astronauts and cosmonauts that have conducted that. So that's a big part of the history. In terms of the IDA, the docking adapter, that opens the door to commercial crew vehicles. And that is the next major chapter on the horizon being developed in the plan to fly. And of course, we don't know what that's going to open up in the future, but it is a significant door opening up in the in the history of human space exploration. That in the context of the ISS, which again is the most significant technological achievement, in my opinion, in history, when you consider the complexity of this thing, how long it's been flying, the international scope of it, the technological scope of it, and then the fact that we sustain it logistically and operationally for so long. And the partnership itself, among all the partners, has never been better, in my opinion. In my experience across the entire program, it's never been better than it is right now. So even from an international relations point of view, I trust that it serves as a very positive example to the world below.
That was Jeff Williams and Kate Rubins talking just a few weeks ago about what they were thinking about getting ready for the spacewalk then, and they are just a little ways away now from beginning that spacewalk. And we're talking with Keith Johnson, who is a spacewalk officer from Mission Control, here giving us an update. I guess we're going to take some social media questions in just a second, Keith, but why don't you tell us a little bit about what they've been doing since we've been talking to get moving their preparations?
Well, we get to watch some of the downlink video that's coming down from the crew, and it turns out that they just put on their backpacks what's called a safer, and it's a jetpack in case of an emergency. In case they come loose, they can recover and get back to space station. They just installed that, and now the Ivy crew member, Anishi Tak, is moving them into the airlock into position so that they can actuate the controls on the panel that provides them their oxygen, and then also open up the hatch. So he puts them in position, and that's what they're doing right now.
Okay. Now, technically, it's scheduled to start a little over, probably about 40 minutes from now. So it seems like they're on time. I know they can go early. Should we be getting ready to watch them go out the hatch?
That's right. They're right on time. It seems to me. Okay. I don't have an open timeline in front of me, but yeah, they're moving right along. They've gotten suited up. The good news is that they passed their leak checks, so the suits are nice and tight from that, and they've got their tools installed, and they're ready to go.
All right. Well, what we're going to do next then is take a few questions from social media. We've got a pretty good lineup for you. The first one is from Thatcher on Twitter, and they are asking, how long does it take for an astronaut to prep for a spacewalk, which kind of covered a little bit, but just give us a rundown again. Well,
again, we've had the long time prep that they've been studying this on the ground and in the swimming pool, so that's years. Mm-hmm. And then, and also part of their training. They've had the weeks beforehand to review the procedures. About a week or so ago, they started collecting all the tools. We send them up a list. They spend a couple hours getting those tools ready, configured. Then they do a suit fit check, which is about a week beforehand. They get fully suited up to make sure everything fits right. And then continue doing their regular space station work while all that's going on. And yesterday they did the final tool check, got their suits ready to go. They start first thing in the morning, getting suited up, and that takes a couple hours, and then we head out the door.
So, Thatcher, depending on how you look at it, it could be months or weeks or hours, but at least hours to get ready for a spacewalk. The next one is from Ed with 2 Ds on Twitter, and they're asking, what new technologies do you think will be incorporated into spacesuits of the future?
Well, that's a good question, and really NASA goes a long way to bring technology in and have people look at new ways to operate. You build a spacesuit to protect you from the environment, but allow you mobility, new materials, new ways of doing that are always being explored.
And I guess one of the things probably that I know they're looking into is actually the time that it does take, being able to get out of the spacecraft quicker so that they can go on spacewalks more often and more easily.
Right. You'll notice that this has taken several hours. They pre-breathe pure oxygen for quite a while. That's because of the absolute pressure that they'll be at when they're down at the vacuum of space. The lower the pressure, the more mobility that they have, but then the longer the pre-breathe is. Mm-hmm. So if you can make materials that are flexible, that allow mobility and all the protection that we need at a higher pressure, then you don't have to pre-breathe oxygen as long, and you can get out the door faster.
But that's not exactly an easy question, right? That's
right, exactly.
Something we've been looking at, but may still be a little ways in the future.
Right.
Let's see, next from Twitter is, and let us know if you can answer this one, does the temperature feel different out in space?
Well, it depends on how you're asking that question. The fluctuations of temperature are quite a bit higher and lower than what we have on the Earth. Mm-hmm. So it gets quite a bit hotter outside and quite a bit colder. The spacesuit has to accommodate those temperature ranges. Mm-hmm. So it's like wearing thermal mittens on the outside, but you also have to have cooling in there so that if it gets really warm, you don't overheat inside. And that's another technological challenge that we face with the spacesuit.
Yeah, one of the many disadvantages, I guess, of being out in the vacuum of space.
That's right.
Next up, what changes need to be made when suits are operating underwater instead of in a vacuum? And I guess that's probably referring to the Neutral Buoyancy Laboratory where astronauts train for spacewalks underwater.
That's a good question, and it's really kind of neat because the spacesuit that we have that they take outside is the same spacesuit minus the backpack that they use when they go outside. So the same soft goods, the same flexible parts are the same in the water. They get a little bit softer, they stretch out just a little bit, in the water, but they still operate the same, which is great because that means the getting into the spacesuit, operating in the spacesuit, and getting out are very similar to what they'll see minus the zero gravity. The backpack itself is different because it needs to be self-contained when they go outside. In the water, we can hook up an umbilical, and we get the cooling and the breathing gas and the communications through an umbilical that connects in the back. But otherwise, it operates just the same as it does in space.
And I'm sure that's really helpful for the crew to be able to have that continuity from the ground and training into the real thing. One more from Twitter, this one from Zach, and he's asking, how has the design of the spacesuit evolved over the lifetime of the space station? Have there been any spacesuits ever replaced on board?
Oh, that's a good question. So the spacesuits were designed to be used originally for the space shuttle, and that meant that they got prepared on the ground, launched up on the space shuttle, used on their spacewalks, and then brought back home again. So that same spacesuit now has to be used for long duration because we fly them up there and they're used over and over again. And we found some challenges with that, some things that we didn't expect. The water quality affected how the suit operated. Throughout the lifetime, they've had to account for that and change. Some of the sensors, we get new technology, we fly up suits that have some of the new parts on them.
Okay, so it's basically the same suit that was designed actually decades ago at this point, but some minor upgrades to accommodate the hardships of staying in space for long periods of time and being in that microgravity. All right, well, that's actually a great segue to our next question, which is during our last spacewalk in January with Tim Coper and Tim Peake, we had a problem with water in Coper's suit. And I know that the team here on the ground has worked a lot to get ready to go back, make sure we can have spacewalks safely and won't have that problem again. Can you tell us a little bit about that process and why we are able to go out and do a spacewalk today?
Well, so the spacesuit takes the moisture that the crew member is producing, sweat, exhalation, and it takes it out of the system and it cools the suit down. And in the process of pulling that moisture out, sometimes some of that water does what's called carryover, and it flows with the gas up over the crew member's face. And in the particular case with Tim Coper, that water concentration sort of was a little bit higher than what we expected. It started collecting, and based on the problem that we had with Luca Parmitano, where the water really started coming over.
That was basically an actual leak, right?
Well, the water was not being pulled out of the system.
Okay.
So it continued to flow through and wasn't pulled out. We have what's called a slurper, and a slurper, and it collects the water and pulls it out of the gas flow and puts it back into the system. And that had kind of clogged up and allowed the water to continue back through the ventilation loop, and it started to pool up inside of his visor. And after that, we took measures to identify to the crew that water was collecting so that we had a problem. And we have what's called a HAP, and it's an absorption pad that's in the back of the helmet.
Okay.
And once that starts collecting water, we periodically, you'll hear us ask the crew members, hey, can you do what's called a HAP check? And they'll lean their head back and see if they can feel moisture in that pad, right?
A HAP check, so we should listen for that today.
That's right.
Okay.
And if it gets cool or squishy or they feel moisture, that means that water is starting to collect in there. Okay. And with Tim Coper, he noticed that water was there. And so he identified that to the ground controllers, and they took action to bring him inside to see what the problem was. It turns out that in this particular case, it might be just a normal carryover, and so we've cleared the suits to allow that to happen. But the crew members that are going EVA today are both aware of that condition and that they keep an eye on it. They'll listen, they'll feel for their suit, see how it's operating, and make sure that if any problem happens that they'll get in quickly. And our ground control team is prepared for that.
All right. Okay, we'll be definitely watching for that today, and hopefully everything will go really well and we won't have to worry about it at all. But what are some of the challenges? We're going to go back to the coverage in just a moment, so we are sure to get the beginning of the spacewalk. But before we do, what are some of the big challenges that for this spacewalk in particular that we should watch for today?
Well, one of the hardest things to do when you're in a spacesuit, and I see you have a glove right here, is operating with a gloved hand inside the spacesuit glove. This has gone through a lot of design challenges and a lot of work, but the primary interface with our crew members and the work site is their hand. The hands get very tired. They do exercises to train for it, and we design gloves that make it easier to do the job, but it's still difficult and it still takes a lot of work. So one of the major challenges for this particular set of crew members is that they're doing a lot of electrical connectors. And the electrical connectors take hand strength and take hand manipulations
to one of those as well.
Yeah, to operate an electrical connector. And with these particular electric...
I'll let you do it.
This is called a NASA zero-gravity lever, and NZGL. You'll hear them talk about electrical connectors, but it's got a lever arm that takes some action to overcome some linkages to pull apart, and the crew members with a gloved hand will pull that and disconnect it. And they'll do this quite a few times during this EVA. So there's a lot of glove action, a lot of hand action, and they're translating around while they're working out there. And all of that makes it challenging for an EVA.
All right. Well, we will definitely watch for that. Hopefully they'll be able to get them all done quickly and easily and go through the spacewalk. Now, we are going to get back to the coverage of the spacewalk, but keep sending your questions in using the hashtag AskNASA. After we come back, once the spacewalk has begun, we'll be talking to an expert on the International Docking Adapter, which is the kind of star of today's spacewalk. More later.
This is Mission Control Houston. You're looking at a view outside the International Space Station of the International Docking Adapter that is seated against the pressurized mating adapter number 2, the former docking port for space shuttles during the shuttle era. The IDA is still in the grasp of the special purpose dexterous manipulator, the Dexter extension to the Canadarm2 robotic arm. The IDA having been extracted from the trunk of the Dragon cargo craft late Wednesday night and maneuvered to a pre-installed position early this morning. Robotics ground controllers pushed the IDA in to a seated position surface to surface against PMA-2. All of this activity occurring while our two spacewalkers for today, Jeff Williams and Kate Rubins, were suited up inside the equipment lock section of the Quest airlock, breathing pure oxygen to purge the nitrogen out of their bloodstreams, preventing any possibility of decompression sickness once they move out into the vacuum of space outside of the hatch of the Quest airlock. A few minutes ago, with the assistance of Japan Aerospace Exploration Agency astronaut Takuya Onishi, Rubins and Williams were moved from the equipment lock section of Quest through the hatchway into the crew lock. The hatch was closed behind them, and Williams and Rubins now have begun the depressurization of the crew lock section. It'll be heading down to 0 for final suit checks and a go from Mission Control to place their suits on internal battery power to begin today's spacewalk. We are expecting the spacewalk to begin just about on time at 7:05 a.m. Central Time, 8:05 a.m. Eastern Time. That's a variable number, nothing magic about that time. The crew is in great shape. Their suits have checked out in superb condition so far, and everything is set for them to move outside and then make their way towards pressurized mating adapter number 2 to fix tethers to the International Docking Adapter that will enable Onishi, working from a control panel inside the Harmony module of the International Space Station, to send commands to close the hooks that will form a hard mate between the IDA and pressurized mating adapter number 2. Before that command is given, Williams and Rubins will be hooking up a series of connectors that will provide hook sensors, ready-to-hook sensor capability, and the hook motor power that will basically drive the IDA's 12 hooks. There are 2 gangs of hooks, 6 hooks per gang. One gang will be closed at a time. It will take about 5 minutes, give or take 30 seconds in either direction for each gang to close. Once the first gang of hooks are closed, the crew, which will have backed away from pressurized mating adapter number 2 to provide a very quiescent and stable atmosphere and environment for the closure of the first gang of hooks. Once that first gang is closed, then the crew will come back onto PMA2 to resume their work to install other equipment on the International Docking Adapter while the second gang of hooks is declared closed. Today's spacewalk, although pathfinding in its nature as it sets the stage for the arrival in the future of the U.S. commercial crew vehicles that are under development, the SpaceX Crew Dragon vehicle and Boeing's CST-100 Starliner spacecraft to be launched in the future. A second spacewalk is in the offing for Williams and Rubins 13 days from now on September 1st, in which they'll venture outside yet again, this time to retract a thermal control radiator that was part of a reconfiguration of the station's cooling system a few years ago, and to install the first of a series of enhanced HD cameras on the truss of the International Space Station. Jeff Williams is in the 154th day of his mission that began with his launch back in March. He will be returning to Earth on September 7th, Kazakhstan time, the night of September 6th, U.S. time, for a landing with his 2 Russian cosmonaut crewmates, Alexei Ovchinin and Oleg Skripochka, in the Soyuz TMA-20M spacecraft for a parachute-assisted touchdown on the steppe of Kazakhstan. Rubins will remain aloft aboard the International Space Station with her 2 crewmates, Anatoly Ivanishin and Takoya Onishi, until they return home on October 30th. For Jeff Williams, he is about to begin the 4th spacewalk of his career. 3 previous spacewalks totaling 19 hours and 9 minutes of spacewalking time. This, of course, will be Kate Rubins' first spacewalk of her career. Williams is EV1, or extravehicular crew member number 1. He'll be wearing the suit bearing the red stripes. His helmet camera designation, once he moves outside, is 17. You'll see that number on the lower right-hand side of your screen once the wireless vision system is activated as the crew is working outside of the complex. Kate Rubins is EV2, extravehicular crew member number 2, wearing the suit with no stripes. Her helmet camera number designation is 20.
5.1. Okay, and I think you're just a little bit lower than I am.
Good.
That means 4.7. Okay. I will take the pump man ISO valve is closed. The pump man ISO valve is closed.
Copy. And switch display to status until leak check displayed. Then hold yes for 2 seconds. Follow displayed instructions.
Copy.
check, holding.
Holding for EV2.
002 actuator to RV.
The depressurization of the crew lock section of Quest has now reached its intermediate point at just under 5 pounds per square inch of pressure. The depressurization will resume a short time from now down to vacuum. Everything is in excellent shape. Good Quest airlock systems, 2 good suits. The crew will verify their suit systems with mission control, as well as conduct final communications checks before they place their suits on internal battery power to mark the official start time for today's spacewalk.
Check complete at O2 EVA, EV2.
Leak check complete. 002 to UVA.
2 solid suits reported by Rubins and Williams in the crew lock.
In EVA.
Good work.
Copy. O2 position EVA.
EV2, O2 position, EVA.
Copy. Locate. Depress pump manual isolation valve to open. Expect our tone.
Press pump and ISO valve is open.
Okay? And I'm gonna open emergency and valve.
Copy.
And the depressurization of the crew lock has now resumed.
T-gauge.
This will take the crew lock down to vacuum and set the stage for the 2 spacewalkers, Williams and Rubins, to place their suits on internal battery power.
Okay. Depress pump manual isolation valve to close.
Copy. Monitoring suit P gauge.
The International Space Station is currently flying 254 statute miles above the Earth in an orbit inclined 51.6 degrees to either side of the equator, having just passed to the south of Auckland, New Zealand, moving from northwest to southeast on a course that will take the complex and its 6 crew members over the southern Pacific Ocean a short time from now.
And Jeff, I'm showing airlock T2.4, probably a couple ticks higher than yours.
Okay. I'll report mine when the car goes there. 2.3 is what I have.
Copy.
Might even converge, they might converge to zero.
They might.
Jeff Williams, along with Kate Rubins in the crew lock section of Quest, just a few minutes away from that portion of the Quest airlock being depressurized all the way down to vacuum, as we are just minutes away from the start of today's spacewalk. Williams, by the way, next Wednesday, August 24th, will surpass the record currently held by Scott Kelly for the most days in space over a career by a U.S. astronaut. Kelly holding the U.S. record of 520 days in space. Williams will surpass that record next Wednesday en route to a total of 534 days in space.
Okay, deep press pump tower is off on the UIA OFS.
Okay. Now you guys can attach waste tethers to the crew lock steering for egress.
Already complete.
Okay. So when the crew lock DPDT becomes nearly zero, you guys expect our tone. When the EV hatch delta P becomes less than 0.5, or you can open the EV hatch. So I will close emergency MPEV.
Okay.
Copy all.
And does the ground want to hear the audit of our daisy chain?
That's affirmative, Jeff. We'll take that. Okay. I will start at the airlock D-ring extender. So I have my waist tether attached to the airlock D-ring extender. It is also attached to my right D-ring extender. On my right D-ring extender, I've got the hook closed, locked, black on black. On the airlock D-ring extender, hook closed, locked, black on black. I also have a safety tether pack attached to my right D-ring extender. The red hook is closed, locked, black on black. The yellow hook is closed, locked, black on black. Green hook is closed but not locked. Tether reels are in unlocked, and I will pass it to Jeff for my blank hook.
And the anchor point of your safety tether pack is attached to my right waist tether. Both hooks, tails are closed. Both hooks black on black. Both hooks are locked. And my right waist tether goes to my right D-ring extender, and that small hook is closed, locked, black on black. I see a good daisy chain.
Concur. And Jeff, ground concurs. Good config.
Copy.
And Jeff will take your tether config next.
And by. Okay, on my left D-ring extender, the red hook, tails closed, hooks locked, black on black. Then I go up to the green hook, it's unlocked, but connected, tails closed. Yellow hook, tails closed, is locked, black on black. And of course my anchor point is attached to my mini workstation right now. Both reels are unlocked.
Good config for you, Jeff. Thank you.
Final systems checks now being conducted by Williams and Rubins in the crew lock section of Quest. Depressurization of the crew lock continues. We're almost at a pound of pressure per square inch, heading to vacuum. Everything proceeding to go on schedule, almost exactly on the timeline prescribed pre-flight. An extremely busy period for both Williams and Rubins, sandwiched in between today's spacewalk and the second one they will conduct on September 1st. Will be an activity a week from today on Friday, August 26th, in which the SpaceX Dragon cargo craft will be grappled by the Canadarm2 and unberthed from the Earth-facing port of the Harmony module, to which it's been attached since July 20th. It will be released, that release time is scheduled next Friday at 5:10 a.m. Central Time. We'll be on the air with live coverage at 4:45 a.m. Central Time next Friday of Dragon's departure. It will move to a safe distance away from the International Space Station, upon which it will conduct a deorbit burn and head toward a parachute-assisted splashdown in the Pacific Ocean at approximately 10:47 a.m. Central Time, 8:47 a.m. Pacific Time, west of Baja, California, returning home valuable scientific samples and other cargo in its pressurized cargo hold.
Kate, are you sipping on your drink break to relieve the pressure?
Yeah, I did that before and had a few sips since then. Thank you.
Okay.
The crew lock section of Quest just about down to vacuum now. Just under 2 minutes from now, we'll be handing over communications between satellites and our tracking and data satellite system. Just for a few seconds, but we should have solid downlink television at the time that the crew emerges out of the Quest airlock. Just to recap, the crew has been right on the timeline since they were awakened just after 1 a.m. Central Time, suited up very quickly, began to pre-breathe pure oxygen to cleanse the nitrogen out of their bloodstreams, did some very light exercise, moving their arms and legs about to increase their metabolic rate and thus create efficiencies in cleansing the nitrogen out of their bloodstreams to prevent any decompression sickness from occurring as they step out into the vacuum of space. Assisted by Japanese astronaut Takuya Onishi and Russian cosmonaut Anatoly Ivanishin, Jeff Williams and Kate Rubins had safer jetpacks, the simplified aid for EVA rescue jetpacks attached to the backs of their extravehicular mobility units. They were moved from the equipment lock section of Quest through the hatchway into the crew lock. The hatch was closed behind them, and we're just about to complete the depressurization of the crew lock.
Sure thing, Kate. It will be daylight when you egress. Copy. Thank you.
The International Space Station is moving from southwest to northeast now, about to enter an orbital sunrise that will carry it across northern Chile.
My DCM is blank.
Copy. Mine is also blank.
Once Williams and Rubins make their way outside, there's their destination for today, pressurized mating adapter number 2, the black structure on the right, and seated against it, the International Docking Adapter launched on the SpaceX Dragon cargo craft, which will be hard mated to PMA-2, and thus the transition between the era of space shuttles arriving at the International Space Station and the future port of call for international, for U.S. commercial crew vehicles that will be launched in the years ahead.
Happy hatch opening in work.
The crew now about to open up the hatch. We've reached vacuum in the crew lock. There's the outer thermal cover having been opened. And the hatch in the Quest Airlock's crew lock is now open. The hatch open at 7:03 a.m. Central Time, standing by for the crew to place their suits on internal battery power.
Okay, I'm going to close emergency MPEV. Okay, emergency MPEV is closed. Now we can move on to a post-depress desk section.
Okay.
Copy in post-depress section.
Copy that. Kate and Jeff, this is Tom. How do you read?
Hello, Tom, loud and clear.
Hey, Tom, I've got you loud and clear. Nice to talk to you.
Good to talk to you. On your DCM, you're going to be switching your power to bat and stagger your switch throws. You can expect a warning tone.
Spacecraft communicator now for the rest of the spacewalk, veteran astronaut Tom Marshburn.
CB1's in bed.
Copy. Check your display switch is functional.
Functional.
EV2 functional for both yes and no.
Copy that. Kate, on the UIA, switch power EV1 and 2, 2 switches to off, and check the 4 LEDs are off.
EV1 power off, LEDs off. EV2 power off, and all 4 LEDs are off.
Copy, Kate. For you both, you can disconnect your SCU from your DCM, install the cover, and stow the SCU in the pouch.
Copy.
The suit's now on internal battery power, marking the official start of today's spacewalk at 7:04 a.m. Central Time, 8:04 a.m. Eastern Time, 1 minute ahead of schedule, actually. Again, the start of today's EVA officially underway at 7:04 a.m. Central Time, 8:04 a.m. Eastern Time. The spacewalk beginning as the International Space Station flew over the southeastern Pacific Ocean, heading towards the coast of Chile.
EV2, SCU disconnected, cover reinstalled, and SCU in pouch.
There's EV1.
We copy. Kate, to check the depress pump manual isolation valve is closed.
Copy, and stand by when the SCU needs to go firmer in the pouch. Okay, Tom, the depress pump and ISO valve is closed.
Copy, Kate. For you both, on your DCMs, take your temp control valve to max hot.
Copy, next set.
V2 max hot.
I'm still going there.
And switch the water to on.
And high.
Tom Marshburn choreographing the preparatory steps for Williams and Rubins before they make their way outside of the Quest airlock. Williams will be first out, followed a few minutes later by Rubins.
Copy. Check your DCM is blank. The bite is off.
DCM is blank, bite is off.
V2, DCM blank, bite off.
And for you both, temp control valve between 3 and max cold.
I just said about 4.
Copy, and EV2, 3.5.
We copy on both, and we just need your pressure gauge reading at this time.
4.3 EV1.
EV2, 4.4 on the CP gauge.
We copy all. Just check your visors to come out in daylight and your go for egress.
Copy, egress and work, visors down.
Jeff, I see good egress. Your tools and tethers are clear of the hatchway.
Copy.
His first spacewalk occurred on May 21st, 2000, outside of the shuttle Atlantis on the STS-101 mission. More than 16 years later, Jeff Williams now begins the fourth spacewalk of his career outside of the International Space Station.
Those serial numbers 0016 and 0019.
Okay, Jeff, the bag's coming towards you. The handle.
Copy that, talk. Those are good numbers.
I will store all canisters in storage node.
Copy, talk.
Red on it. I'm going to release your red.
Copy. And the large small ret that was on the item medium or U-bag is on the airlock D-ring extender.
Jeff Williams as EV1, as you can see here, just outside of the hatchway of the Quest airlock, as he will receive a bag of equipment from Kate Rubins, who's still inside the crew lock of Quest. She will be joining Williams outside just a moment or two from now.
The BRT ret.
Got the RU bag on my BRT.
And Kate, we believe that large small that's on the D-ring extender in the airlock is the one you wanted to keep with the bag for stowage at the work site.
Well, per our plan, we have a large small on the bag and one large small in the airlock.
We copy. So Jeff, you'll be attaching your safety tether to the airlock circular handrail forward outboard tether point.
Copy.
Once Rubins has joined Williams outside, they will take an inventory of all of their equipment before they make their way towards a spare parts platform just adjacent to the Quest airlock called ESP-2, or External Stowage Platform number 2, as well as towards the Columbus module of the International Space Station, the European Space Agency Laboratory, to collect a pair of portable foot restraints that they will affix to PMA-2 as their work site to begin the process of hooking up connections and tethers for the international docking adapter and the precursor to the commanding of the hooks to be closed to form a hard mate between the IDA and the PMA.
The yellow hook is closed, hook is locked, black on black. The green hook is connected, unlocked. And the red hook on my left, D-ring extender, tail closed, hook locked, black on black. Both reels are unlocked.
We copy, Jeff. Thanks. You'll be attaching Kate's safety tether to the forward airlock D-ring.
Copy. I break the daisy chain.
Copy.
Your safety tether back anchor point is connected to the forward D-ring.
Confirm that's locked, black on black.
Hook is locked, black on black, bail's closed.
Okay, copy. And starting from inside the airlock on the airlock D-ring extender. I still have my waist tether. I'll wait for your go. And Tom, on my right side, on my right D-ring extender, red hook, closed, locked, black on black. Yellow hook, closed, locked, black on black. Green hook, closed, but not locked. and both reels are in unlocked.
Good config on both. Thanks much. So, Jeff, when you're ready, Kate's go for egress.
Stand by just a second.
Copy.
Okay, Kate, come on out.
Okay, copy. Keep my waist feather off the D-ring extender. And the view is phenomenal. And Jeff, thank you. I've got one green WBS light for you. I can see your 2 safer handles are down, and 1, 2, 3 tabs up. Your tools are in a good configuration. I see the bag on a ret on your BRT. True check from me.
Okay, I have 1 light on you, got 2 safer handles down, 3 tabs up. Safety tether, checking that config. I see a good config. Tools and tethers, good. I see a camera installed. I'm going to ask you for one little assistance here.
Absolutely.
See this waist tether? It wrapped around down below the BRG in the wrong direction.
It is.
Okay.
The 2 spacewalkers checking each other's tethers. Kate Rubins is just about to float out of the hatch. They'll close the thermal cover behind them and then begin to make their way towards pressurized mating adapter number 2.
And we'll take a HAP baseline check from you both, too.
HAP is dry, EV1.
Okay, I've got a good baseline HAP check, and I have a look at my gloves. They are pristine. Put in my translation adaptations.
As are my gloves.
The HAP is the acronym for the Helmet Absorption Pad. This was installed in all spacewalking helmets for U.S. astronauts in the wake of a water intrusion into the helmet of European Space Agency astronaut Luca Parmitano during a spacewalk a few years ago. Kate Rubins now outside of the Quest airlock.
Thermal cover's closed.
Jeff, as you know, when you're ready, you'll be leading out on ESP2 around the outboard end there and pausing for Kate as she goes over the top of ESP2.
Copy. And I'm going to work my way up.
A moment or two will be spent by the crew members to orient themselves, conducting a few small translations and a few yaw and roll maneuvers just to get the feel of the environment outside.
Crossing over to ESP2. How's my ORU bag behaving back there?
It looks good. It's behind you down towards your leg on your lower left.
Okay.
And I see your safety tether strung out nicely. Singular handrail. I'm going to continue to ESP2.
Copy.
Station Houston on space to ground 2 for talk when convenient.
It's on my right arm and the safety tether.
Yeah, that's behind your back.
It's known configuration.
Okay.
Sounds good.
Good. Here's your AFPFR, just as promised.
Excellent.
Williams and Rubins in the early process of collecting portable foot restraints.
I'm on the top of
This now our first view from Jeff Williams' helmet camera. You can see very faintly the ghostly number 17 in the lower right-hand corner of your screen. That's Williams' helmet camera. Kate Rubins' helmet camera will be number 20.
I'm local to the Fram handrail.
Kate, we'll have APFR pre-configure settings for you when you're ready.
Okay, copy.
These portable foot restraints will be affixed to two locations on pressurized mating adapter number 2, both on the space-facing side and the Earth-facing side of PMA-2, to enable the two crew members to work at those interface work sites in tandem.
That is a good setting, and Delta 1.
The International Space Station is passing over the southern Atlantic Ocean, just to the east of the European Space Agency's launch site in French Guiana.
Delta is set. And 1 is set.
We copy all, Jeff. Thanks.
Give me a second, Jeff. I'll get my BRT ready.
Yeah, but
Okay. Here's the ret hook from BRT.
And now a view from the helmet camera of Kate Rubins as she begins to set up her tools and equipment outside the International Space Station.
okay. Ready to release?
Yep, the jaws are locked and closed on BRT.
There you go.
And if you can check this BRT on my side here, it goes down.
And that thing will have quite a bit of inertia, so if its BRT is loose, it'll move around.
Copy.
Ready for me to goodbye?
Yeah, just check the profile here. I think that's good. Yeah, I'm ready for you to come by. I'm standing by on the SP2.
I'm going to release my local tether. Head on out.
Copy. And as you're passing by, your config looks good, and your medium or your bag looks good.
Thank you. The gap spanner.
And I'll wait until your safety tether is stretched across the hypotenuse before I start my translation.
Okay. Heading forward.
We're following along, guys. And Jeff, you know you've got that fair lead at the bottom of the camera, Stanson.
Copy.
A good view of Jeff Williams moving towards the work site at pressurized mating adapter number 2 on the left side of your screen. Kate Rubins on the right side of your screen. For those just joining us, today's spacewalk, the 194th in support of space station assembly and maintenance, officially began at 7:04 a.m. Central Time, 8:04 a.m. Eastern Time, when Williams and Rubins placed their suits on internal battery power in the crew lock section of Quest. A few minutes later, they made their way, Williams first, followed by Rubins, outside of the hatch into open space with their full complement of equipment that they will bring towards PMA-2 to begin the work to hard mate the international docking adapter to the pressurized mating adapter that has been the docking port for space shuttles in the past, the IDA to be the docking port for U.S. commercial crew vehicles in the future.
And Kate, just a reminder to check your safety tether as it comes across ESP2. That's where you want it.
Okay. And do you want it outside of the pump module here? Or is it okay to have it inside? Now it's coming backward and forward of the pump module.
Okay. Starboard and forward. And it'd be best, we think, if it were clear of the pump module.
It's on in work.
And Tom, I like your plan about the real fair lead, not the plumbing.
Copy.
And Tom, it's going to take a lot of work to get it over the top of the pump module, and there's not a lot to translate on there. So if you guys are okay with it going in space, I'll leave it in that configuration.
We copy, Kate. And just keeping that in mind, if you're happy for any contingency return, then we're happy.
Yep, I understand well where it's routed.
Non-fair lead, the handrail 0274.
We copy, Jeff.
Copy, Jeff, and I am working my way zenith on the lab.
Copy. I'm just getting a note too.
And Kate, as you're translating, just a caution for you. There's an EWC antenna, handhold, antenna forward on the lab end cone, and you should not use that as a handhold. Just be careful for it.
Copy. Thank you for the reminder.
Tom Marshburn, the spacewalk communicator here in Mission Control, cautioning Rubins to stay clear of what he called an EWC antenna. That's an external wireless communications antenna that provides the helmet camera views from the two spacewalkers throughout the course of their excursion outside.
We'll go.
Hey, Tom and Jeff, I've got down to the port side of the lab, and I am heading forward.
Copy, Kate.
And I see you, Jeff. I see you forward.
And Kate, as you know, you're going to be routing your tether port of the wet antenna on node 2 and the trunnion pin on node 2 as well.
Copy, I see it. I'll drop my green hook right where that trunnion pin is.
Copy. Now's a good time. I'm going to read some warnings and cautions for you both. On the PMA2, avoid contact with glass targets and potential sharp edges. And a reminder, PMA2 surfaces may be hot, so limited contact is needed. And then finally, avoid inadvertent contact with the forward face of the peripheral docking target and the planar reflectors as well.
Copy all.
Copy, Tom.
And I've dropped off my green hook and handrail 0315.
We copy, Jeff.
At opposite ends of the Harmony module of the International Space Station, Jeff Williams on the left side of your screen, Kate Rubins on the right, as they again are making their way towards their respective work sites along PMA or pressurized mating adapter number 2. At the top of your screen, the Columbus module, the European Space Agency's laboratory. The Japanese Kibo module is in the lower left-hand portion of your screen.
Tom, I am routed port of the red eye antenna for my safety cover.
Copy, Kate. Thank you.
Copy, Kate. And Jeff Williams now has made his way to pressurized mating adapter number 2 and the international docking adapter that is seated against, surface to surface, against PMA2.
We have handrail numbers.
Not long from now, the hooks will be commanded to be closed. That will hard mate the new docking port to pressurized mating adapter number 2.
We see that little box shaped by 405, 6, and 9.
The first one?
It should be zenith on the PMA, handrail 405, 406, and 409.
Copy.
And I see you setting up the bag there, Jeff. I'm going to put my green hook on 0318. Safety tether is routed underneath the trunnion pin.
Copy.
Houston Station on Ground 1 from ID crew. IDA control panel verified safe. Go for initial cable install.
Takuya Onishi inside the Harmony module of the International Space Station, confirming that the IDA control panel, from which he will send commands to close the hooks between the IDA and the PMA later in this spacewalk, is all set to receive those commands. Cable installed, the control panel at the ready. Once the crew has completed the mating of several connectors between PMA2 and the IDA that will enable hook closure power, hook sensors, and heaters for the IDA.
And Kate, it's up to you if you want to pick up your cap keeper.
Okay, we're going to have to get the bag installed first, so I can drop off my APFR and be a little more maneuverable, and then come assist Jeff.
That sounds good.
And Kate, we'll take a glove and hap check for you before you put that in work.
Okay, copy. Gloves are good. No change from baseline. Cap is dry. No change from baseline.
We copy all. Thank you.
Jeff, I headed forward and nadir on PMA 2.
Copy.
Kate Rubins now having joined Jeff Williams on pressurized mating adapter number 2. They will attach adjustable tethers to a series of handrails on the pressurized mating adapter number 2. Those tethers then will be extended to the international docking adapter to be able to cinch it into a soft dock configuration, if you will, to set the stage for the commanding of the closure of the hooks once these power and data connectors are hooked up between the two components. 31 minutes into the spacewalk, the crew is right on the timeline, performing very efficiently.
And then come and pass you before I head major.
Okay. I've got 3 hooks down on the bag.
Copy.
And a reminder for you both to avoid putting loads into the IDA. Do not translate on the IDA.
Copy.
Copy.
I am headed to WIS 1. We're clocking 6 on the APFR.
That's a good copy, and it's the nadirmost of the widths you see there.
I got my BOT red off the bag.
The spacewalk team here in Mission Control reports the crew is running about 10 minutes ahead of the timeline.
Good morning and welcome back to our coverage of the U.S. Spacewalk number 36. It's already started, as you've seen if you've been watching. 7:03, the spacewalk officially started, and we're going to take a break now while the spacewalkers, Kate Rubins and Jeff Williams, are getting set up to talk a little bit more about what they're installing today, the International Docking Adapter, which is going to open up the International Space Station to our commercial crew partners. We're going to start by finding out a little bit more about that, going back to an interview that my colleague Pat Ryan did with Sean Kelly, a senior programs manager here at NASA, talking about what exactly the International Docking Adapter is.
So we developed the International Docking Adapter post-shuttle because the docking system that we used as part of the shuttle program was a proprietary system. It was of Russian design with NASA influence on it to adapt it to the Space Shuttle orbiter. But it was also something that was unique to the Russian company that built it, Energia. At the same time, we were already looking ahead to exploration. As part of exploration, we were very interested in developing some international standards. One of the leading international standards was the International Docking System Standard. The participants for that standard are all the current International Space Station program participants, Russia, ESA, CSA, JAXA, Canada, and of course NASA. And it was a collaborative effort to develop a new interface standard that would be out in the public sector and available to anyone and everyone that wanted to build to that interface standard. We felt that was a good, empowering way to stimulate competition, stimulate technology and different ways of looking at things, since we are entering a commercial sector now. And as part of that, you can actually go out to internationaldockingstandard.com, download the interface standard, and any company in the world, any country in the world can build to that interface standard and be assured that they'll be compatible with this.
When the first IDA was lost in a launch accident, the second one had already been built by Boeing at a facility here in Houston and shipped to the Kennedy Space Center. And that's the one that has just arrived on orbit. What was the plan to provide a replacement for that first one?
One thing that NASA is excellent at is contingency plans. So we actually had contingency plans in place in case something happened. We also had plans in place in case we needed a third docking adapter. based on the International Docking Standard and the interest in developing new docking systems, and also the potential that we could add new participants in the future. Certainly, the space station has grown, and the interest in the space station has grown across the world as far as participation. So we'd also had plans to, if we needed to, build a third docking adapter. So we had adequate structural spares available. We didn't have enough spare parts to build a complete international docking adapter, but we identified the spare components that were going to be the long lead time and made sure we had those on hand. Had we not built a third docking adapter, those would not have gone unused. We would have used them for some of the qualification programs of these new docking systems. So either way, we were in a good position to make sure that we get good value for the taxpayer out of those structural spares and those spare components that we had for IDA.
The plan is, I understand it, is that the first users of this would be the commercial crew partners that NASA is working with, Boeing and SpaceX. Those are both American companies. Why do we call it an international docking adapter?
Well, there's really two reasons, and that's an excellent question. The reason we call it the International Docking Adapter, first and foremost, is because it's the first implementation of the International Docking System Standard. We're fully compliant with that international standard. NASA wanted to lead the way. We also see the potential for other international partners to come to the International Docking Adapter. Part of the thought behind naming it the International Docking Adapter essentially was to advertise to the community that we are open for business for additional international business. And of course, you mentioned the commercial crew. They are likely to be the very first users of the new International Docking Adapter, and that also helps stimulate commercial enterprises because a U.S. commercial company is building the first one for their vehicle, Dragon. SpaceX is designing their own system, building their own system. We also have Boeing under contract to build the NASA docking system, which will go on the Orion vehicle and support exploration. So the International Docking Adapter configuration is fully compliant with what our plans are for exploration. So in many ways, we're laying the groundwork, and it's really the gateway to the future of exploration and cislunar activities.
Describe where on the station the two IDAs are going to be installed and what kind of flexibility that affords the station program, station operators.
Yes, so these international docking adapters get installed on the PMAs, the two PMAs that we have available, PMA 2 and PMA 3. PMA 2 is currently located on Node 2 Forward, and that will be the final location for the International Docking Adapter 2 that's going up on SpaceX 9. It's already, as you know, berthed up there, and we're looking forward to the activities to extract it, robotically extract it, and start the installation of that. And then we're going to be moving PMA 3 and installing that on Node 2 Zenith. And that will be the final location for the second active docking adapter that we have on board, IDA 3. Right now, the current plans are to launch that on SpaceX 14, but we have some flexibility on that. We only need one international docking adapter up there to support the initial crew activities, commercial crew activities. At a later date, when we have multiple commercial crew vehicles and potentially cargo vehicles that will use docking, we'll need a second docking adapter at that time. So we have some flexibility on the schedule, both for the launch and also for moving the PMA 3 to its final location.
And then this would, you have then 3 different potential locations for vehicles to dock there at the front of the station.
That's correct. That's absolutely correct. So that creates a lot of flexibility for the program. When we look to commercial cargo, under the CRS-2 commercial cargo contract, NASA's asked the providers to provide an option for docking. So today, cargo vehicles all berth to the International Space Station, but we are also trying to allow an option for those cargo vehicles to convert to docking. So hence the reason why we may in the future actually need a third docking port if we do decide that docking is the way of the future, and we can work on some automated rendezvous and docking techniques for this on the space station. Then we'll be in good shape to consider a third docking adapter and still have berthing and docking available for our program.
Be very exciting to see it finally get ready to put in place.
Absolutely, absolutely. This been a very active activity. It's an activity that spanned across numerous states in the United States. I think at last count there were 28 states that contributed components to the space station international docking adapter. So that's pretty exciting. That's good activity for the U.S. And also we obtained some of the structural components from Energia. So this really is a worldwide effort. Because of the international participation in the International Docking System Standard, this really is something that numerous partners are very excited about the opportunity to see this installed and the opportunities it'll bring for docking to the space station.
Now, only a few weeks away, so it'll be exciting to see it happen.
Very few weeks away. Looking forward to it.
Learning more about the international docking adapters coming to the International Space Station with Sean Kelly, NASA's Senior Project Manager in the Development Projects Office.
Welcome back. That was a look at exactly what the IDA, or the International Docking Adapter, is, and we're going to find out more from Dave Clement, who's joined us here in the studio. He is the Boeing Director for Space Station Development and Modification Projects.
Morning.
But just real quick, one reminder that if you want to watch the uninterrupted EVA or spacewalk coverage, you can also watch that online at nasa.gov/NTV. But we're going to learn more about the IDA from Dave here. Thank you so much for joining us.
Glad to be here.
All right, why don't we start by letting you explain what your title is. What does a Director for Development and Modifications do?
Well, good question. I have the privilege of leading the teams that develop new hardware to support either modifications of existing systems or new capabilities like the IDA, the NASA docking system, that support the on-orbit ISS. Aside from IDA right now, we are in the process of, we've already delivered the first set of lithium-ion batteries that are packed and stored on an HGV-6. We've developed the nitrogen-oxygen resupply tanks that were required once we retired the shuttle. And of course we have the upcoming NASA docking system as well. So those are the kind of projects, as well as any kits, modifications, cables, anything needed to support the on-orbit ISS evolving needs.
Okay, so even though we basically could consider assembly complete on the space station, there's still things that are changing, and you're watching out for those, making sure they all work like they're supposed to.
Absolutely, and like I said, obsolescence, as obsolescence occurs, we look for new technology to implement new technology, provide evolving capability like wireless access ports that can be used by the crew.
Okay. All right. Well, so I guess a great example of that is the IDA, the International Docking Adapter. I know that that's the main thing we've been talking about, is that's going to allow commercial crew vehicles that are being built right now by SpaceX and Boeing to dock to the space station, and obviously that's a big deal, but it doesn't really end there. They're not the only ones who will be using that, right?
That's correct.
Tell us a little bit about that story.
Well, I think the International Docking Standard that was developed, that IDA was the first item built to, is not just for ISS. It's intended to be used for future spacecraft to allow docking, either at cislunar or to spacecraft to allow them to dock, whatever the mission, whether it's ISS, whether it's any other future exploration missions. It sets the standard that allows all those things to occur in the future.
And I'm guessing it was a lot of work to get that standard set and ready to go if so many people are going to be using it.
Oh, absolutely. It was a large collaboration that took a long period of time to work out through each and every detail. So a lot of details when you're talking about interfaces, that not only the mechanical interfaces, but all your electrical communication interfaces. Everything has to be precisely documented to ensure that when you don't have the opportunity typically to put these things together on the ground, so that they must work when they get on orbit.
That's important. So how long would you say you've been working towards this?
Well, there's been various configurations and concepts of the International Docking Adapter, as well as the NASA docking system that have been going on really even before the shuttle retired. But in earnest, we started this probably 7 years ago now. I'm going back a little bit, where we started the first collaboration on the standard. The standard was released and signed, and continues to evolve as we talk about more additional capabilities. We still have fluid capabilities to add in future revisions to the document, but it's been a long period of time.
So it's a little bit of a change in concept, right, for somebody besides the government to be building a docking adapter. Can you tell us a little bit about that philosophy change, why we went that way, and what it means for the future?
Well, as you noted, that this is the U.S. has always made use of the autonomous, or what we used to have, the androgynous pressurized adapting system that allowed the shuttle to dock to the station. And that was a Russian product. That product is no longer really what's needed going into the future. So when the U.S. decided to build their own product, they made use of that, much of that technology, modernized it, and it was certainly a challenge. And it makes sense that if we're going to go forward with the commercial space, that we have a product, and that the commercial providers are allowed to build their own products as well.
So I think you told me previously that basically you can go online and get anybody, I could, and somebody who's actually going to build a spacecraft could, go online and get the standards and build your docking system to that standards. Anybody could do that. Absolutely, that's intended, and like I said, it took a long time to make sure that was a possibility. The details were in there it took a long time to make sure that anybody that really was intending to build something had every detail they needed to be successful. Okay, well, that's really cool. But one of the things that's interesting about this hardware in general is that not only does it let anybody dock to the space station, but they can do it without having to basically bother the astronauts who are already on board the space station, right? It's autonomous. Absolutely. That's the best feature. That, you know, typically when you bird, it requires the use of the robotic arm to capture the vehicle and then bring the vehicle in, drive the bolts, and then make all the connections for data, power, and communications. When you come and you dock, as the vehicle docks, it's equipped with umbilicals that, as you dock, those umbilicals are mated, so you automatically have all your power, all your comm, all your data connections made without any actions by the crew. Compare that a little bit to what the other forms of docking and berthing on the space station. How is that different from what else we see? Well, like I said, berthing on the USOS side requires the use of the robotic arm and active participation by the on-orbit crew. So that's just kind of a terminology difference there, right? Docking is a spacecraft comes in and connects directly to the space station. Berthing, it comes close to the space station, then we grab it with the robotic arm and bring it in to connect. Correct. It has a little larger envelope in berthing. Where a docking system has the tunnels a little smaller, but it's allowed for egress of the crew. It's mostly intended for crew ingress and egress. Okay, getting in and out of the vehicle. Right, whereas berthing was, you could bring large racks or something through that tunnel, so it's a little bit larger tunnel. Okay. There is docking capability on the Russian segment right now, but it uses a probe and cone system, which is a different system than the docking system that we're employing now. And what does this docking system use? This docking system uses essentially a steward platform that has when the vehicle approaching will essentially extend a soft mating platform. It will make contact with the docking system. Once contact is made, it allows the vehicle momentum to settle out, and then it essentially pulls itself in and then drives the hooks and does mating in that. Don't forget, we have this that might help you talk a little bit about exactly what's going on. This is a 3D printed model of the IDA, the International Docking Adapter. That's correct. And so this is the station site is being installed today. And then when host vehicles come up, like I said, they have essentially an active element that will mate with this softly dock capture. And then they have their own set of mating pedals. And the pedals will drive into and align the two spacecraft such that the hooks can be driven and mating is complete. And the same thing with these umbilicals. Like I said, the importance of these umbilicals is you align the approaching visiting vehicle such that these umbilicals are mated and you have power and all your data, like I said, as soon as you dock. It's like plugging in a plug into the wall. It's
absolutely done. It's like driving in your garage. Okay, well, tell us a little bit about what some of the standards that the companies build to are. What are some of the options for how what's the
what's the range of choice there?
Well, I think that a lot of the features in International Docking System Standard also we had to consider feature vehicles and what their capabilities would. And so there's a lot of targeting standards. Various vehicles use different guidance and navigation systems to come to dock. So we have hemispherical and planar reflectors, as well as peripheral docking targets that are made use by the navigation system of the approaching vehicles. All those standards had to be established and without knowing exactly what those vehicles were going to use. So I think that was a real big challenge.
Oh, okay. All right. Well, I think we have some social media questions for you.
Okay.
And if you would like to send in a question for us to answer on air, you can use the hashtag AskNASA to send that in, and we will try and get those answers to you. But for now, what we've got, Nor on Twitter wants to know how much the IDA weighs.
It weighs 1,020 pounds.
1,020 pounds. So that's what Dexter had to pull out of the trunk.
That's correct.
Of SpaceX earlier this week and get into place, and that's what they'll be installing. Another one from Liz is asking, where is the camera located that's giving us the view of PMA and IDA from the side? And I don't have that view up right now, so, oh, here it is. It's behind us. I'm guessing that could be from the robotic arm. I don't know if you would have any insight to that. But
no, I don't.
Yeah. And then another one is, what do you think is more difficult, installing it on the space station or bringing it to the space station to begin with, and why?
Well, I hope it's bringing it to the space station.
It's all smooth sailing from here.
That's right. It's certainly intended to go together and fit like a glove. And you know, the folks that orchestrate the installations, it may look easy, and they always make it look easy, but it takes a lot of planning by a large number of people to make sure every step and every consideration is taken into account. If there's an issue that should occur during the installation, all the contingencies are examined. So there's a whole host of people and teams that carefully orchestrate this. So I believe that installation, as you've seen with almost every operation on ISS, it looks easy, but it's not.
What about the setting up of the standards? What were some of the challenges there?
I think a lot of the setting up of standards was understanding that the standard was built a lot on the legacy APAS system, like I said. And because of that, you had to really understand what were the requirements for radiuses, the tight tolerances. Really had to be examined closely on not only why were they why were they the standards, why were they the tolerances, but also were the same tolerances that we're going to need in the future. So I think that was the most difficult, was really getting down to establishing the tolerances and every specification for every angle, every dimension, especially on the mating faces.
Yeah. Well, I know that even after you got all of that settled and the adapter was actually built, getting the space station ready to receive it has also been a challenge. I think you told me it was like having a house and then deciding 15 years after you built it that you wanted to move the garage to the top floor and the master bedroom to the side. And explain a little bit about that.
Well, that's true. You know, originally the station configuration didn't allow for these ports to be available. And with the retirement of the shuttle, you had the PMAs, which were used for shuttle docking, and the agency wanted to make use of that hardware and repurpose it. To do that, it took quite, like I said, imagine not only remodeling your house, but doing it while you're living in it and still operating it. So we built a series of kits that were carefully orchestrated such that when the modifications were made by the crew, they only had to go into one area one time. So if they were going to go pull off sidewalls and make additional connections of new cables, route new cables, new plumbing, then they'd only have to go in there one time. So that's what really drove the complexity and how we built the kits, so that essentially it went together like a Tinker toy. And it was truly something to behold, because a lot of the reconfigurations that have gone on over the life of the station had to be known, so that, like I said, you could route the cables around the other cables every time, make all the connections you needed to make sure they could be, the crew could get in there and had access to it, and that they would go together the first time, because you're rerouting power and you needed to pull down systems for only a brief amount of time and then reconfigure them. So it was really a challenge.
Okay. Well, getting close to the end of that part of the challenge, and then I'm sure you'll have some more work to do to get the next IDA 3 up to the space station and installed, coming up pretty quickly, too.
Yes, very quickly. We're completing this initial assembly of the IDA 3 at KSC, and then we'll begin, of course, the rigorous test program to ensure that it's ready to put into the next SpaceX 14 launch and have another successful installation.
All right. Well, can't wait to see it installed today, and then even better to see it used in the future. Thank you so much for joining us today. We really appreciate it.
I appreciate it. I enjoyed it myself. Thanks.
All right. Thank you. And that is a great segue, actually, into our next feature that we're going to take a look at the road that got us here and ready for the spacewalk, on the road to IDA, basically, looking at the work that has come before to get ready for the installation of the International Docking Adapter.
Over a period of 4 spacewalks in 2015, NASA astronauts laid the groundwork for the installation of the first International Docking Adapter, or IDA, on the International Space Station. The first 3 spacewalks were conducted by Butch Wilmore and Terry Virts, who unfurled hundreds of feet of power and data cables needed for not only 1, but 2 docking adapters that will serve as future docking ports for U.S. commercial cruise spacecraft in development by SpaceX and Boeing. Saturday, February 21, 2015, focused on pressurized mating adapter, or PMA number 2, to which space shuttles used to dock, and where the first IDA is being attached as the primary docking port for the first commercial crew flights. Working on the forward end of the Harmony module, Wilmore and Virts played out 10 different cables in some of the most labor-intensive work in station history. After unfurling the first 8 cables and prepping the last 2 for the next spacewalk, the crew members called it a day. 4 days later, on February 25th, the pair headed back outside and routed the remaining cables to PMA-2. With their primary job complete, the pair split up for additional station maintenance tasks, including preparations for the relocation of the permanent multi-purpose module as part of the reconfiguration of the station to accommodate commercial crew vehicles. After another 4-day breather, Wilmore and Virts suited up one final time to install the Common Communications for Visiting Vehicles, or C2V2 system, a relay system for data and communications between approaching commercial crew vehicles and the station itself. Working in tandem, the NASA spacewalkers hoisted 2 antennas on the station's truss structure before routing 4 separate 100-foot cables to a single connector located on the U.S. Destiny laboratory. Then, last December, right before Christmas, astronauts Scott Kelly and Tim Kopra took up the cause, routing yet another cable that will be used for the installation of the second of the docking adapters to the space-facing side of Harmony. The 2 docking ports will provide redundant parking spaces for U.S. commercial crew vehicles that will augment the transportation of astronauts to and from the orbital outpost and the expansion of research capability on the International Space Station.
As you can see, it's been a long road to get to today's spacewalk, and the spacewalkers, Jeff Williams and Kate Rubins, are making good progress and about to start getting to work on actually connecting the International Docking Adapter. So we're going to go back to that coverage here in just a second, but a reminder first before we do that if you have questions today, you can send them to us using the hashtag AskNASA. We'll be answering those throughout the day, and also astronaut Doug Wheelock is answering them via Twitter as well. And if you want a behind-the-scenes look at today's spacewalk, you can follow NASA on Snapchat to view a special Snapchat story, or take a look at ISS via Instagram. We're going back now to coverage of the spacewalk ongoing.
This is Mission Control Houston at the 1-hour mark into today's spacewalk. As Jeff Williams at the top of your screen and Kate Rubins on the bottom of your screen are continuing work to hook up adjustable tethers to worksite interface points at the Earth-facing and space-facing sides of the pressurized mating adapter number 2. They are in great shape so far. Their spacesuits are functioning perfectly as we are reaching the critical point of today's spacewalk that will result in the hard mating of the international docking adapter that you see, the white circular component that is still grasped by the special purpose dexterous manipulator at the end of the Canadarm2 robotic arm.
All the connectors.
Copy, Jeff. We got copy, Jeff, and we got a couple of cleanup steps for our timeline for you. I think we dropped out for your AFR final setting. Did you get Delta 2?
I did.
Copy. And
when I get back there.
And just want to double check your double adjustable tether, whether that's installed or not.
It's not installed. I'm pulling it out right now.
Copy.
And I'm on handrail 0414 conveniently.
And that's the one, the forward tether point.
The two spacewalkers, Jeff Williams in his fourth spacewalk of his career, Kate Rubins in her first spacewalk. They're at the point of their timeline in which they're attaching these tethers to stanchions on pressurized mating adapter number 2. This is the precursor to the point at which they will take a handoff of international docking adapter.
We copy, and we have a nice view of the panel there, and as long as the cap keeper in your cable bundle is nicely accessible to you, it looks really good.
Stable so far, and I was able to keep my waist tether on the PMA handrail, and had a good ingress with no loads in IDA.
This connector panel you're looking at on the side of the international docking adapter will receive a variety of power and data connectors a short time from now. Those are required before the hooks are driven closed from a control panel inside the Harmony module by Japan Aerospace Exploration Agency astronaut Takuya Onishi. These initial power and data cable connections to that connector port on IDA, the International Docking Adapter, will provide hook motor power, the ready-to-hook sensors, and heaters for the new docking port.
Remove a little bit of slack and just make sure there's no twists.
Copy. And my double adjustable equipment tether is installed. Do you have video, by the way?
We have good, yes, we were able to recover your video. We have good video on both.
Okay, good. And you can see I have it installed. Now I'm going to go retrieve my cap keepers.
Copy, Jeff.
Oh, and they're almost banging me in the head here.
They disappear, huh?
Yeah, love it when that happens.
Like IVA.
Once again, the sequence of events will call for the two crew members to receive a handoff of the IDA from the special purpose dexterous manipulator that grappled the docking adapter in the trunk of Dragon earlier this week and extracted it, maneuvering it to a pre-installed position, and then earlier this morning driving the IDA into a fully seated position, structure to structure and surface to surface against pressurized mating adapter number 2. Once the crew receives that handoff, they'll cinch these adjustable tethers to essentially create a soft dock configuration between the new docking port and the old docking port, PMA2. From that point, they'll proceed to hook up a series of cable connections to the connection port on the side of IDA2. That will provide ready-to-hook sensors, heater power, and the hook motor power that will enable Onishi to send the commands to drive 2 gangs of 6 hooks apiece, 12 hooks in all, 1 gang at a time, to drive those hooks close to form a hard mate, and the IDA will be at its new home.
But putting eyes on it, it's very nice and close. I do not see any interference from the nadir hemisphere that I can see. No tools, no tethers, and no MLI. The ceiling surfaces are clear.
We copy all, Kate. Thanks. Great words.
For those just tuning in, the spacewalk began at 7:04 a.m. Central Time, 8:04 a.m. Eastern Time, as Williams and Rubins in the crew lock section of the Quest airlock placed their suits on internal battery power to mark the official start of this second U.S. spacewalk of the year, the 3rd overall outside of the International Space Station, the 194th spacewalk in support of space station assembly and maintenance.
And Kate, we'll take a glove and have check from you.
Copy. And work. Top is dry. Gloves are pristine. No change from egress.
Copy, Kate. Thank you.
And I'm setting my TCD back to 3.
The portion of the international docking adapter that is flush against the surface of PMA2 at this hour is called the MAPAS. That's the acronym for the Modified Androgynous Peripheral Attachment System. It has 12 hook assemblies. These are the active hooks driven by the IDA control panel inside the Harmony module, and 4 ready-to-hook sensors.
Your heels are engaged in the FBFR.
My check is good. Gloves look good. And I've got 2 heels engaged.
Again, EV2, both heels are engaged.
We copy. Kate, we heard the good words from you for, you could verify one more time, tools and tethers are clear of the H fixture and the SPDM as well. And then we'll hand the comm over to you, Jeff, to give SPDM a go for the release.
I can verify in the nadir hemisphere, tools and tethers clear of the IDA PMA interface. The H fixture is also clear.
And my side is clear.
Standing by for the robotics officer here in Mission Control to release the Dexter, special purpose dexterous manipulator, from its grasp of the IDA.
I concur, and I've got eyes directly on the fixture to SPDM release. I'll watch it during release.
Okay, stand by just a second.
We'll give the final copy.
Yeah. Hey, Tom, we're go.
We copy. Go for IDA release.
Go for IDA release.
See it driving. I see grippers releasing. And I see stop motion.
IDA is stable.
Okay.
And at 8:16 a.m. Central Time, 9:16 Eastern Time, the Dexter has relinquished its grasp on the International Docking Adapter. The robotics officer here in Mission Control will begin to back the Dexter away from the H fixture, as it is called, a grapple fixture on the new docking adapter, which is being controlled now by Kate Rubins and Jeff Williams 1 month after it was launched in the trunk of the Dragon SpaceX cargo craft from Cape Canaveral. The crew will press ahead to cinch up these adjustable tethers. They'll begin to mate the series of connectors to provide heater power for the IDA, as well as hook motor power and ready-to-hook sensors that will set the stage for the beginning of the driving of these two gangs of hooks to form a hard mate between the new IDA and PMA-2.
And Kate and Jeff, if you are both ready, we're looking at back away next, and just confirm the H fixture is clear.
I can confirm the H fixture is clear. DD2 is ready for backaway.
DD1's ready for backaway.
We copy, and it's in work.
I see motion. Motion.
The arm is now in motion to back the Dexter away from the H fixture on the International Docking Adapter.
We've got about 10 centimeters of clearance. Need to drive forward. clearance. H-fixture is clear.
Good clearance now between the Dexter special purpose dexterous manipulator and the grapple fixture on the international docking adapter. The crew soon will resume work to begin first to cinch up the tethers between pressurized mating adapter number 2 and the IDA itself. And then they'll work to mate these critical connectors to provide heater power, as well as the ready-to-hook sensor capability and the hook motor capability for the driving of the 2 gangs of hooks soon that will be commanded by Takuya Onishi from an IDA control panel, one of 2 such control panels in the Harmony module. The second of those 2 control panels will be used at a later date once the next IDA arrives at the International Space Station, not scheduled to launch until late 2017. That will be mated to the space-facing side of the Harmony module onto pressurized mating adapter number 3, which currently resides on the port side of the Tranquility module.
And Kate and Jeff, the SPDM is clear. You go for IDA install. Once you verify the interface is clear, you can cinch it down.
And the interface, I think, remains clear on my side.
Copy, and on EV2, Nader side, the interface is clear, no tools or tethers. And Jeff, I'll let you coordinate the cinch call.
Okay. I'd like you to try applying a little cinch first while I steady you there to cinch.
Okay.
Tell me if you applied a little.
I'm applying a little bit of cinch.
Okay. Not real tight, just a little bit.
Just a little bit.
Okay. Now you stabilize it, and I'm going to try to apply a little.
Copy. I'm stabilizing. I see the mating interface being brought closer together.
Okay, now let's both apply together.
Copy.
Ready?
3, 2, 1.
Go. I've got a little gap here. I'm going to try to close up.
Okay, I will as well.
Welcome back. We are continuing our coverage of today's amazing spacewalk that's going very well with a series of expert interviews for you. And right now in studio with us we have Mike Fink, who is an astronaut with 381 days spent in space, over 2 space station expeditions and 1 shuttle mission, and 48 hours and 37 minutes spent spacewalking, over 9 spacewalks. That's really impressive.
I'm very lucky, and it's like you said, a great day here at NASA. We got a spacewalk going on, and they're doing great. We're going to we're finishing up putting on the international docking adapter, which paves the way for future space flights from United States to get to the space station.
Great, that's exactly what we were excited about. But first, before we start talking about too much about that, so you spent more than two days spacewalking. Can you give us kind of your expert opinion on how things are going today?
Absolutely, it's always great to watch other people's spacewalks and helps us reflect on our own. Of course, 48 hours over 9 different spacewalks, some in the Russian spacesuit, some in the American spacesuit, and I've seen from one end of the space station to the other. And right now, Jeff and Kate are at the very front end of the space station. It's an exciting place to be. They're on the edge of on the edge of the abyss, and it's going well today. I'm really impressed with the crispness of the comm. They're going back and forth. It looks like they've practiced this many times in our neutral buoyancy laboratory, and it's that practice that makes it perfect.
All right, great. Well, hopefully things keep going as smoothly. But it just seems, in general, kind of like a big day for the astronaut office. Do y'all get to pause and really watch and appreciate it on days like this?
As much as we can. Now, we have on the order of around 50 astronauts. We're working on 3 new space programs, and new rockets, new capsules, and we'll talk more about that later. But we're all very busy. But we always do try to take a few moments out and see how our colleagues are doing, and wishing them absolutely the best of luck, because we've all been there, or for our new guys, they're going to be there. And it's really nice to see the success of our friends and the success of our whole team.
Right. Well, as you referred to, it's also a big day because of what they're doing on board the space station at the Spacewalk, and that's installing the International Docking Adapter, which is a big deal in its own right, especially for you. I think you are the chief of the commercial crew branch of the astronaut office. So can you tell us a little bit about what the International Docking Adapter means for y'all?
Absolutely. So we have 5 or 6 or 7 astronauts now that our primary focus is to help the rest of the NASA team, the program office, our contractors, our what do we call them, the industry partners like SpaceX and Boeing, and we all work together. We bring a certain amount of expertise to the table, operations experience, and how we've done things in the past, and that can help influence the design and production of our new spacecraft. Now, our new spacecraft are, of course, the Crew Dragon and the CST-100 Starliner from Boeing, Crew Dragon, of course, from SpaceX, and they need a place to dock on the space station. And what we have, well, I'll say right now, but what we had up until almost right now is no way for the Americans to dock. We had a pressurized mating adapter, a PMA, where the space shuttle docked to, and there was an acronym called the APAS, the Androgynous Peripheral Attachment System.
Very good.
And that's where the space shuttle would dock to. But it would be very hard for us to pilot a small capsule, space shuttle, big winged vehicle, and docked and actually touched in the back of the cargo bay, the payload bay of the space shuttle to the space station. The new spacecraft are going to dock in almost like head first to the front of the space station, and we needed a docking adapter to do that. And today's the day where the International Docking Adapter gets attached, so that'll give us capability when our spaceships are ready to dock to the space station, and we don't have to go outside as we go from one spaceship to the other. There's a tunnel in the middle, and so we keep in our shirt sleeve environment, open up 2 hatches, 1 on each side, and go right through.
All right. Well, and I guess part of your job basically is to keep an eye on these spacecraft as they're getting ready, right? How's that going? It's going great. We have 2 very energetic partners, Boeing and SpaceX. We have a great program office here. It's at the Kennedy Space Center and at the Johnson Space Center. So Team NASA is helping American industry to get to a new level, and hopefully this American industry will be able to use the combined knowledge of the whole team to open up the doorways for more people to go into space, not just professional astronauts like ourselves. Right. But with that and the International Space Station providing kind of just a stable platform, cool place to do science, and the Orion spacecraft that NASA's building coming online pretty soon, with all those things coming together, it just seems like it's a good time to be an astronaut. Is that, do you feel that in the office? Would that be your perspective?
Absolutely, it's my perspective. Now, of course, I'm betting my or leading the question a little bit, because in my opinion, it's always a good time to be an astronaut. But these are definitely interesting times. When we had the space shuttle, we were flying more often. Now we're helping new spacecraft develop and helping to influence the next 30 or 40 years of spaceflight, and it is very exciting. It's challenging to develop new things, and sometimes ideas don't always work, but that's why we build a little bit, test a little bit, and we'll be ready for spaceflight with the commercial crew program coming soon. Orion, that's extremely exciting. We'll get beyond low Earth orbit, and of course we're continuously living aboard the International Space Station, and like you said, it's an awesome, amazing, wonderful place to do science.
Yeah, lots going on, and I guess a lot of people must agree with you because we got more than 18,000 applications to be an astronaut when we had the application open earlier this year. I guess, would you have any advice for people who are either in the middle of that process right now, maybe getting interviewed sometime soon, or even people who weren't able to apply this past time but are already looking forward to the next opportunity?
Absolutely, 18,000. That's absolutely amazing. I mean, that's it was a big burden, not burden, but it was a big privilege for us to look through that many applications. It's taken a little bit of time, but we're going to start interviewing people soon, and that's exciting for us because we need more help in the astronaut office, and we're hoping that more people apply even next time. It's the only way to become an astronaut, professional government astronaut, is apply. So we're not just going to randomly pick people out of the you have to put in an application. So one piece of advice is that, and this is not just for astronaut applications, but for any dream job out there, you kind of have to look ahead and see what kind of things does NASA need in the future, and what kind of skills do you have, and maybe there's an area where you can improve your skills. For example, there's a lot of people that never thought about flying. Well, that's our job. We fly airplanes, we fly in space, and if you have a little bit of flying experience on your application, then you're going to look a little bit better than someone who didn't, otherwise everything being equal. So so again, just look at what kind of job, what the job needs, and for example, International Space Station, maybe some international experience, maybe some other languages, maybe things like that, as well as, of course, science, technology, engineering, and math. Having done well in school, we're looking for technical people with hands-on operations. It's an exciting time, and we need astronauts with different backgrounds for sure. Right. Diversity in the astronaut corps really would help us succeed so far.
Great. Well, so if you were watching this spacewalk and hoping to someday do your own spacewalk, there's a little advice for you. Next, we actually have some questions from social media that we've been gathering, and if you're watching and following along and want to submit your own, you can do that using the hashtag AskNASA. Again, Ask NASA hashtag, and we'll be taking them throughout the show, and also astronaut Doug Wheelock is answering them online. But we've got a few here from Mike. First is from Willie on Twitter, and they are asking, do you carbo load before a spacewalk, and how many calories would you expect to use?
Well, hi, Willie. So for spacewalk, it is a very physically extenuating circumstance. You're really putting a lot of energy not fighting against the suit, working with the suit, but it's a pressurized suit. Sure. But it's not, I think a lot of people, runners kind of carbo load before like a marathon or something, and this is, it's a different kind of thing than running. So most of us do not carbo load ahead of time. We do like to make sure we're well hydrated before and during the spacewalk, because inside the suit it's only 4 pounds per square inch, so it's 1/4 of the atmosphere that we normally feel, or 1/3, 1/4, something like that, that we normally feel on us, but it's all pure oxygen, so it's a very dry environment. So we'll dry up. So we actually have water bags, drink bags inside of our spacesuits. We stay hydrated. That's an important part. Just like running, hydration is also important.
Did you have a favorite breakfast to eat before you did your spacewalks?
I don't. If I did, I don't remember, because it was always, I was just so excited about the spacewalk. I wasn't. I'm sure I paid attention what I was eating at the time, but it didn't have anything super special.
Okay.
And the choices aboard Space Station aren't great. You can't say, well, I want my favorite. You get what you get. And
all right.
And it's good.
Fair enough. All right. From Tara on Twitter, we have this question. In the silence of space, if nobody's talking in your ear, can you hear your heartbeat?
Tara, great question. It's a vacuum outside of the spacesuit, so between spacesuits, the sound can't travel. But inside the spacesuit, we have that 4 pounds per square inch of pure oxygen, and we can hear things. We can hear ourselves breathing. We can hear the fans and motors inside the spacesuit, and it's not always very quiet out there. But when it is quiet, we can't really hear our heart beating, but we can hear the fans, and we can hear our spacesuit kind of talking to us.
Talking to you. Interesting. All right, this one's a good one. From Akshay on Twitter. They ask, if you were given a chance to rename the term spacewalk, what would you pick and why? And she also adds that Doug Wheelock has already chimed in on this as he's answering questions on Twitter, and he says he would name it the Fingertip Ballet.
Doug is absolutely right. It's like a ballet outside, and you're not walking with your legs, you're using your hands, and it's just the tips of your fingers. So that's a very good one. I'll give a counter offer to my friend Doug Wheelock and call it something like universe alone time. Because it's just you and the rest of the universe out there in front of you, and the only thing between you and the rest of the universe, thankfully, is the glass, the helmet visor that you can see out. So it's a very amazing thing. It's a breathtaking thing to be outside on a spacewalk.
It definitely sounds like it's fun just watching from the ground. So I can't imagine what it's like to actually be there. Okay, from Cheryl on Twitter, do you have time to enjoy the view, or is it all concentrating on the job at hand?
That's a very good question. Most of us astronauts, we really are mission-oriented, right? So we want to get the spacewalk done correctly, and we do not want to let the rest of the team down by making mistakes. So especially on our first spacewalks, like Kate Rubins' first spacewalk today, she's probably not stopping too much to take a look at where she is and what she's doing, because she wants to get the job done. On the other hand, I bet you Jeff Williams, an experienced fellow, we became astronauts at the same time. I'm really proud of Jeff, but he's probably also saying, hey, Kate, we got 1 minute here. Stop and smell the roses, right? There's no roses and can't smell out there. But anyway, stop and take a look at the whole universe out there. Look at beautiful planet Earth and enjoy it for a moment.
Yeah.
And I was actually on one spacewalk in a Russian spacesuit where we couldn't do our job when we were in the dark side. So of the planet. We go around every 90 minutes, and for 45 minutes approximately, they didn't have anything for us to do, so I was just able to put my tethers down and sit back and enjoy that, and that was such a privilege in my life, and I'll never forget it. So sometimes we do get a chance to stop and appreciate what we're doing.
That's good. Next question is from B on Twitter. What did space smell like to you?
So there is of course, outside you can't smell and you don't want to open up your visor, and they don't even have a way to do that. But when we are after a spacewalk, we get back into the airlock and close the hatches, and when we do get to the part of taking off our spacesuits, the doffing process, they take the helmets off, and there is a particular smell. It's like ozone, which is like a little bit of electrical. If like lightning hits something, or if you're working with electricity, you can smell the kind of a little bit of a burnt air smell. Mm-hmm. And it's unique to space, and it's unique to the space station. And now and then I have a few shirts that I brought back from my missions, and they're wrapped in plastic. And if I wanted to rearrange the shirt or look at it, when I open up the plastic, I can smell the space smell, and it's like, oh yeah, I remember that.
You should make a candle.
Oh my goodness, that would be a very popular candle, I believe, in the astronaut corps.
Absolutely. Okay, last one from Twitter. This was from Naya, and she's asking, how is nitrogen purged out of the astronaut system before they spacewalk?
What a great question, Naya. As I mentioned, inside the spacesuit, we are at lower pressure than normal 1 atmospheric pressure of 14.7 pounds per square inch. We're only about 4.2 pounds per square inch, so it's less. And when we get into a lower pressure, it could be possible, like with the soda pop can, that the bubbles come out, and so bubbles of nitrogen can get into our blood, mm-hmm. and they can actually make our skin feel bad, or actually gets lodged in our brain and stop some blood flow. So it's called decompression sickness, the bends. Mm-hmm. But we very carefully, in both the Russian suit and the American suit, are very careful to purge our blood from the nitrogen. So we have several ways aboard the space station to pre-breathe, we call it, and that means we breathe pure oxygen, and the nitrogen goes out of our blood while we're breathing in pure oxygen. So our pre-breathe period depends on which protocol we're using, and so this morning, while most of us were sleeping on the East Coast and on westward, Jeff and Kate were pre-breathing pure oxygen to get the nitrogen out of their blood.
Right.
For safety.
It seems to have gone well. They seem to be doing okay. All right. Well, I think that's the last of the questions we're going to answer right now, but keep them coming. Again, you can send them in on social media using the hashtag AskNASA, and also coming up in just a little while at 9:10 a.m. Central Time, we're going to be asking questions to astronauts Sunny Williams and Bob Bankin as part of a Facebook Live on the International Space Station Facebook account. So you definitely want to start thinking about questions for that. That'll be starting at 9:10, although the actual Facebook Live will start a little earlier so that you'll have a chance to watch the actual spacewalk activities going on as well. And Mike, do you have any questions that you would suggest we ask Sunny and Bob?
Oh, yes. No, Sonny and Bob are part of our commercial crew team. They're going to be on the first cruise to actually dock to this docking adapter, and so I think that would be some great questions on how they think that the new spaceships are coming along, and maybe how they're going to feel when we actually dock, that moment of docking to this international docking adapter that's being connected right now by Kate and Jeff and the rest of the team.
That's a great suggestion. We'll be sure to ask them that. All right, so get your questions in, but for now we are going to go back and join the activities on board the space station, coverage from Mission Control in progress.
You can take a look at you here.
And Kate, it is
the view from the helmet camera of Jeff Williams from an altitude of 254 statute miles above the Earth as the International Space Station flies from southwest to northeast over the southern Pacific Ocean, about to approach the west coast of South America. 1 hour and 36 minutes into their spacewalk, Williams and Rubins are continuing to hook cable connectors to a connector panel on the new international docking adapter that are providing ready-to-hook sensor capability, heater power, and hook motor power for the driving of 2 sets of hooks, 12 hooks in all, that will be commanded from a control panel inside the Harmony module a short time from now by Japanese astronaut Takuya Onishi. The spacewalk is going as planned. The spacesuits are functioning perfectly for Williams and Rubins as they continue to run about 15 to 20 minutes ahead of the timeline.
So, Kate, we're going to step you through the crib sheet here. Confirm that there's no FOD in the lever.
Okay. There's no FOD in the lever.
Inspect the linkage for damage.
No damage in the linkage.
And you probably got the alignment and side loads just fine with that cap, but just make sure you check that. And then you can push-pull on the back shell and try to just increase the force on the lever, see what you can do.
Yeah, I'm gonna try getting it mated full forward. It moves easily until the position where it gets stuck, and then doesn't move past that. By it, I mean bail.
And Kate, with your left hand, try grabbing the back shell and keep your right hand where it is and see if you can pull it back with your left hand.
Just on the back shell?
That's affirmed, just using the back shell.
I cannot. Got a little bit of preload on it. I'm going to try throwing the lever forward, getting the cap keeper off the cap, and I'm doing a twist and see if that preload's going to do anything for me.
I lost track of where you are. You're still trying to get the cap off?
Yes, the cap of J3 is was stuck initially, just not popping off like the other three.
Okay.
And Jeff, you're done with all of your caps, correct?
I am, yes.
So next, I think we'll be moving to quiescent ops. You're going to be getting out of APFR anyway.
Well, we're going to cinch down to get more ready to hooks.
Okay. You can lay off of this J3 and get ready to hook.
Yeah, okay. That's one of your optional ones, right? This for the first...
No, this is a required
it's
one.
Required, yeah.
Okay, Tom, I'm going to move the lever full forward so it's in a known configuration and drop the J3, J4, and I am ready for cinching.
Copy, we'll stand by for your cinching.
I am ready for your call, Jeff.
Let's first try to pull up the tether to apply a force into the IDA to see if they can get ready to hooks.
Okay, copy. I can apply a force and get about a 1/4 inch closure.
Okay.
And I'm applying a force right now on this side.
And I'm applying now. What do you see, Tom?
We have 3 out of 4 now. One of them is going in and out.
Okay. So that's good news anyway. Can you just stand by in your end for a minute?
Okay.
Okay. Just monitoring motion.
So Kate and Jeff will continue to work with the cable ops at this time. I don't know if, Jeff, you have your cable-to-cable made accessible to you. If so, you can work that. And Kate, we have some words for you for trying to get your lever back.
Okay, ready to copy.
So you'll be taking one of your adjustables and one hook on the connector lever. Note that the hook is probably not going to fully close around the lever. And the other end of the adjustable will be going to a handrail stanchion. We have a handrail for you.
See? And ready for the handrail. 402?
That's right, 402.
And Tom, I don't understand what you gave me a call for.
And Jeff, you have one cable-to-cable mate still, and just didn't know if that was accessible to you or not.
Okay, I'll see if I can find it.
It's the white-blue cable, Jeff.
Got it. I got one end. They don't advise on the other end.
And Jeff, if you're looking for the J1 connector that mates to, we've got some words for you.
Please. I have P1 in my hand.
So if you back up from the J8 connector panel, the J8 location on the panel, then you'll see a pigtail coming off of that. That's your J1 red.
Perfect. Thank you.
1 hour, 44 minutes into today's spacewalk. Jeff Williams and Kate Rubins still working with a couple of the cable connectors to the international docking adapter that will route hook sensor capability as well as hook motor power.
So you'll be pulling away from the handrail to try to get that, just give you extra leverage to get that lever to go back.
Copy.
And you can work on pulling back on the back shell as well to help it.
One of the cables proving to be a bit stubborn, but Kate Rubins continuing to work on all of that.
Let us know what you guys are thinking for the ready to hooks and the tether plan.
And we're talking, Kate. And Jeff and Kate in priority order. We'll let you work that for a moment, Kate, but getting your connector in will be priority, and then we'll, if we need to, we'll go around and get another adjustable on the IDA to take care of that other ready to hook.
Okay, I would suggest if Jeff is amenable that he come down here and we can try this with two people. This is not getting any lever movement, even with using the force of working against the adjustable on the handrail, so it's a pretty large amount of torque.
We like your plan, Kate.
Stand by, see if we get this 1 series metered. I've got 2 caps off.
The discussion between Spacewalk communicator Tom Marshburn here in Mission Control and the spacewalkers outside dealing with possible alternative methods to further cinch down the international docking adapter to PMA2 in the event we can't complete this one connection from an apparently stubborn connector that Kate Rubins is dealing with. But we have plenty of time, 1 hour and 47 minutes into the spacewalk, the crew running 20 minutes ahead of the timeline.
So, Tom, you're going to have me egress and go down to Kate?
That's affirmed, Jeff.
Okay, I'm going to egress now and then mate these cables in egress position and then work my way down there.
That sounds great, Jeff. Thanks.
And Tom, I'm working with all the torque from that APFR against the adjustable to the PMA handrail on the lever. That's not budgeting.
We copy, Kate, and why don't we stand by and let Jeff get down there and play with it for a while before we put more force on it.
Sounds good. And I will leave the adjustable to the lever.
Okay, Tom, the 1 series is mated, P1 to J1. The bail's forward and over center.
Great work, Jeff. Thanks.
And just so you keep track of it, I'm releasing my cap keepers on their right back to the bag.
Thanks. We saw it go away. So you can head Nader and give Kate some help.
Okay. And Kate, you recommend I come around the Nader side?
I do, because I think if you can come Where your feet are right now, head directly nadir from your ATFR. I'm going to keep you deconflicted from my safety tether.
Okay. Okay, I've picked up my local and coming around.
Jeff Williams making his way towards the nadir side of the pressurized mating adapter number 2 and international docking adapter to assist Kate Rubins with this one finicky connector. Just a reminder that the structural integrity of the IDA's
0417.
modified androgynous peripheral attachment system, that is the surface-to-surface portion of the IDA with pressurized mating adapter number 2, that structural integrity is considered sound if both of the 2 gangs of hooks are closed and engaged. At least 11 out of the 12 hooks that are involved in these 2 gangs must be closed in order to provide the proper structural integrity for the arrival of visiting vehicles.
And we're discussing as you guys are working, you're probably thinking, Jeff, if you need another pair of hands, the 4 of you could stabilize and just jiggle that back shell and use your back shell to try to get that lever back.
I don't understand.
He wants us to pull on the actual back shell, but you can. I tried that. Can't get a ton of torque on it. See how easily it moves? Pull that lever back, and you can see it move easily to the next position.
And Jeff, we're thinking if you could have your hands as they are while you're pulling on the back shell away from the cap, then Kate could be moving the bail aft.
I'm going to move you more than I'm going to move the bail.
That's fine. That's fine. Oh.
Another thing we can try is working against each other. So if you take one side, I can take the other side, and we can try to pull. If you try to move the bail.
Again, the issue that Williams and Rubins are dealing with is an attempt here to disconnect one of these connectors from its current configuration so that it can be reconnected to a patch panel on the side of the international docking adapter to provide us with all of the ready-to-hook sensors and all of the hook motor power capability that will be needed a short time from now when the commands are given to jive 2 gangs of hooks closed to form a hard mate between the IDA and PMA-2.
And Jeff, we see you've got a handrail available to you. Perhaps you can hook the lever on that, pull on the back shell, and use the handrail as leverage against the lever.
Here's the adjustable also if you want to try that.
Let's see if I can figure out what you mean here. I think you mean like this.
And just watch that French hook that it doesn't slip off the cap.
Yep.
I can hold one end and hold it steady onto the handrail. There we go.
Hey.
Nice work. All right, let's pop the cap off now.
And the crew now has declared success. They have the connector free.
That was a beautiful thing. Great work.
Okay, just because we had the issues with it, I'm double checking no FOD. There are no bent pins at the J300 connection. And I'm giving a really good check on the EMI stand here.
And we're only half done.
We copy, Kate, and Jeff, if you could check that handrail for any burrs after that op.
Copy.
It is a rare day in the world of EVA when there is not a stubborn connector, but with two sets of hands working at it, Williams and Rubins have been able to free up one of the connectors that now will be mated to that patch panel on from pressurized mating adapter number 2 to the international docking adapter to complete the set of connectors required for hook motor power and the ready-to-hook sensors that will be observed here in Mission Control as the driving of the hooks begins a short time from now.
And J300 is mated.
Copy all.
Right, Tom, I have 8 caps on my cap keeper.
What's the ready to hook status, by the way?
Stand by 1, Jeff, we're talking.
Jeff, nice work with that.
Jeff, we're only seeing one ready to hook at this time, so we're going to go ahead and have you go back to the bag and get an adjustable. And I'll have a location for you. That adjustable is going to be going on the port side.
Is it a single adjustable?
That's for my mini workstation, and we're welcome to use that.
We got one
And
right
Jeff,
here.
that's a double.
I see a single.
No, the double, they want the double.
Oh, you want the double, gotcha. Gotcha. Okay, I'm heading back.
While he's working on that, I'm going to retrieve the single that we were using for the connector ops and put that back on my mini workstation.
Copy, Kate.
Okay, I dropped the local down in 0409.
And Kate and Jeff, just so you know, despite all the anomalies, you guys are plowing through it just great. We're still on the timeline.
Thank you.
That sounds great. Thanks for those words, Tom.
Okay, Tom, I've got it. Which direction am I heading?
So, Jeff, you'll be going port. You're going to go to about the 3 o'clock position. You're looking for a handrail that's just zenith of the base of Kate's APFR. And a heads up, you know about the please don't touch peripheral docking target. It'll just be off to your side there.
Okay. Okay. Tell me, I see 0412. Are they handling looking?
That's it. And you're going to be going from the aft stanchion on 412 to the corresponding handrail on the IDA. Aft stanchion to that one. That's 1501 if you see it.
Jeff, I can feel you run my feet.
And that should be 1501, Jeff, that you want to attach it to.
Got it. Aft to aft. I'm connected between 1501 and 0412.
All great words, thanks. You can go ahead and cinch that down.
Get my RIT removed first.
Jeff, I'm going to take a look at the orthogonal view here and see if I can see things as you sit it down.
Excellent views of the new international docking adapter. As we have just passed the 2-hour mark into today's spacewalk, the crew running some 20 minutes ahead of the timeline. The International Space Station currently flying over the North Atlantic on an orbital track that will take the complex and its 6 crew members directly over London a short time from now. Rubins and Williams outside the long pressurized mating adapter number 2 at the docking interface, currently assessing to see whether there are any gaps between the 2 docking surfaces. They are going to be asked probably to cinch down those adjustable tethers a bit tighter to draw PMA2 and the IDA even closer together, structure to structure and surface to surface.
We recovered 1 ready to hook, and so we're going to have you go around, Jeff, and both of you go back to your original tethers and cinch those down tight, and looks like we're making progress.
Good.
Hey, Jeff, I think your tether should be cinched first. That's where the gap is widest. I'm going to hold off on cinching mine.
Okay. Clear.
Once the tethers are cinched tighter, basically like tightening your belt to form a closer surface-to-surface contact, the ready-to-hook sensors will all come online. That's the belief of the mechanical systems officer here in Mission Control. We need to see those ready-to-hook sensors before we can proceed with the process of having the crew back away from pressurized mating adapter number 2. That will set the stage for the initiation of the commands from a control panel inside the Harmony module that Takoya Onishi will be in control of as he sends commands to start to close 2 gangs of hooks, 1 gang at a time. It'll take about 5 minutes for each of these 2 gangs of hooks, 6 hooks for each gang, to close to form a hard mate between the new docking adapter and pressurized mating adapter number 2.
Hey, Kate and Jeff, we see 4 good ready-to-hook sensors. Great work.
All right, don't touch it.
Okay, copy.
And there's the best news of the day. 4 ready-to-hook sensors. All of the cable connections are good, and we have a very clean surface-to-surface contact between the the new docking adapter for the commercial crew vehicles and PMA-2.
And just ensure your tools and tethers are clear all around as you're going around.
Copy. How you doing, Kate?
I'm going to egress to APFR.
Okay.
And I will meet you back at the bag.
Okay.
I see up there. Working my way around.
Yep.
And Jeff, if you'd like, you can temp stow your cap keepers there by the bag.
Yeah, I've done that. Still on the original tether in the bag.
We copy. And Jeff, we'll take a glove and a half check from you.
Copy.
And just let me work my way around. I'm not wanting to translate over this APFR without a local down. So
yep. I don't blame you.
Russian tether method right now.
This is Mission Control Houston, 2 hours, 8 minutes into today's spacewalk. Jeff Williams and Kate Rubins still working ahead of the timeline, having completed the initial connection of critical cables to a patch panel on the new international docking adapter. Everything is proceeding well. We have good 4 ready-to-hook sensor indications. The crew soon will be backing away from PMA-2 to retrieve a reflector cover from a tool bag that will be installed over what is called a hemi-reflector. That's basically a docking aid that exists on pressurized mating adapter number 2 and is no longer required, and in fact would provide false cues for approaching U.S. commercial crew vehicles as they come in for their final rendezvous and docking to the new international docking adapter. The crew will be moving to the nadir side of the Harmony end cone as the permission is then given for Takuya Onishi to begin sending commands to drive the hooks closed that will hard mate the new docking adapter to PMA-2.
Planar reflector cover. Later we had, of course, planned on having tether points on either side, starboard and port, down below at the base of the reflector. I don't see those places to run the Velcro tethers through. It's completely void of anything obvious to me anyway.
And we copy, Jeff. We'll talk about it. We got some further words for you. By the way, those tether loop, leather material loops you're talking about should be on the IDA itself. But we're going to have you, Jeff, get another double adjustable. We just lost ready to hook sensor 4. So we're thinking about just going ahead and just getting them all installed.
Welcome back, and for those who are joining us via Facebook Live, welcome for the first time. We really appreciate you tuning in to view our Spacewalk Live here on NASA TV or Facebook Live. And we have with us in the studio to tell us a little bit more about how spacewalking goes when you're up there, and about the commercial crew program that this is going to allow us to dock to the International Space Station. We have astronauts Bob Behnken and Sonny Williams. Bob has 708 hours in space over 2 space shuttle missions and more than 37 hours spent spacewalking. And Sonny has 322 days in space over 2 space station missions and 50 hours plus spent spacewalking. So they've got a lot of experience between them. And what we are going to do is start taking questions right away from Facebook Live. If you are following along on NASA TV, you can tune into the International Space Station Facebook page to ask your own questions. But we're going to jump right in, okay? All right, just real quick, why don't y'all give us your kind of idea of how the spacewalk is going to start us off?
Well, good morning, Brandy. I think the spacewalk's going really well. We just heard Tom Marshburn report a little while ago that they were on the timeline, and they're working towards getting the hooks driven to kind of get this IDA permanently installed on Space Station.
And that's exactly what we want, right?
We're excited about it. It's the next step for the commercial space program, so it's looking good so far.
All right. Well, we're getting a lot of questions, so let's start with them. First one is, do you ever get claustrophobic on a spacewalk?
I don't know if I can speak for Sonny or not, but I actually did not get claustrophobic. Kind of the opposite of that. When you kind of step out, you're kind of in the void. You know, you just have a kind of a bubble, a clear bubble that you can look out and kind of see the Earth. And so folks sometimes get a sense of falling, or a little bit of kind of the opposite of claustrophobia, because there really sometimes is really nothing to hold on to. So
that makes sense.
Yeah, and I agree. I know I was on the space station during a long duration mission, so it's actually the first time you get to go outside. So it actually is sort of the opposite effect. And like Bob said, you get that, you know, that almost 360 view, as you could turn your head in any direction to really see out into space. So yeah, no, not claustrophobic.
Not claustrophobic, even in the spacesuit. Well, what about this next one? Big star for the day is the International Docking Adapter, which is being installed right now by Jeff Williams and Kate Rubins. And we have a question about, is that going to be a docking port for U.S.-built spacecraft? So maybe you can explain that.
Absolutely. It's going to be the docking port that will be on board, and we'll be able to bring U.S. vehicles to it. You know, for years we were able to bring the shuttle to that kind of same port, but we need to modify it a little bit so that we can get the commercial crews optimally attached to Space Station.
Right. Yeah, and hopefully in the not-too-distant future also we'll have a second one, and part of the spacewalk at the end, when they get to it, is routing some cables to prepare for that. So hopefully, knock on wood, before too long we'll have actually 2 places to park.
And when I introduced you two, I didn't mention that you're both part, I guess half actually, of the commercial crew cadre in the astronaut office here at NASA. And that means that y'all are kind of in line to be among the first to ride on those commercial vehicles docking to the space station, right?
Absolutely. You know, when we identified the commercial crew cadre, when NASA did that, we were to be the group, the pool that the people who first fly on these new vehicles will come from. And so we're all looking forward to those days, launching again off the Florida coast. And so pretty exciting times, pretty exciting to be a part of the commercial crew cadre.
I bet so. And I guess this means it's kind of especially exciting for y'all to see this adapter installed, right?
Absolutely, because one of the vehicles that we're working with today, the Boeing CST-100 and the SpaceX Dragon capsules, one of them is going to be the first one to dock to this adapter, which is, when you stop and think about that, really exciting.
All right, we'll go back and take some more questions from Facebook and keep them coming. We'll be asking them for a few minutes. So next one is, can you see stars on a spacewalk?
I was able to see some stars during my spacewalks. They're not necessarily as bright as you might think. There's usually some other lights that are still there on board the space station. So whether it's your helmet lights that are reflecting off of the structure that's out there, or they've got some big lights on space station that are turned on, you know, it's kind of just like in Houston or any other city. If it's really dark, you get a better view of the stars, and if it's kind of bright, then you don't. And so space station is a pretty bright object. Those of you who've watched it kind of transition across the sky have seen how bright it actually is, and it's bright when you're up there as well, and that can interfere with seeing the stars. But you're able to see them, and if it's really dark, you can still see you can actually see the colors that's hard to see from the Earth as well.
And I guess you probably couldn't convince the Mission Control Center to turn off the lights while you were outside, huh?
You know, I actually was pretty lucky on one of my spacewalks. It was when we installed the cupola on the underside of the space station. It had a big insulation blanket that was on it when it was actually launched, which was a lot of work to get off and fold it up and get in the bag so that we could bring it inside. And we were actually both, my spacewalking partner and I, breathing more than our suits could handle. And so we got the luxury of Houston calling us up and saying, hey, take a break. And it was a night pass, and we were actually able to get some good views, turning off all of our lights, and both looking down at the Earth and looking out into space. So, you know, not very often do they tell you to just relax and take a break for a little while, and that was pretty cool opportunity.
Any stories like that from views that you found memorable?
Yeah, actually sort of similar story. Every spacewalk has a little hiccups every now and then because you can't really practice every little thing that you're going to do up in space up there. And we were on one of my spacewalks trying to retract a solar array and running into a little bit of a problem. So again, Mission Control told us, take a moment for a second. We want to collect down on the ground, and it happened to be a night pass time frame. And not only the stars, but also seeing the northern lights below you is pretty spectacular, and a little shocking the first time I saw it, to see that much of energy interact with our planet that you have really no control over. But to see it from that vantage point was pretty amazing. So yeah, being on a spacewalk, it allows you to really reflect a little bit more about where we are, what we're doing.
I bet. Yeah. Well, next question is actually about the space suit. They're asking if it's one size fits all or not.
It's a little bit of one size fits all, but the spacesuit does come in different sizes. The upper torso is hard. We call it the hard upper torso, so HUT, just like all the other acronyms that NASA has. We have one for the top of the spacesuit. Comes in different sizes, and so I think the crews that are outside today are actually wearing 2 different size suits. All of us actually try to wear a couple of different sizes of suits because we want to have some flexibility if one suit has a problem to be able to fit in another one. And so there are a couple of different sizes. In addition to that hard upper torso, the legs are different lengths, the arms are different lengths, the waist or otherwise are different sizes as well.
Okay.
But they're kind of an erector set. You kind of put them together and wear the size suit that you need.
All right, and I'm sorry, we're going to pause real quick now because I think they are getting ready to drive the hooks, and we want to be sure and see that. So we're going to join the commentary from Mission Control in progress for a few minutes.
Awesome.
We like the idea of picking it up on your way aft.
This is Mission Control Houston, 2 hours, 18 minutes into today's spacewalk. The stage is now set for the driving of the hooks that will permanently mate the first international docking adapter to PMA-2 on the International Space Station. This will be the docking port to which the SpaceX Crew Dragon and the Boeing CST-100 Starliner spacecraft will arrive and link up to in the future. A second international docking adapter is in the offing, currently under construction, to be mated to the space-facing side of the Harmony module on the International Space Station to PMA-3, which will be relocated from the port side of the Tranquility module to the top side, or space-facing side, the zenith side, if you will, of the Harmony module.
Beautiful.
With the crew running ahead of schedule, they were able to use several adjustable tethers to cinch down, or basically soft mate, the new international docking adapter to PMA-2. They then proceeded to hook up a variety of cables to a connector port on the IDA itself, providing heater power, ready-to-hook sensor capability, and the hook motor power that will be used to drive 2 gangs of hooks closed, 1 gang at a time, under the commands of Takuya Onishi from a control panel inside the Harmony module. That activity is set to begin a short time from now.
Jeff, you copied that, correct?
I did. I'm trying to get visual on you. Here we go.
Okay, so I am BRT to 0318. The local down there as well, and I'm not copying anything from Tom.
It must be
And we're back with you.
Good, Tom, and I'm just letting you know I'm BRT to 0318 on there too. I've got a local down there as well, and this is a good position. It gives me a view of the mating interface as well as being zenith, and I can see Jeff.
We copy, Kate. Thank you.
And Tom, I did pick up the reflector covers.
We copy, Jeff.
And I am BRT'd on 0316. And we're ready to initiate quiescent operations.
We copy, Jeff. I'll read you the note. You must remain quiescent while we're driving the first gang of hooks. It's going to take about 5 minutes. And once you and Kate are happy, you can give us a go for the hook driving.
We are both ready. We're both on BRTs and we're quiescent. So you have a go.
Copy. Go for quiescent ops.
And here we go at the 2-hour, 21-minute mark into today's spacewalk. Takuya Onishi is about to send commands from a control panel inside the Harmony module to begin driving the first of 2 gangs of hooks. There are 6 hooks for each gang. It will take about 5 minutes for each set of hooks to close to form a hard mate between the IDA and PMA-2. Structural integrity is considered sound if both of the hook gangs are closed and engaged. We need 11 of 12 hooks to be confirmed closed and engaged for visiting vehicles to begin arriving at the International Space Station.
And you have a go to perform steps 5.3 to 5.5 for TOC. 5.5 for TOC.
Copy, go for step 5.3 through 5.5.
Good readback.
The first gang of hooks are the odd-numbered hooks that will close. The second gang closes the even-numbered hooks.
And I'm closing the hook gangs 1 in 3, 2, 1, mark.
Command issued for the first gang of hooks to close.
The best task so far.
Awesome.
It will take about 5 minutes for each of these gangs of hooks to close. The mechanical systems officer here in Mission Control monitoring the data.
A lot more crowded out here than the last time I was outside. Modules everywhere up here.
That call from Jeff Williams referencing the last spacewalk he conducted outside of the International Space Station as the commander of Expedition 13 back in August of 2006 with European Space Agency astronaut Thomas Reiter. Mechanical Systems Officer here in Mission Control reports that the first gang of hooks is halfway closed.
Kate and Jeff, 1 more minute to nighttime.
Copy. Copy, Tom. Thank you.
As we stand by for further word, this, again, a cutaway view of the various segments of the International Docking Adapter. The hooks that are closing belong to the MAPAS. At the bottom, that's the Modified Androgynous Peripheral Attachment System in NASA speak. 12 hook assemblies and 4 ready-to-hook sensors that are mating the IDA to PMA2 at the top. That PSCS is the Passive Soft Capture System. That is the mechanism to which the new U.S. commercial crew vehicles will link up to.
Okay, Houston, Navy crew, this is Ivy. It took 4 minutes and 30 seconds to get multimeter readings less than 100. Then after 4 seconds after that, I got close the light illuminated.
Thanks for that talk, and can you verify you also got the all closed indication?
Yes, I did.
Copy that talk. That's a good configuration.
First gang of hooks now closed between the International Docking Adapter and PMA2. Christina Cook, the astronaut communicator with Takoya Onishi, who is operating the closing of the hooks from a control panel inside the Harmony module. So the second gang of hooks now will be initiated closed, again a 5-minute procedure, and at that point we will have a hard mate between the new docking adapter and the International Space Station.
On PMA, but not on IDA.
Copy, Doc. Thank you.
Great work, everyone. So Kate and Jeff, you can go ahead, and as long as you stay clear of the interface, go ahead and move over to the PMA2 Hemi reflector and get the cover on there and get pictures before and after.
Copy.
With the first gang of hooks now closed, Williams and Rubins can press ahead to return back to PMA2 to begin the process of installing a cover over a docking aid called a hemi-reflector on the pressurized mating adapter to which shuttles used to link up to. This reflector cover is going to be attached to the PMA to prevent any false indications that would be offered to the new U.S. commercial crew vehicles as they approach for a link-up to the new international docking adapter. Later in today's spacewalk, Williams and Rubins will be attaching two new hemi-reflectors, as they are known, onto trunnions on the new international docking adapter. Those will be the primary docking aids for the Crew Dragon and the Boeing Starliner vehicles when they are in their terminal phase of rendezvous for contact and capture to the International Space Station.
Thank you.
Okay, I'm closing hooks gang 2 in 3, 2, 1, mark.
Copy.
Onishi has now issued the command for the second gang of hooks to close.
I'm dropping a local on 0323.
Okay, copy. I'm at 0324, and I'm in a good spot for pictures, so I'm dropping a local.
Copy.
Back with our television capability from the International Space Station. 2 hours, 33 minutes into today's spacewalk. Williams and Rubins back at it as they are now working to install a cover over a reflector on pressurized mating adapter number 2. The second gang of hooks in the process of being closed to hard mate the international docking adapter to PMA2.
Get you here from the side.
Yeah, your end effector's pulling me up. Pictures of this thing are best effort, right?
That's affirmed. Best effort. We know the conditions are poor.
Were you able to snap a few shots?
I was. There's a TA cramp in the way, and your helmet lights are right there, so I'm not sure.
How about now?
Yeah, I'm going to BRT here to 0307 for stability, and I think that'll be better.
Okay. And I'll give you some good lighting.
From station 101.
Go ahead, talk.
I've got hook assemblies all closed, gang 2 light is on, and it took 4 minutes and 26 seconds until we got multimeter reading less than 100. After 4 seconds after that, I've got gang 2 closed light.
Okay, I got good pictures. If you put the cover on, I'll take post or install pictures. Okay.
And with that, we have a new port of call for the new U.S. commercial crew vehicles. All 12 hooks are closed. We have a hard mate between the new international docking adapter and pressurized mating adapter number 2 at 9:40 a.m. Central Time, 10:40 a.m. Eastern Time, as the International Space Station flew over the Indian Ocean just west of Singapore.
Snap right in place.
Houston EV crew, this is IV. Hooks gang 2 is closed. Stand by for final checks and power saving. EV crew is go for translation on IDA, but not cable disconnect.
Copy, Doc. Nice work.
And Jeff, we have a great view of your work there. It looks like you're putting that wire tie through the tether ring as well as the 2 loops on the cover.
Copy.
Station Houston on Space to Ground 1 for talk. Talk, we copied your words. Let us know when you're complete with step 7, and ground will perform the RPC steps in 8.1, then give you a go to pick up with the verify steps.
All right, I got good post install pictures.
Okay. Taking the red off.
I have completed through step 7, so you guys have a go for PCS step.
Great work. We'll take some closeout photos with the cap on there as well, and then we'll be moving back up zenith.
Okay, Kate got some photos.
It's already complete, Tom.
Unless you want both.
This is Mission Control Houston, 2 hours, 38 minutes into today's spacewalk. Just a couple of minutes ago, the mechanical systems officer here at Mission Control and Takuya Onishi, working from a control panel inside the Harmony module of the International Space Station, confirmed that the second of 2 gangs of hooks were closed. This is a view of the IDA control panel, one of 2 such panels inside Harmony. You can see all of the lights lit for the closed and the hook assembly all closed for both Gang 1 and Gang 2. And so we now have a hard mate and a permanent attachment between the international docking adapter and PMA-2. Additional installation work lies ahead for Williams and Rubins. Now they will be rerouting power from the interfaces between the connectors that were hooked up a short time ago to provide the hook motor power for the MAPAS, or the androgynous attachment system linking the new IDA with pressurized mating adapter number 2 There is some reconfiguration now that will take place over the course of the next few hours that will then route power and heating to the top portion of the International Docking Adapter, the passive soft capture system as it is known, to which the new commercial crew vehicles will be linking up to. You see the cover that's over on the very left side of your screen, the cover that's over the International Docking Adapter. That cover will be removed later in the spacewalk, and two reflector docking aids will be attached. The crew is in the process of completing work to put a cover over a reflector on PMA-2 that space shuttles used as a docking aid or reference during final approach for contact and capture. That, of course, no longer needed. So we now have made the transition, mechanically at least, from the space shuttle era to the new U.S. commercial crew vehicle era with the firm attachment and hard mate of the International Docking Adapter to PMA-2.
So the inhibits are in place, so when you guys are ready, we'll start, you're all set in your APFR, we'll start on the cables again.
Copy.
Welcome back, and for those just joining, welcome for the first time to our coverage of today's Spacewalk live here on NASA TV. And we are back with astronauts Bob Behnken and Sunny Williams, who not only are extremely experienced spacewalkers, but also are members of the commercial cadre crew inside the astronaut office here at NASA. So are you guys just, now that we've got the hooks driven and it's really close to being installed, are you just dying to knock on the door?
Absolutely. I mean, it's ready, essentially. Now we have a little bit more reconfiguration for Kate and Jeff out there, but Talk did his part and made sure all the hooks are closed, and we'll be ready as soon as the spacecraft are ready to dock to the space station. Pretty psyched.
Great. Well, let's talk a little bit about that. Let's see, you two plus Eric Bowe and Doug Hurley make up the commercial crew cadre in the astronaut office. Explain a little bit about what that is and what kind of a typical day is like as a member of the commercial crew cadre.
Well, I guess a typical day for us involves kind of tracking along with how SpaceX and Boeing are doing and taking any opportunity that we can to make sure that if there's anything that we can add to the designs that they're kind of working through or how effective they're going to be when we actually need to operate these spacecraft, we take those opportunities and reach out to them. And so we travel to Hawthorne, we'll travel to the Kennedy Space Center where, you know, operations are ongoing to get the Atlas pad and the SpaceX pad up and ready to launch these vehicles into space. And so we spend most of our days just trying to reach out to them and make sure that there's anything that we can share from our spaceflight experience that might affect their designs, that we get that to them in a timely fashion.
Okay. I feel like I've seen pictures and video of y'all at some really interesting tests and demonstrations. I know y'all see a lot of interesting stuff as astronauts, but anything that really stands out from this part of your job so far?
Yeah, actually, I could tell you I had the opportunity to check out the Boeing simulator as it was getting released in St. Louis to be brought back down here to Johnson Space Center, and that was pretty neat to actually see, you know, essentially a cockpit ready to go for us to train with. Also, both sides, of course, have their own spacesuits, and so that's, to me and Bob, I think, pretty exciting as we like spacesuits for many reasons, to go outside, but also to ride uphill and back down as we're coming back into the atmosphere. It's a very critical, integrated part of the spacecraft. So both companies have their own designs, and we've had the opportunity to work with the engineers and even try on the spacesuits that they're producing in an engineering fashion, trying to help them understand some of the needs as we're going uphill to space and then back down into the atmosphere. So those, to me, stand out as pretty significant events.
I would just say for me, each of these events that actually kind of bring something to closure are the ones that are most exciting, whether it's the docking adapter that comes on board, whether it's the room that you were last in before you climb into the vehicle down at the pad at Kennedy for the Atlas launches. When you see those final steps kind of being put into place, I think we had some folks at an engine test for a Centaur engine. It's going to be the last engine that needed to be tested prior to launching one of the crew into space. And so when we get to those final steps, those are the ones that are most exciting and most important, because we know, hey, that's the last time anybody's going to touch that before we actually bring a spaceship on board with it. And the same thing's going to be true for this docking adapter. They're going to take that cover off here in a little while, and then the next person who touches it will be a ship that's coming aboard space station at a new port of call, to quote Rob Navius. So.
So this obviously is a pretty big block to check off, a big milestone for us. It sounds like there are lots coming up, though. We're going to start seeing test flights in the near future. What are y'all looking forward to next?
Well, as this year progresses, just like Bob said, it's the closeout of all this hardware. So, you know, in the year past, it's been a lot of discussions and a lot of paperwork and decisions being made, and now we're actually seeing a lot of hardware being made, and actually how we're going to operate these spacecraft, how we're going to be flying them as we launch and as we rendezvous and dock to the space station. So I think this whole year is going to be very exciting as we really, you know, the rubber meets the road, and we actually get to try it all out and see how it works.
All right, well, we'll definitely be watching for that. Getting back to the spacewalk that's going on right now, though, two of you, I think if you add it up, have a total of more than 3.5 days spent spacewalking. So that's a lot of experience right here. Can you kind of compare the work that's going on today to work you've done in the past, and any challenges that you're watching out for these guys?
I think for me, really watching these guys kind of go forward, it really brings back memories of the assembly sequence that we went through for Space Station. You know, this is actually bringing up a module, a small module, getting it attached to Space Station, and all the things that go along with that. There's always a cover that needs to be removed. There's always some power that needs to be hooked up. Sometimes there's ammonia. Luckily, these guys don't have much ammonia involved in the activities that they have today, and so it really is reminiscent of all the assembly that we did in the past. And so all those things that you plan to go exactly perfectly, luckily for these guys, and I hesitate to bring it up because you want things to continue to progress as smoothly as they are, but things are going really well for them in this assembly sequence, which means that the teams that worked it out and thought a lot about it before we got to the game day here today really did an excellent job, and so I'm glad it's going so smoothly for them.
Yeah, definitely. Anything from
I was just going to add to the last thing Bob said is, you know, we make it look like it's very easy usually during spacewalks, and things are ticking along and everything looks perfect, but what that means is that whole back room, which probably folks are seeing on NASA TV, or that whole front room, mission control, and then their back rooms, who are all working together and who have thought for many months before this of all the things that could have gone wrong, and then they're ready to swing into action in case they need to change their plan or alter their plan. And so you know, like Bob said, I have all the faith right now after the hooks are driven that this spacewalk's going to go very well. But even if there's a couple hiccups, I'm sure they'll get through it based on the experience and the work that they've done beforehand. And that's all, that big team effort.
We actually had Keith Johnson with us earlier today talking about how they actually start working like as early as the design phase, thinking about how they're going to do spacewalks to actually install it. So months and even years of preparation for this.
Absolutely.
And no, we've heard them talking a lot about making connections. So I think this is the kind of connection that they are making. Maybe one of y'all can demonstrate how it works.
I guess it's
this is a test.
it's relatively straightforward if it works the way that it's supposed to. So we've got power connectors, data connectors that have if you look closely in here, I won't attempt to count the number of pins, but it's way more than 2 and way more than 10 inside of here. And figuring out a way that you can get these aligned in a way that they'll actually mate together without jamming one of them or causing some damage to it is something that's really tricky, but the folks who invented these connectors put a lot of time into guaranteeing that before you tried to push them together that they would be very well aligned. So the first step is to get it aligned and snap it into place. You heard the click. You can't really hear that click, but you can feel it because there is a bit of a detent there when you're in space and inside of your spacesuit. The next step is, now that it's well aligned, is to just drive the connectors into place. And so as long as this mechanism works smoothly and things go really well. Now, temperature cycles.
Oh, yeah, go ahead. I was going to say something to remember where they're working, and we had one of our spacewalks which was on the PMA right in the front there, pressurized mating adapter number 2, which is right in the front, goes through a lot of heating and cooling. Bob was just about to say that, so I didn't mean to cut you off. Makes this metal expand and contract at different rates, and so it sort of makes them a little bit tougher. And then, Brandy, right next to you, you also have a space glove, just so folks at home can understand why maybe you couldn't hear and feel that you're in the spacesuit and you're using the space glove to actually actuate these electrical connectors, which makes it a little bit harder at times. So, the combination of the intense environment that you're operating in, which requires you to wear the suit, makes doing this rather simple operation sometimes a little bit more difficult.
And I've also put it, in the optimal place for me to get my hands on it and things like that.
Yeah.
They tend to put these connectors down over here and then ask you to, with the very tip, and then try to get it clicked into place. And so you get that part done, and then you've just got trying to figure out a good way to make sure that you've got your hands on here and you can drive this mechanism. And it's pretty stiff. Especially a new one. The ones that we get for training sometimes have been cycled hundreds of times by the folks, and they move pretty smoothly. The ones on orbit typically are just getting done a handful of times, and so they're like any brand new piece of hardware. Sometimes they're a little bit less cooperative than something that's well worn. And so luckily for these guys, they've been able to figure out that magic position to make it go smoothly during the spacewalk.
All right.
So,
thank you. That was very interesting. So we're going to go back now and take a few more of the questions we've been getting online via social media. And if you are watching from home, you can keep sending those in to us using the hashtag AskNASA. We'll be looking at those on Twitter. And even if we can't get to them here on the show, astronaut Doug Wheelock is also answering questions online as well. So hopefully we'll get to a lot of them. But some of the ones we've got lined up right now, we've got from Tara on Twitter, what are the highest risk moments of an EVA or spacewalk?
At least from my perspective, it really can depend on the spacewalk. And so if you have an operation, and I mentioned ammonia earlier, that you're managing the cooling system on board the International Space Station, that ammonia, if you bring it back inside, could be toxic to the crew, poisonous to the crew, and so you don't want to do that, and you have to manage it very carefully. So that can be a danger in terms of how you manage it. And so getting sprayed with ammonia while you're outside, not a big problem. You're in a special suit that gives you your own little atmosphere. But when you come back inside, that's when things could potentially be dangerous. So you have to manage that process really well. And I think that kind of drives the point home, at least for me, that it seemed like the most dangerous thing that was out there, the most critical point, was actually getting back inside. When you're inside, if you can't get out, then you're still safe. But when you're outside, you do eventually have to come back inside to get back to a safe place. And so doing that in a way that doesn't bring ammonia, doesn't bring some other contaminants that we have outside the space station, and doing it before your suit runs out of some of the capabilities it has to scrub your atmosphere is really critical. So
that makes sense. This one's a good one. Our spacewalks planned, different one I was looking at. The patches on your suit, can you tell us what they are and what they mean?
Yeah, well, every crew designs their own patch for when they're going to fly. It depends on the vehicle and if you're going up there for a long duration. So mine and Bob's suits are a little bit different. Some of the standard stuff, of course, is your name tag, the agency you work for, the country you represent when you're up in space. But the specific patches, the two on my arm right here are the space shuttle flight that took me up to the space station, dropped me off, and then the one that brought me back home. And the patches right here are the expeditions, which you're part of when you're up in space. And so I was part of Expedition 14 and 15 on my first flight. So that's why I look like a little bit of a NASCAR guy here with a lot of stuff, but it was really just one mission.
I will say, I guess if you're as an experienced crew member as Sunny is, she's actually eligible to wear a lot of patches on her flight suit. But you'll also see ones that depict how fast it took you to get you into orbit. So I have a Space Shuttle one. She could wear both a Shuttle one and a Soyuz one since she rode on two different spacecraft. She's also got a lot of days in space, and so there is a number of days in space patch that can be above the name tag. So you'll see all these things on different folks' flight suits, and I think both of us are in a configuration that matched one of our missions. So this was my last mission, and this, I think, was Sunny's first mission that she flew on. So.
Okay, interesting. So just trying to be humble with not completely decking your suit out in patches. All right, now that's your suits. For the space suits on orbit, they had a question about how much time do they allow you to be outside for?
So each of our spacewalks are generally planned for 6 to 6.5 hours. That's what, the optimum time, and that's based on, of course, fatigue for one thing, because you're in the suit for at least an hour or so beforehand, and then it takes a little while to get out of the suit also when you come back in, just for the repressurization of the airlock and then getting out of the suit. So that already is adding up to about 8 or 9 hours. And so the real driver, though, is your consumables. We have the space suit is its own spacecraft. So, of course, you have oxygen being provided by the suit. You have a tank for that. And then you also have carbon dioxide removal that's being done with the suit. Now, oxygen, we can recharge. We have an umbilical, which you probably saw when the guys were in the airlock in the beginning. They were connected to an umbilical. So you can go and reconnect that umbilical and recharge your O2. The CO2 removal, though, that's just a one-time with a canister that's in the back of the suit. So it depends, like Bob mentioned earlier today, like if you're maybe a heavy breather, you might be using up your CO2 canister a little bit faster, and so you might have a little less time. We monitor that on our space suits itself and the computer, but of course we've got the wonderful backup of folks at Mission Control who are really monitoring it on a moment-by-moment basis to understand how that canister is working, to make sure we have the EVA the right amount of time so nobody comes into a risk of getting a high CO2 in the suit. So we have, again, also procedures on our cuff checklist in case we have any type of issues that happen to be with electronics that are on the suit. Also, there's a sublimator on the suit that provides cooling, but the real determining factor is the CO2 removal. And like I said, we try to keep the spacewalks around 6.5 hours. It's pretty tiring to be out there that long and in that big suit, which is operating like a balloon. So just for everybody's comfort, that's probably a good enough time.
I would just add that I think you have some interviews with some of the neutral buoyancy lab divers coming up a little bit later this morning. And so the training that we go through at the NBL out there is typically closer to 5 or 5.5 hours. And so when we start stretching an EVA to 6.5 or 7 hours, we're actually putting crew members through a much longer, marathon than we normally put them through during training. And so we try to be careful about not kind of doubling the length, if you will, of the spacewalk compared to what they've actually seen in training. We try to match those two things up.
Right. Okay. And I guess we are coming up on the 3-hour mark for these guys. So you think they're starting to feel the fatigue a little bit at this point, based on your experience?
Definitely, and it depends a little bit on the task. And so I think that when they were working the electrical connectors, there's a little bit of fatigue involved with that because that's a task, like I said, that there's sometimes a stretch involved. Sometimes the connectors are a little bit stiff, so that can be a little bit of tiring. They'll probably get a little bit of a break while the hooks were being driven. If you were watching, they just you kind of hear the status of that. When they fold up that MLI, that insulating blanket that's on the end of the PMA, I think that'll be another opportunity for them to get a little bit fatigued.
I've heard stories about the MLIs before. Multi-layer insulation, right?
Yeah. Sorry about not clarifying that.
Blanket.
That blanket is a little
Folding
bit
in space is a little hard. Things don't tend to sit with gravity.
We should have a map folding contest from the space station.
Yeah, with these gloves on. There you go.
All right. I think we have one more question from social media we'll try and take, and that is, we talked a little bit about it being tiring, but are you ever afraid during a spacewalk, or you just stay focused on what you do?
Were you afraid during a spacewalk, Sam?
I'll have to admit and say, yeah, there were a couple times, but generally not really, because you have a lot to do. There's a lot of people who put their time and energy into it. What you're doing is pretty expensive and usually pretty critical. Like this is, we're not going out there really just to take a walk. We're actually out there to either put something together or repair. So on your mind is really like, let's get this job done and let's not make a mistake. But I will have to admit, living on Earth really does come back to you even when you're in space. On actually my first spacewalk, we were climbing up the truss because it was a little different configuration than it is right now, where we had a piece of the truss sticking straight up. And we're climbing up that, and I couldn't help having that feeling that I was climbing up a skyscraper, and my heart just, inadvertently just started to beat really fast, and I had to sort of close my eyes, convince myself that, up doesn't matter in space, just go sideways and you'll be okay. And, you just sort of switch your focus back and compartmentalize and understand where you are and get back to the task at hand. But yeah, every now and then I think it's you can't help but remember where you are, and when you realize where you are, I think you should be a little bit nervous and a little bit scared. How about yourself?
I would just say that...
Steely-eyed.
Well, I think that...
Bob Benkin.
The tasks that you go off and do can sometimes, I wouldn't call them necessarily be scary, but there can be anxiety associated with them. And so if you're doing something critical, like installing the docking adapter that only the commercial crew program and the future of launches off the Florida coast are depending on you being successful for, if you put it in those terms, I think that could make you a little bit nervous when the time went off to go off and do it. And so I think on one of my space flights, we actually installed an inspection boom. If you remember the space shuttle, you needed to inspect it after we had lost Columbia to make sure it was in good shape before you brought it inside. And so we were leaving the boom behind for a future shuttle crew. And so that was probably the task that I knew we had to do on our flight. No future spacewalkers could come up and fix that for them. So we needed to get it in a good configuration so that shuttle could get a good inspection before they came home. That was one that I had a little bit of nervousness about, making sure it was all going to go really smoothly. And we had never done that before. It was to support the GEM, the big portion of the Japanese module going up. It was so big that they couldn't bring it and this inspection boom both up with the same space shuttle. And so they were going to take ours. We were going to leave ours behind. And that was one that I would say nervous, not scared, but I really felt a lot of responsibility and nervousness about making sure that went smoothly so that those guys would have a good inspection when they came home.
Sure, that makes sense. And I guess actually you were there when Dexter was delivered as well. So
I was. When the SPDM Dexter was installed on space station, we got to go out, and I think over 3 spacewalks, get it put together and assembled the way that it needed to go. I didn't do all 3 of those. We had 4 spacewalkers on that flight, did 5 spacewalks at station, 3 of which were primarily focused on getting Dexter assembled and ready to go and do some replacement for the EVA spacewalkers, right? So.
And now we have Dexter to thank for being able to install the IDA, the docking adapter that we're so excited about seeing in place today.
Neat.
Absolutely.
All right, well, for now we're going to go take a look back and see what the spacewalkers, Jeff Williams and Kate Rubins, are doing on the space station. We'll join the commentary in progress from Mission Control. Thanks.
And Tom, how do you hear?
Jeff, we got you loud and clear.
Okay. Just heard a beep, and then momentary loss of the side tone.
And that was a caution that came up in Columbus, and there's no immediate action for the crew.
Okay.
Copy. Okay, I have the double adjustable retrieve. I'm going to come meet you at the back, Jeff.
Okay.
While Williams and Rubins work outside of the International Space Station collecting the cables, the tethers, and other equipment they used for the hard mating, and the cable connection work to lock the IDA onto PMA-2, that alarm that you heard enunciated came from the Columbus module of the International Space Station. The European Space Agency team in Oberpfaffenhofen, Germany, is currently looking at that, but there's no action for the crew to be concerned about.
And Jeff, we copied something you saw, something on your glove. We don't have a good view on the WVS. If you could just check for Vectran.
And I checked EV2. That's a little bit of a thread from the side, but there is no tear in the Vectran.
We copy, Kate.
Riser's down. Okay, how are we doing on tethers, Tom? I've got 2 doubles. Kate?
I've got a double right here that I'm going to put back in the bag. I've retrieved a single, and that's back on my mini workstation per the Egress plan.
Okay.
And I'll put that on the bag lid if you guys agree. You want it inside?
The lid is fine. They're accessible there.
So we've been following. It looks like you've got all of the adjustables and adjustable pairs from around the interface. And so we'll just continue with the outfitting. And Kate, did we get a HAP check from you?
Not yet. I'll put this adjustable down and give you one. I owe you one. Got a dry HAP. Let me get a glove inspection.
We copy. And Jeff, the planar reflector is the next for the outfitting for you.
Copy.
Tom, a good and glove inspection from AV2.
Copy, Kate. Next for you is to go back down to the H fixture and put that cover back on.
Okay, let me finish dropping the adjustable off in the bag here. Okay. Not a lot of room on the bag lid strap, so I've hooked one end of the adjustable to the bag lid strap on the port side. The other end is going back to the D-ring loop on the adjustable.
We copy, Kate, and nice view.
Headed down to the H fixture, Tom.
Copy, thanks. And Kate, for you, the connector J35 near the peripheral docking target is no touch at this time.
Copy, J35, no touch, and I see the aft side of PDT. I will not touch it.
Thank you, ma'am.
This is Mission Control Houston, 3 hours, 6 minutes into today's spacewalk. That view showing Jeff Williams at the bottom of your screen, right at the new international docking adapter that is hard mated to pressurized mating adapter number 2. That will be the new docking port, the port of call for the SpaceX Crew Dragon and Boeing CST-100 Starliner vehicles. All of the cable connections have been made that first enabled 2 gangs of hooks to close, to hard mate the IDA to PMA2. The cables were then reconfigured by Williams and Rubins to route power and data to the covered side of the IDA that you see there just above Williams, that cover to be removed a short time from now. That now will enable the new visiting vehicles, the new U.S. commercial crew vehicles, to arrive at the station and to link up for the hooks to close with their docking systems to the International Space Station. With that having been completed, outfitting of the International Docking Adapter will continue now as Williams will retrieve a planar reflector cover from a tool bag and install it
Let me know if you need them.
over that particular docking aid on PMA2 that is no longer required, while Kate Rubins is working to close a insulation cover over the grapple fixture on the IDA that the Canadarm2 Dexter special purpose dexterous manipulator grappled onto to extract the IDA from the trunk of Dragon last Wednesday night.
And Jeff, while you're working, we see that Velcro billfold still open, and your final step will be to have those closed.
Copy. I'm leaving them open to make a potential adjustment.
time, you should be able to see in WVS that the H fixture cover is installed, all the Velcro is covered, and the straps are back in place.
We see it, and we're checking.
Hey, Jeff.
Yeah?
Looking good out there.
You too. Kate.
And Kate, we're looking at the outboard corners on that top cover. Just make sure that they're all down and Velcroed.
All right, welcome back. We are still here with astronauts Sunny Williams and Bob Bankin talking now about training that the astronauts do to get ready for these spacewalks. We are in just a few minutes going to go to the Neutral Buoyancy Laboratory, a 40-foot deep swimming pool where a lot of the astronaut training takes place. But before we do that, we're going to hear just a little bit more about what the process is like. I feel like if y'all have spent, what would you say, more than 3.5 days spacewalking, I can't imagine how many multiple times of that you spent training for spacewalking. So why don't you tell us a little bit how that works?
Yeah, so you're going to see the pool before too long, so a lot of folks are going to get acquainted with how we practice for floating, and that's using the pool. But it starts before that, actually. Mm-hmm. It starts, making sure that you're going to be sized correctly. Bob talked a little bit about how the suit is a couple sizes, but then you need to get fitted for how long your arms are, how long your legs are. So there's a little bit of that going on beforehand. So we have a couple times that we go and check out the length of the suit, and then a majority of that time is actually checking your gloves and making sure you have the right size of gloves. We have gloves that are made for people in the past, and we try to use those old sizes of gloves so we don't have to make brand new gloves. But sometimes people have pretty unique hands, and you might have to have your hands fitted a couple times to make sure your gloves are going to be good for you when you're out in space, because that's the part of you that works the most, as we talked about with the electrical connector. There's another part also, and I'll let Bob tell a little bit more, but there's another part where we're actually getting in our actual spacesuit that we're going to be using in space and go into the vacuum chamber. So you actually get to experience vacuum here on Earth for the first time before you go into space. It's called the SETA chamber, and you can really see how all of the inner workings of the spacesuit work, including the electronics that are on your suit, because when we're in the pool, of course, we don't have the real electronics right there. We want to know how all the caution and warning works, how the sublimator works, how the oxygen system works, how the carbon dioxide system works. And so that's the time that you really get to try all that stuff out. So it all starts probably at least a year, probably 2 years before you're actually even going to think about being assigned for a spacewalk. I'll let Bob continue with a little bit more.
Sunny described it really well, some of the tools that you use, and you have to really think about your suit being a tool, your gloves being a tool, then the tools traditionally that you would think about, as well as the hardware that you're going to go and actually install or operate on when you're in space. And so when you go to and see the Neutral Buoyancy Laboratory and see the pool out there, you'll actually see modules that are sitting in the bottom of that pool. And Sunny did say, hey, things start a little bit before you actually get in the water there. And we do a process called the 1G, which is, not when you're floating, just on a tabletop, just in front of the real hardware, where you get to look at it and understand how it's really supposed to work. And then when you go into the NBL, you practice how it's really supposed to work. You don't necessarily operate the hardware the way it works in the NBL. You need to think about how it really operates and then try to duplicate that when you get in the water. And that's kind of a tough concept to describe. For example, the bolts don't turn the right amount of times, or they might be made of plastic and it's just something that you have to flip into place, versus the real piece of hardware is a piece of electronics. They can't put that in the Neutral Buoyancy Laboratory, but you have to imagine what you learned on that bench top, what you learned in this SETA run at vacuum in terms of how the suit's going to operate, put those two things together, and then add floating to it in the Neutral Buoyancy Laboratory. And so integrating all those things into your head takes a little bit of time. Historically, for space shuttle missions, for assembly operations, we were able to do a lot of that activity with just one set of crew members that was going to go off and do it. For Kate and Jeff, who are outside today installing this docking adapter, we had to have a team develop those procedures for them and make sure that they were in good shape and then pass them off to them. And so it really is a big team effort to pull it off because those other people have to do all that imagination and then hopefully have a great product that those guys can go off and execute.
One key other thing, particularly for folks that are living on the space station for a long time before they're going to do a spacewalk, is a place that we call a virtual reality laboratory here also. We practice there how to use the safer, that backpack on the back of your suit in case you get disconnected from the space station. But another thing they have is a tool that they call DUG, which is a computer graphics of the whole outside of the space station, and they can put the spacewalkers, maybe folks have seen it as we were getting ready for the spacewalk, those animations of where the spacewalkers are going to go and all the detail that's out on the space station, because you don't really know you know right from left, but you don't know where everything is. And so part of the way to understand where all the things on the outside of the space station is use that model and use those pieces. Maybe it's a camera, maybe it's a foot restraint as a landmark to where you're going to go when you're navigating your path to the workstation that you're at. So that virtual reality laboratory really helps us, particularly when you haven't been back here and used that pool real recently before you're going to go do a spacewalk.
Sure. Would you say you have a favorite part of training?
Which part is our favorite? Well, I think that probably the most exciting thing is, of course, the neutral buoyancy laboratory. Being out in the pool, you get to wear a spacesuit, you get to go climb around for 6 hours on space station. It's pretty exciting. And the teams out there, they just do a wonderful job of making it like it is in space as best that they can and trying to get you as ready as they can when the time comes. So I would say that's probably the most exciting thing that we get to do in terms of spacewalk training.
Yeah, and I think I agree with Bob. I think the integrated part in the VR lab is really telling also, because it really puts you into the moment, because your view is just like you're going to be in space. So I think they do just an outstanding job to connect all those dots and make it almost seem like it's real when you have those goggles on your head.
I think just like all other astronauting, the trainer's job is to try to make it harder for you in training than it is when you're in space. And so I will say the guys at the NBL do a great job of making it just a little bit harder than it is when you're actually in space, and so that you're ready for whatever comes at you when the time comes.
Yep.
Okay, well that's the perfect segue. So actually we're going to stop now, take a break, and send it over to my colleague Gary Jordan, who is at the Neutral Buoyancy Laboratory. They're talking with a couple of divers about spacewalk training. Gary?
Thank you, Brandy. I'm just a little ways down the street from the NASA Johnson Space Center at what's called the Neutral Buoyancy Laboratory. And behind me is one of the largest indoor pools in the world. It goes about 40 feet deep, 102 feet wide, and 202 feet in length. And inside are full-scale replicas of parts on the International Space Station. And astronauts commonly come here, get suited up in their spacesuits, and do runs to practice some of the EVAs, like the one today, of installing various parts and maintenance aboard the International Space Station. With me are two safety divers that work here every day and support the astronauts that do some of these runs, Sarah Kennard and Nick Pavlo. Thanks for being with us today, guys. So tell me a little bit about the Neutral Buoyancy Laboratory. Why is it good to practice some of these EVA runs in the water?
Well, Gary, it's the closest thing that we can get to a weightless environment. Obviously, we can't practice on land because of the weight. It does provide a little bit of being weightless in a sense. And one of our main jobs as safety diver is to make it more flight-like. So we have a lot of techniques and we have a lot of training that help us do that for the astronauts.
So by making it more flight-like, you mean, I guess, there's water resistance, right? So you have to kind of push and pull to simulate actual, microgravity environment?
Exactly. And then there's a lot of way-out training that we do for the astronauts. By way-outs, we shift weights around all throughout the suit, and we want to make them neutral, and in any orientation, they'll stay there. And that's kind of an idea of what we mean, like flight-like, and we do the same with tools. We have low-fidelity tools and high-fidelity tools. The low fidelity is to make it more neutral and, give the idea of weightlessness.
Awesome. So right now, 250 miles above us in the microgravity environment, Jeff Williams and Kate Rubins are performing a spacewalk to install the International Docking Adapter. But I guess this is not the first time that they've done that, right? They've done a couple practice runs here in the Neutral Buoyancy Laboratory. Can you tell me about that? Did you guys actually have a part in it?
Yes, sir, we did. We've been supporting the IDA install runs ever since 2014. That consists of approximately 20 installation runs, and another 60 support runs where we were doing various tasks from running cables, checking connections, and also practicing for different contingencies or anomalies that might occur. So all in all, roughly about 300 hours worth of practice.
Wow, that is incredible. So I guess they are kind of experts on doing these kinds of runs.
Yes, they certainly are.
So the astronauts, I guess they come here not just for international docking adapter runs, but also for other EVAs. What kinds of things do you encounter on a day-to-day basis for some of these runs in the Neutral Buoyancy Laboratory?
Well, we can do anything here that's going to require regular maintenance or repair to the space station. What we're doing today is actually set up for a battery exchange run that we're going to do on Monday, just practicing going out to one of the IEAs and changing out different batteries and things like that. So kind of common repair and maintenance things is what we practice now.
Awesome. And how often do you kind of do those runs, maybe on a weekly basis?
We do about 3 to 4 runs a week. Each run is about 6 hours.
6 hours. And what about the role of the divers? I guess inside the astronauts that are suited up in the spacesuits are there for about 6 hours, but do you guys do shifts?
We do. We do 3 2-hour shifts. And on average, we're diving about 2.5 hours a day.
2.5 hours. And this is to, I guess, just to make sure that you guys are healthy and safe and don't get too cold?
Yeah, that's absolutely right. The astronauts have the ability to stay in the pool for anywhere from 6 to 8 hours, but they change us out just to make sure that even in 86-degree water, we don't develop hypothermia and we can still provide that adequate safety support that the astronauts need.
That makes sense. So behind us, I guess, I don't know if you'd be able to see it on camera, but we have a couple cranes here. Do you guys actually move some of the segments in the underwater kind of frequently or no?
Yeah, absolutely. Even yesterday, we rotated the P6. Wednesdays are usually our off days, and we'll take the mock-ups out and we'll repair them or we'll rotate them or move them. So.
Awesome. So specifically for the run dealing with the installation of the International Docking Adapter, which Jeff Williams and Kate Rubins are doing right now in space, I guess both of you had a part in it. What was that like, that experience working with Williams and Rubins?
Well, as we mentioned earlier, we certainly got a lot of practice working with all different types of crew for this run. It's not just Williams and Rubins who have practiced this, but what we've learned doing this run so many times is that while we practice way-outs on the astronauts and various tools and ORUs over the last few years, IDA presented some new challenges, new types of tools that were used that we kind of had to think outside the box on. We've developed different techniques for applying foam to the keyring cap keeper and being able to quickly release that foam and deploy it so it doesn't get in the astronaut's way. It seems like small nominal things, but little ounces of weight make a big difference to the astronaut in the pool. As Sarah said, we're really trying to make sure that it is as flight-like as possible.
Exactly. So I guess that's why you do it so many times, right? You said you had so many runs practicing this, and it's to fix any sort of things that may come up that weren't expected, if I'm right in saying that.
Yeah, absolutely. There are a lot of limitations that we might have in the pool, but as divers, one of our main jobs, just like Nick said, is to kind of fix those or try to make it, like I said, more flight-like for the astronauts. So that was something that we did get a lot of practice on and we did work a lot on.
Awesome. So, all right, besides the International Docking Adapter runs, what else can you expect to do here at the Neutral Buoyancy Laboratory?
Well, now that the space station is built and we're mainly just worried about repair and maintenance and things like that, it gives us the freedom to kind of work into some newer projects, bring Orion in every now and then and practice with the Air Force crew and the astronaut crew that are going to be going up in Orion, and then the Air Force crew that will be used to recover them. We practice with new types of tools that are being designed by college teams all around the country and in some cases around the world. We practice ROV events, competitions, and things like that. So this is actually one of the more exciting times in the NBL's history where we're seeing a lot of new projects and kind of the next phase of what NASA's going into beyond space station.
Well, you guys seem like you have a very busy schedule ahead of you and a lot of activities coming up on a day-to-day basis. But in the meantime, we have a spacewalk going on right now with Jeff Williams and Kate Rubins up in space. We'll go back to you, Brandy, at NASA Johnson Space Center. Thanks for having us.
Thanks so much, Gary, Sarah, and Nick. That was very interesting. And obviously, the training is working pretty well. Why don't we check back in now with Kate Rubins and Jeff Williams on orbit. And just remember that you can keep sending in your questions using the hashtag AskNASA and see a behind-the-scenes look on Snapchat if you follow NASA or by checking out Instagram at ISS. Back now to mission coverage.
This is Mission Control Houston, 3 hours 25 minutes into the spacewalk. A new docking port now resides at the International Space Station. You're looking at it. It is the first of two international docking adapters. This one permanently mated to pressurized mating adapter number 2, the port to which space shuttles used to dock. The new IDA is the port of call to which the new U.S. commercial crew vehicles will link up to. Jeff Williams and Kate Rubins, working extremely efficiently, are in the process of cleaning up the work site at PMA-2. They will be next moving on to the installation of 2 docking targets called hemi-reflectors on both the space-facing side and the Earth-facing side of that international docking adapter. The IDA has a mass of 1,021 pounds, 42 inches tall, 63 inches wide, with an outer diameter of 94 inches.
Once we do a glove inspection and another HAP check, and then Jeff, yes, you'll have reflectors in your future.
Copy. HAP check is nominal. Glove check is good.
Glove check nominal for EV2 and dry HAP.
We copied. So Jeff, you'll be moving that reflector bag. We think it's a good idea to put over on the about 9 o'clock so you can get access to both stanchions. And I have a handrail if you'd like it.
And I can assist. I am already at the stanchion here.
Copy, Kate. That would be reflector alpha.
Okay.
Okay, I'll stabilize the bag. Here, let me turn it over.
And for you both, just to remember to leave the pit pin in the stowage location when you take it out so the pit pin doesn't hit the reflector.
Copy. Let me move this over here.
And another public service announcement: to avoid contact with the black face of the reflector, use the handle only.
Copy. You're ready at B, right?
I'm going to be A. You're going to be
That's right.
Bravo. A up on the Venus side here. And Tom, I know that the PDT is in front of me, and I'm on the planar reflector. I'm being very careful here.
Copy. Thanks for those words. As you know, just stay away from that. And just a reminder, the handle of the reflector is going to be pointing aft towards PMA-2 when you soft dock it.
Copy.
There's yours.
Thank you. Tom, I have reflector alpha soft docked at the 12 o'clock position.
Copy. You can move the pit pin from the stowage location to the trunnion and give it a pull test.
Pin is in the trunnion location. I have a good pull test of reflector alpha. This should go. I'll send the right back to the bag.
You're good for that, then verify the lanyard cannot float in front of the reflector.
Okay, that's coming back to the bag. And the lanyard is aft. I think you should see this in my WVS. Cannot float in front of the reflector.
We copy, Kate. Nice job. The only thing left for you is to head back onto the port side. We'd like some closeout photos. If you can go down to the connector panel and for the cabling, Hemi reflector if you think you still need to get some more. And that'll be close to all the work for you.
This is Mission Control Houston, 3.5 hours into today's spacewalk. Kate Rubins has installed the two so-called Hemi reflectors. You just saw a shot of that as the International Space Station flies from southwest to northeast, paralleling the east coast of the United States, currently over the North Atlantic Ocean. Those Hemi reflectors are essentially docking aids that will provide visual cues for the approaching U.S. commercial crew vehicles as they are on final approach for contact and capture to the newly installed International Docking Adapter. Rubins and Williams will soon begin their cleanup of all of their tools and equipment in the vicinity of the International Docking Adapter. The likelihood is, with time still available, that they may be allowed to press on to some get-ahead work.
Video of you right now, but if you're getting close to the B stanchion, the handle for your reflector also goes aft towards PMA2.
Copy.
And Kate, if it's possible, to get pictures also of the IDA interface, just making sure you don't go out, it's still no touch.
Understand.
If the permission is given by Flight Director Zeb Scoville for these get-ahead tasks, those tasks would include the tie down of brake handles on one of the crew equipment carts that resides out on the truss of the International Space Station, on the port truss of the station, as well as photographs that they would take of some of the insulation on the starboard truss of the Alpha Magnetic Spectrometer, the AMS, that was installed during the STS-134 mission back in May of 2011. Some of that insulation is beginning to fray a bit through the passage of time, and consideration is being given to a Hubble Space Telescope servicing style series of spacewalks that would upgrade some of the outer thermal insulation on the AMS for the years ahead.
Okay, Tom, I'm going to head down to, I got myself a new workstation cleaned up. The colors are all looking good. I'm going to head down to the PMA Hemi reflector. If you have a priority order for photos of the connector panel, of IDA and Hemi reflector?
We're checking. And Kate, we don't have a priority order. Just do what you feel like you have time for.
Your clock. We are on your time here. We're happy to do anything you'd like us to.
So we'll go ahead and then get all the pictures you want there, particularly because the lighting conditions are so nice.
Understand.
As they say, you can never have too many photos, so Kate Rubins and Jeff Williams more than willing to continue snapping away closeout photos for the engineers on the ground of the newly installed international docking adapter and its associated cabling that hooked it up earlier this morning to pressurized mating adapter number 2. The second of 2 gangs of hooks closed and a hard mate was declared at 9:40 a.m. Central Time, just about 2 hours and 36 minutes into the spacewalk.
I copy you, Seth. Okay.
And Jeff, we'll see you starting to bundle the 2 bags, and we'll take the reflector bag inventory as well.
Reds inside and 1 large small red on the outside. Then it's ready to the bag.
We copy. That sounds great. Thank you.
Yeah, Tom, I have photos of the Hemming reflector panel, and just wondering how high priority the connector panel is going to be. That's going to take a while to get out there and get set up. I'm already pretty far back on there, too, and could easily start back to the airlock to ST2. Or get my APFR.
Okay, Kate. We think we're good with the pictures this time. So we're good for, why don't we get a mini workstation inventory from you at this time, and then we'll press on.
Okay. I have a PIP 10 RET, regular RET, and 2 adjustables on my mini workstation. On my swing arm, I have a wire-tied test guide and a camera. On my BRT, I have short wire ties and a long wire tie.
We copy. And we're only missing the RET on your BRT, Kate.
Yes, I'm sorry. I cut eyes on that. Yes, I have a RET on my BRT.
Copy. So, Kate, you can go ahead and grab your APFR and start heading back to the airlock.
Work. Jeff, how are you doing?
I'm bundling the bag. which is as much fun as I anticipated.
Let me know if you need help.
Okay.
This is Mission Control Houston. Jeff Williams and Kate Rubins still gathering up the last of their tools, tethers, and other equipment before heading back to the Quest airlock away from the pressurized mating adapter number 2 work site that has been their work site for this entire spacewalk in support of the attachment of the new international docking adapter. Once back at the Quest airlock, they'll put all of their equipment back inside and await further word on whether or not we will press ahead for get-ahead tasks.
The next step is to go ahead and fully mate that J9 connector.
Okay.
The J9 connector that was soft docked, if you will, or partially mated about an hour ago, that's the final connector that will provide power to the international docking adapter for the arrival of visiting vehicles that will link up to the so-called passive soft capture system that the thermal cover was removed from a short time ago.
Nine connectors forward over center.
Work.
We copy, Jeff. And while you're there, I believe you said you already got some pictures of the panel. If not, now would be a good time. And Jeff, I'm hearing it would be nice to get a picture of the final config.
Okay.
Yeah, Jeff, I'm at my APSR, working on getting that onto my BR2.
Copy. Hopefully it treats you better coming back.
I am hoping.
This is Mission Control Houston from Kate Rubins' helmet camera. a view of the SpaceX Dragon cargo craft that transported the International Docking Adapter to the International Space Station. It was launched atop the SpaceX Falcon 9 rocket from the Cape Canaveral Air Force Station on July 18th, arriving at the station 2 days later. The IDA was housed inside the unpressurized trunk of Dragon, the aft portion of the spacecraft, and was extracted robotically this past Wednesday and maneuvered to its pre-installed position. Of course, the IDA was firmly installed and hard-mated to pressurized mating adapter number 2 about an hour or so ago.
Copy, Jeff.
Tom, I'm having the same issue where the locking collar isn't fully opening, so I cannot depress the 4 pedals below the locking collar.
We copy, Kate. We're wondering if you're getting some more. We're wondering if you're getting more side loads from your ingress aid being out. You might want to pull that in, see if that helps.
Okay, understand. I don't see any side lights, but I will go return to the ingress aid.
And Jeff, once you're happy with your work site, it's clear of all tools and tethers and such, we'd like a mini workstation inventory from you.
Okay. I've got the camera and the swing arm and its integral racks. I've got BRT with a rack on it. I've got one rack, my mini workstation without a pit pin. And I've got one with a pit pin. And I've got a trash bag.
We copy and we're checking.
Okay. Frankly, I've lost track of what adjustable I still had thought I had on my mini workstation.
As you watch this view from Kate Rubins' helmet camera looking down at the SpaceX Dragon cargo craft, just a reminder, SpaceX will be at the International Space Station. The Dragon will be for one more week. 1 week from today, it will be unberthed and released at 5:10 a.m. Central Time from the Canadarm2 under the control of Williams and Rubins, heading for a splashdown in the Pacific.
Tom, can you remind
Later that morning, a parachute-assisted splashdown, of course, to bring home critical science samples and other cargo from the International Space Station.
Yes, you just want to push on the ingress aid. You can move it down, friction only, down to the boot plate.
Copy. There's a lot of friction. I figured I'd check there wasn't a locking mechanism.
You're right, and not a surprise that it's difficult to do, so if you want to get out on the end of it and pull it down, that might help.
Understand.
Also, if you want to pitch the whole thing out away from the structure, that'll ensure that you're not putting loads in.
I got it folded for Tom's suggestion. And
We see it, Kate, and we love it.
I've got the boot plate yacht around so that there's a good gap between structure. I'm going to try the locking collar once again. And I'm still feeling it just run up against the hard stop. Not to press the pedals.
We copy, Kate, and we're talking.
Got a red on it?
I do have red on it. This is the same thing. I don't think it's changed.
Rubins and Williams continuing to gather up all of their equipment before they make it back towards the Quest airlock. 3 hours, 49 minutes now into the spacewalk, and there they are together at the interface between the newly installed International Docking Adapter and Pressurized Mating Adapter number 2.
It's the hardware.
They're in the process of removing the portable foot restraints that they used at the various work sites on PMA2 to allow them the leverage that they needed for the installation of the cable connectors.
Some more words from you on the difficulty of removing that. If it is a degraded APFR, you could swap them and put that degraded one back up on the top of Columbus, and then Kate, you could take back Jeff's APFR. Any more words on the difficulty of removing that?
I'm going to let Jeff answer that because he's installed and removed a lot more APFRs than I have. I think it might have been the inside loads.
Tom, I think it was just finding the sweet spot.
Copy that. Thanks for the words, and let's press on with the nominal plan. Kate, you can go ahead and bring that one back.
Okay, copy. And Tom, you had wanted a FOD check inside the WIF from earlier. I'm taking a look at it. I do not see any FOD.
Great. We'll check that off. Thank you. So, Jeff, we have next for you to return your APFR to Columbus.
Copy.
Okay, Tom, I have the APFR on my BRT. Jaws are closed. I have it tucked back against me and ready for translation to ESP2 if you are. And I see sunset coming soon.
We're ready for you to head back. Yes, ma'am.
Okay. Jeff, how are you doing?
Good. It's my turn to wrestle with APFR.
I don't know that I'd be much help, but I'm happy to assist.
Yeah, thank you. Okay, Tom, I have dropped a local tether and I've read it to the APFR. Let's see if I can release it.
Copy, Jeff.
And it's released. And on my BRT.
This is Mission Control Houston, approaching the 4-hour mark into today's spacewalk. Everything continuing to go very smoothly for Jeff Williams and Kate Rubins. Their spacesuits functioning perfectly as they have throughout the course of the day. A new docking port now firmly installed on PMA2.
20-second handover, and also about 6 minutes from sunset.
Copy. You doing, Kate? You on your way?
Yep, I am on my way. At node 2 still. And you're right, it's the...
I'm at node 2.
CFR's got a lot of inertia. I've got my DRTs locked down as I can get it.
Yeah.
With the International Docking Adapter now a permanent fixture on the International Space Station for the future era of U.S. commercial crew vehicles arriving at the complex. The crew is still running some 20 to 30 minutes ahead of the timeline. Flight Director Zeb Scoville and the lead spacewalk officer, Glenda Brown, here in Mission Control will be talking shortly to see what the next course of action for the crew is after they return their tools and tethers to the Quest airlock. We have a series of get-ahead tasks, nothing that is mandatory, of course. That's why they are bonus tasks for the crew if time permits. So we will see how things are pressing along and determine what may be in the offing for the crew for the remainder of the day.
Welcome back. If you've been following along, you know that the spacewalk is going very well. Jeff Williams and Kate Rubins making really good time on the installation of the International Docking Adapter. And to talk with us next, tell us a little bit more about what that means for us, we have Steve Stitch, who is the Deputy of the Commercial Crew Program at NASA. That's a big milestone for them today since the Commercial Crew Program needs the docking adapter to be able to dock to the International Space Station, right?
That's correct, Brandy. Thank you very much. It's great to be here. I can't be more excited right now. The spacewalk has gone just about perfect. And first of all, I want to congratulate the ISS program, the EVA project office, all those who've worked so hard to put this together for us. It's really a momentous day when I sit here and think about the fact that that docking adapter is just about perfect for us to come to dock to it next year. So it's a huge milestone in our program. It's just been an incredible week for us. If you really look back a week ago, last Friday, we hot-fired the RL-10 engine, and we'll talk a little bit more about that. SpaceX then had a successful parachute drop test on Saturday.
Mm-hmm.
Sunday, SpaceX had another launch, commercial launch, but we follow every one of those launches. Moving into Monday, we were able to get ULA and Boeing got the crew access arm installed at Launch Complex 41. And then here we are today with a spacewalk getting the International Docking Adapter installed on Space Station. So, I mean, it's just been an incredible week for us, and this is a huge milestone for us as we get ready to go fly these vehicles.
Right, right. So not just a big day, but a big week for the whole program, and this is a great way to wrap it up. But this probably seems like a little bit of a basic question, but I'm betting there's a lot of people who are watching who don't, think about it day in and day out like we do, and may not really understand exactly, all the different ins and outs of human spaceflight. So can you give us kind of human spaceflight 101 and talk about what commercial crew is versus what we do on the space station, or what we do with, say, Orion and the Space Launch System that are coming up?
Okay. Yeah, right now the commercial crew program is really focused on restoring our capability to take the crew to the space station. And we'll be doing that very soon with test flights next year. And so the program is structured a little differently than other programs. In the past, NASA owned the vehicles that we would transport our crew. NASA owned the space shuttle. For this program, it's a little different. We're actually buying a service from both Boeing and SpaceX to transport our crew, and then about 200 pounds of cargo to the space station. The vehicle stays docked for about 210 days for the entire increment that the crew's there, and then it serves as a lifeboat while it's there. And so it's a little different model than we've had in the past. We started this model buying a service from industry on the cargo vehicles, Orbital and SpaceX, and now we've added Sierra Nevada to that mix. And so we do it under a fixed price contract structure. But the nuts and bolts of flying people in space really hasn't changed. I tell everybody, people ask what's different about this than the space shuttle program. the physics, the hard part of getting the crew off the Earth, launched into space, the speed required, 17,500 miles per hour, it's really all the same. And we have to take that same attention to detail, and both companies, both Boeing and SpaceX, are doing that. We do work hand in hand with the Orion program and SLS program. You know, those are two vehicles that are planned to go beyond low Earth orbit, beyond the space station, into cislunar space and someday Mars. But our program works a lot with the Orion program. For example, the parachute testing that Orion does, the Boeing parachute system that they have on their Starliner CST-100 is very similar to Orion. So we share data, we share test data back and forth between those programs.
All right, so we've got the space station up there, home for people 24/7, 365 days a year, and we've got the cargo vehicles, commercial cargo vehicles, taking supplies and science up there for them to work on. Soon we'll have the commercial crew vehicles taking people to the space station, and then following that, our NASA Orion vehicle with the Space Launch System taking people even farther out into space. So
That's correct. We've started with the cargo vehicles. They fly routinely to the space station. You know, it's pretty interesting when you think about this International Docking Adapter. It was built by Boeing for the ISS program. It's transported up in a SpaceX Dragon cargo vehicle in their trunk, was extracted by the Canadian arm and placed on the space station, and it's there in place for the commercial crew vehicles that are going to be transporting 4 crew members to the space station. So if you really think about that whole orchestration, it's really an amazing feat to make all that happen. But yeah, we're about transporting 4 crew members to space station. Today in the Soyuz, we were able to transport 3 crew members to the space station. When we add that 4th crew member, we'll be able to basically double the amount of research we're doing on the space station. And so if you think about the cargo vehicles today, they're really very much focused on not only resupplying the crew, but bringing up science experiments for the crew to do. And so we're in this utilization stage of space station right now. And it's very important that we have now a 4th USOS crew member to execute that research. And so that's a very important part of our program.
All right, and the docking adapter that Jeff Williams and Kate Rubins just installed is what's going to allow these commercial crew vehicles to dock to the space station. How long do you think before we're using that?
Yeah, that's a very good question. So right now we have a couple of test flights under our contract. Each company proposes their number of test flights, and at least one of those flights has to have a crew on board. So I'll start with Boeing. Boeing has plans to do an uncrewed test flight in the December 2017 timeframe, and then follow that up with a crewed flight test in the February timeframe of 2018. So we're working toward those milestones, and you know, it really is upon me today how soon those flights will be. For some people that may seem like a long time. In terms of all the hardware and preparation and getting the spacecraft and the launch vehicle together and the crews trained, it really isn't a lot of time, so it's very exciting. And then SpaceX also has, they call their, and Boeing calls their flights orbital flight tests for the uncrewed flight test, and then the crewed flight test for the crewed mission. SpaceX has 2 similar missions. One of them is called Demonstration Mission 1, and that will occur in the May 2017 timeframe. And then they have a Demonstration 2 mission, which is their crewed flight test, and that will occur in the August timeframe. And so if you really look at the next year, and really toward the end of this year, it's a very busy time frame for both those companies, and then for our commercial crew program and the ISS program. It's a partnership between all these entities to make this happen.
That to me also sounds like it's just around the corner. Lots to do before then, and lots going on, as you said already, right now. And maybe you can give us an update on some of the progress that we're making. I think we've got some photos and even a little bit of video to show.
Okay.
I think the first photo we had was of the SpaceX pressure vessel test that was recently.
Okay. This is a test that SpaceX has executed out at their Hawthorne facility. So this is what's called a structural test article. And so anytime you put a spacecraft in space, there's a lot of analysis that has to go on to make sure that the structure is very much optimized for weight. You want to really minimize the mass that you take into orbit and carry everything that you need to carry in terms of the crew and cargo. So this is a structural test article out at Hawthorne, and basically they put it in a fixture. They can test the pressure inside, so you can pump up the pressure to simulate the vacuum of space where there's a delta between the 1 atmosphere or the 14.7 psi inside and the vacuum outside. And then also, if you look at the upper left-hand part of the picture, you'll see a strut pushing in on this structural test article. And you can basically push on the spacecraft in all the ways that you would get loading on through the various phases of flight, whether it be the launch phase or the entry phase or on orbit. You can kind of push on the structure and see how it deflects, and then you can anchor that to all the analysis and then determine that spacecraft is ready to go fly. So this is a very important part of our structural testing going on right now at Hawthorne for SpaceX.
Okay. And this is, I think, a photo of the Boeing Starliner.
Yes, this is what's called the C3PF. So this is the old Orbiter Processing Facility 3, where we used to process the orbiters and the main engines. And this is where Boeing will do the assembly of their spacecraft. Right now they have two vehicles in there. They have their structural test article, which they're prepping to ship out to Huntington Beach in California for some testing later this year. They're going to do the same kinds of tests with the CST-100 vehicle. They'll put them through vibe test, and they'll push on the structure and see how it responds, and they'll do pressurized tests as well out at Huntington Beach. And then they also have what they call their Spacecraft 1, which will go in and be their pad abort vehicle. And so they have both those vehicles in this facility. So all their vehicles will come through here. They'll be assembled in Florida and put together and then sent out for the various missions. And so Boeing has done a lot of work in getting this facility, all the test stands set up in this facility over the last few months, and it's really coming together nicely.
Okay. And I think the next one up is an engine test firing that just occurred last week.
Yes, this is a picture of the crew out at West Palm Beach, Florida, and on the left-hand side you can see an engine, and that's called the RL-10 engine. And this engine's been used for approximately 50 years of putting various spacecraft into various orbits, interplanetary missions, and lots of launches. And we're using this engine as part of the Atlas launch vehicle. It's on a stage called the Centaur, and there's 2 of these engines on the Centaur, which will push the crew into the final orbit and insert them into the final orbit. This test firing was the second engine for the crewed flight test. And so we've already test fired the first engine, and it's been shipped down to the Decatur facility for integration into the Centaur stage. They did a series of tests with the crew there present. It's got about 23,000 pounds of thrust, so if you think about the shuttle orbital maneuvering system engine, that's about 4 times the thrust to put the spacecraft into orbit. And the crew watched this test firing, a couple of different test firings, really wringing the engine out and putting it through its paces. And it was a very successful test flight firing. So when you start to think about the engines for the real rockets are actually being test fired, that timeline begins to really crystallize in your mind that those flights are really upon us.
Sure. I think the last photo we have is of the launch pad at Kennedy.
Yes, this is the old shuttle launch pad 39A. This has been leased to SpaceX, and SpaceX plans to use this launch pad for their crewed launches. So they're in the process of reconfiguring this tower. They've removed probably 500,000 pounds of steel from the tower already. Wow. They've modified the flame trench for their rocket. They've installed a rail system to bring the Falcon 9 vehicle out of their hangar and then up into the configuration for launch. They've got a big strong back that raises that vehicle up. They've tested that. Here later on this year and into the fall time frame, they'll actually put their crew access arm up. And so when you go to Florida and you look at the changes, the program awarded these contracts a little over 18 months ago, and you look at the amazing progress that both companies have made, it's truly remarkable. And every time you go, you see these changes in the launch pads and more infrastructure being put in place for our launches.
And one other test that just took place this past weekend was the SpaceX parachute drop test, and I think we have some video of that as well. But maybe you can tell us a little bit. That was just on Saturday, was it?
Saturday, yeah.
And I think this is...
So this is the SpaceX parachute test. And this
parachute tests are always such cool video.
Yes, yes. This is a C-130 aircraft out at the Mesa, Arizona test range. That's the programmer chute that pulls, that sort of stabilizes the vehicle before the 2 drogues are deployed. Those are drogue what's called drogue parachutes that stabilizes the capsule. Those are real chutes that will be used in flight. And then that transitions, the drogues are released, and then they have 4 main parachutes. And then those fully, they start out in a reef configuration, and then those are deployed, and you can see the vehicle with those 4 beautiful chutes landing very softly in the desert.
Very cool. So I guess the upshot is that you are seeing actual test and hardware coming together, getting ready for those flights that I think you said test flights starting next year.
Absolutely. You know, if you just look at the pace in the program, it's really been incredible. Not only have both companies started this detailed parachute testing, that was the actual configuration, 4 chutes, 2 drogues that will fly in flight, very important. Both companies have started working on their spacesuits and are into, these are the launch and entry suits that protect the crew. That work is ongoing. Both companies are in the process of test firing the engines, the rocket engines, which will steer both spacecraft up to the space station. So it's exciting to watch that. Both companies have started laying out their operations and how they'll operate the spacecraft. Here at JSC, Boeing has already installed some trainers over in Building 5, which the crew can use to train. In fact, I got to go over there just yesterday and do a little docking run from 10 feet, which was...
How did you do?
I did pretty well. I was able to dock. So, the spacecraft is planned to be flown automatically, but I was able to do it manually, and so they've got that backup, and it's interesting. The cockpit is laid out very much like you would think, a little bit more modern than the shuttle. SpaceX is doing the same thing out at Hawthorne. They're laying out their trainers, starting to figure out how they lay out their displays. So we're seeing that work happen. We're starting to talk about a lot more of the operational kinds of things. We're starting to talk about launch commit criteria and the flight rules and things that, so we kind of know it's getting closer when we're in that phase.
Great. Well, you mentioned that you have kind of seen the inside of the cockpit of the Starliner, and we actually have a tour of the cockpit that Boeing sent over with Chris Ferguson, former astronaut. So we'll take a look at that next and then come back and talk a little bit more with Steve Stitch.
Thank you. We're here in the Commercial Crew and Cargo Processing Facility at NASA's Kennedy Space Center in Florida. And joining us is Chris Ferguson. He is a 3-time Space Shuttle astronaut. He commanded the final Space Shuttle flight, STS-135, where he committed to the world that America would never stop exploring. And today he is the Deputy Program Manager of the Commercial Crew Program for Boeing. So Chris, tell me a little bit about where we are today and the historical significance of where we are.
Sure, Rebecca. This used to be the Orbiter Processing Building number 3. Now we call it the Commercial Crew and Cargo Processing Building. There's a lot of history in here. Where we're standing used to be part of the large array of platforms that surrounded the space shuttle when it was in here for processing. We've since cleaned it up, and now we use it to build our crew module or service module that we're going to launch next year.
And so tell me a little bit about what is inside the facility today. What sort of progress have we made?
Well, in addition to this great mock-up we have behind us that we've actually done some training on, when we get a chance to walk around, we'll see our structural test article. That's sort of the first vestiges of a real spacecraft. We're going to pull it and push it and bend it and make sure that it has the necessary structural properties to withstand the rigors of space. And then on the other side, we build the service module, which is the cylindrical portion we use for orbiting maneuvers while we're in space. And then we have the initial parts of our very first spacecraft here too, so that will eventually go on to become our pad abort test. We took out a lot of the space shuttle infrastructure. We've added this, what we call ante-room right here, which is where we'll position our spacecraft before it goes outside to get fueled with hypergolic fuels. So we made a lot of changes, and we have office spaces upstairs now that have been completely refurbished. So it's a great environment. It's a collaborative environment where the engineers can work together with the technicians to rapidly push the vehicle out the front door.
Speaking of vehicles, that mock-up behind us looks great. You want to go take a look inside?
Absolutely. Let's go.
Tell me a little bit about the mock-up that we're sitting in now. What's it used for today?
Well, just a few days ago, we had some of the commercial crew members in here. They had an opportunity to put on the spacesuit, climb into the seat, and before that, we had surveyed everything to make sure that nothing moved. It's very important to ensure that everything fits. And after you build the vehicle is not the time to decide that something is too far away, I can't reach it. So this is primarily what we use it for. We also see what you see around some cargo. We fit check the cargo, we make sure that the shelves work, we get all the crew members in, we do timed egress exercises.
So I did notice that sort of up here in this general area, we have a great picture of the International Space Station. What does that signify for your team?
That's a goal. That's where we're headed someday. Now, of course, through the small window that'll be in the hatch prior to docking, you'll actually be able to see the space station out there. But of course, that is the direction to the International Space Station once we are docked. And because of the way our navigation sensors are oriented, we always will point at the space station prior to docking. So, you know, that's sort of the gateway to the next world right there.
Significant-wise, international docking adapter, is that kind of where we will connect to the station through the docking adapter?
The docking adapter takes the PMA, which was a former version of the mating adapter that's currently on the International Space Station that has gotten old. And there's a new international docking standard, so it's sort of like a conversion plug, if you will, for the new spacecraft, the commercial spacecraft that are visiting the International Space Station, and we have to put that on before we can dock. So that's step one.
Okay. So today, Kate Rubins and Jeffrey Williams are connecting International Docking Adapter 2 to the station. What would you say to them about Starliner and what they're doing up there?
I'd say do a good job, because we're counting on them, because until they do their job, we can't do ours. I had the opportunity to fly with Jeff on the ISS several years ago during his first long increment, so it's special to see him go. And, you know, of course, Kate was a rookie not too long ago when I left the office, so it's great to see some of the young astronauts have these great opportunities to go out and do spacewalks. So I'd say, you know, hey, go team, get her done, and we'll be up to sea in about a year and a half.
What kinds of things are we doing right now to get ready, and what kinds of things can the public look forward to in the next year and a half?
Well, we have a lot of dynamic tests coming up. So, you know, a lot of the engineering work is behind us. The drawings are all in work. We're fabricating actual parts of the spacecraft, but we're also testing some big things. You know, up at the Langley Research Center, we're dropping our vehicle, a replica of our vehicle, on the airbags on which it will land on. We're doing that several times in various configurations to make sure it's safe. And then later this month, later in the month of August, we'll drop a full vehicle from a balloon from 40,000 feet at White Sands test facility out in the western United States. That'll be very exciting. We're currently undergoing test firings of our thrusters that will propel the spacecraft around at White Sands as well. So there's a lot going on, and it's going to get more exciting as the middle of next year approaches.
Chris, is there anything innovative about the Starliner interior?
Well, one of the things you notice, I mean, it's not a huge vessel. It's not as large as the space shuttle was, but there is still ample room in here for 4 NASA crew members and up to 5 if we should choose to fly a 5th crew member someday. But this is really what you're going to see inside the vehicle. You know, the space shuttle had over 2,000 switches in it. We really got it down to a much more simpler architecture. In the instrument console you see behind me, there's probably 40 to 50 switches and an interactive display that performs a lot of the functions that all those hardware switches used to on the space shuttle. So we have shrunk the footprint of the way the crew interacts with the vehicle considerably since, you know, the shuttle program and, of course, its predecessors, the Apollo, Gemini, and Mercury.
Right. Previously, you mentioned the commercial crew astronauts, and you know, one of the things I find fascinating with this program is that we are providing a full service to NASA. So the spacesuits, the vehicle, and also the training too, and that's kind of your baby. So talk a little bit about the training.
Well, you know, training is very near and dear to all astronauts' hearts because unlike, you know, learning to fly, where you can go out and fly a trainer airplane, there is no such thing as a trainer rocket ship. All the training you do has to be in a simulated environment. So we build high-fidelity simulations that emulate the spacecraft to a T. We will be operating our simulation capability at the Johnson Space Center, which is a place very familiar to all the astronauts. And we'll be doing some of our training actually in the neutral buoyancy lab, not too far away from there. We'll have a mock-up not unlike this in Building 9, the space vehicle mock-up facility. So everyone, the general public has an opportunity to pass through that as they, as they tour the center. Will be able to see our vehicle next to all of the other vehicles that NASA is working with. And you mentioned the commercial crew astronauts, the cadre of 4. Well, it's just great working with them. I'd worked with them in a different capacity throughout the years, but they're very helpful. They're obviously very passionate, and they want to see us, through to safe completion and resumption of flights from American soil to the International Space Station as much as we do.
So, take me to sort of launch day in 2017. What will that feel like?
Well, at Pad 41, which is where the Atlas V currently launches and what our spacecraft will be on launch day, it's been around since the 60s. It's been around a very long time, but there's a huge new structure out there, access tower to get the crew into the vehicle, because formerly it was uncrewed payloads and we never worried about accessing the payload when it was out at the pad, but with the crew members, and we want to get them in a couple hours beforehand. So we had to build that, and that's been a work in progress. There's some significant milestones coming up with that very soon. But aside from that, take launch day, contrast it with the space shuttle launch day. I don't think it's going to be that different. The crew will likely stay where they've always stayed the night before launch. We'll drive them out to the launch pad. We're going to take a different direction because it's a different launch pad. But we'll get them inserted, strapped into their vehicle about 2 hours before launch. And they'll be talking to similar voices in a different place, the Atlas Spaceflight Operations Center, which is not too far away from the pad itself. And then as soon as the astronauts leave the pad, then they'll go back to very familiar voices in the Mission Control Center in Houston, Texas.
Very nice. Well, thank you, Chris. Thanks for joining us. And, any final words for the crew on board the station today?
No, it's great. Go out there. Do a wonderful job. We're counting on you.
Thanks.
As Chris Ferguson said there, I think the crew is doing a wonderful job. They're making still great progress in the spacewalk, and we will take a look back at that pretty soon. But obviously, if we got to see inside the Starliner, we didn't want to pass up the chance to see inside the SpaceX Crew Dragon as well. So we have a video that gives you a look at that as well. So a good look there at both the Boeing Starliner and the SpaceX Crew Dragon, and what I guess kind of the future looks like for crews going to the International Space Station. I think looks a lot different than the space shuttle. Do you think that is because, well, I guess, the space shuttle was designed more than 30 years ago, but also we've got commercial companies kind of being allowed to innovate?
Yeah, I think there are some differences between both vehicles and the space shuttle. The space shuttle was designed in the 1970s. It had that unique characteristic that it had to land like an airplane and launch like a rocket, and so there were some unique things laying out the cockpits. In that time frame, as Chris Ferguson alluded to, most aircraft had switches all over, and now you see both companies use a lot of the more modern cockpit layouts, a lot of nice displays, in some cases more touchscreen type applications. And so you see the differences, and we've let the companies really decide kind of how to lay out their cockpit the best. We've given them some overall requirements of how it needs to operate, but we let them kind of innovate. And so I think that's the unique thing about our program, and that we take the best of what NASA has learned over our time in 50 years of human spaceflight and let the companies survey the market of what's out there in terms of the new technology, and then use that technology to lay out their cockpit.
Well, it's really interesting to get that look. Now, actually, we're going to go take some questions from social media. We have a few here. I think some of your questions we probably already addressed. So Ryan on Twitter, hopefully you have a better idea now of what the SpaceX crew vehicle is looking like. And Richard, you got to see some changes at the Cape in Florida on the launch pads. But we do have a few more to try and answer. Navia on Twitter asked, are there any other spacewalks planned to get ready on the space station for the commercial crew?
Well, hopefully not. The original plan was to install the International Docking Adapter today with just the one spacewalk, and so far it's gone very, very well. All the cables are connected and the hooks have been driven. It's made it firmly. We were able to take that cover off, which exposes the pedals and really sets us up for dockings. We'll have to check it out a little bit over time, but today we don't really anticipate any other spacewalks in this particular area. So hopefully it all checks out, and then we don't have to go back out and do a spacewalk in this area.
Yeah, fingers crossed. Everything will keep going smoothly today, and everything will work well. Nora from Twitter asked, can we celebrate now? Would you say it's time?
Wow, you know, it's hard to say celebrate because this is an important milestone, and the International Docking Adapter is hooked up. But remember, we still have 2 crew members out in the vacuum of space. So from my old former operational world as a flight director, it's very hard for me to celebrate until the crew comes back inside safely and they're in the airlock and we get the airlock repressurized and they can take their spacesuits off. So I'm not going to celebrate yet. I'm very excited. You can see the smile on my face that it's been a great day so far, but we'll celebrate when the crew gets back inside.
All right. And I guess even just beyond today, you're looking at a lot of more work ahead.
Yeah, I mean, we can celebrate the success today, but we have an awful lot of work ahead of us over the next few months. If you think about these spacecraft beginning to come together, there's hardware going through what we call qualification. So all the computers, all the systems that fly the vehicle are getting tested all throughout the country to make sure that the software works, make sure that the hardware works, make sure that they can command all the systems they need to. And so this is what we would typically call the hard part in a development program, of where you're going through qualification and you're ramping up and doing this testing. And so it's really important phase, and we'll celebrate when we get to the end of important milestones, but we know we have a lot of work to do. Both Boeing and SpaceX knows they have a lot of work to do. Their teams are working very hard. We're working very hard in the program and we're involved in the testing and the layouts of boxes and the designs of many components and understanding those so that we can certify these vehicles in the end and put our crews on board. So we're going to celebrate today, but then, you know, it's kind of like once the football game's over, you got to get back to work, and next week we'll have another set of challenges before us.
All right. Well, one more question, I think, here from Alex on Facebook, who asked, will this give more people a real chance to go to space?
That's a good question. You know, part of our commercial crew model is we have really 2 purposes. We have what we would call a public purpose, and then the NASA purpose. And of course, the NASA purpose I've talked about is to take our 4 crew members to the ISS and for the spacecraft to serve as a lifeboat. But the public purpose really is, since NASA doesn't own the spacecraft, both companies are really on their own to go out and propose other non-NASA missions and to potentially fly other people in space. So you kind of see this whole market changing dramatically in this time frame that we're in, where there are a lot of companies that are thinking about different ideas to fly people in space. So it would be interesting to look. It's hard to forecast, but then 10 years from now, what will this look like? Of course, we'll have flown to the space station many, many times, and hopefully space station will still be there in the 2028 time frame, 2026 time frame, but there may be other people flying into space, and and carrying non-NASA crews, and it'll be an exciting time for everybody, I think.
Mm-hmm. That actually kind of gets to my last question for you is you've had just such an interesting career. You've worked as a space shuttle flight director. You, I think before this, worked with the asteroid redirect mission and kind of the new technology projects going on, and now you're here in the Commercial Crew Program. I feel like you've got a good vantage point. So what does the future look like from your perspective, do you think?
Yeah, I think NASA's future is very bright. If you think about kind of where we're at, never in my career, I've been at NASA almost 30 years, never in my career have we been building so much hardware at one time. If you look at exploration, they're building the Space Launch System and Orion and getting ready to embark upon missions to cislunar space, perhaps the asteroid redirect mission. We have 2 commercial companies building 2 different spacecraft, integrating those spacecraft into 2 different launch vehicles, 2 different launch systems. So that's a very exciting time frame to restore the capability for the U.S. to launch back to the space station. And then, you know, this journey to Mars, we're starting to put the pieces in place to go to Mars. So it's an exciting time frame. And, you know, if I look back on my career and look back on the shuttle days, those were great missions, but really everything we learned in Space Shuttle, everything we've learned in Space Station, we're taking those lessons learned and applying them to these new vehicles. Mm-hmm. And so it's pretty exciting for me to see these new companies coming online, and we have an awful lot of work to do, but it'll be exciting. And so I'm going to be here to watch it all happen.
All right. Well, hopefully we will all be able to keep an eye on all this different progress that's going on in so many different directions and see a lot of new and interesting things coming on in the not too far away future. All right. Thank you so much for joining us, Steve. Again, Steve Stitch is the Deputy Director of the Commercial Crew Program, and we are going to join back now in the activities in progress as the spacewalk continues today with Kate Rubins and Jeff Williams.
This is Mission Control Houston, 4.5 hours into today's spacewalk by Jeff Williams and Kate Rubins. You're looking at Williams in the vicinity of the area near the Quest airlock from which he and Rubins emerged at 7:04 a.m. Central Time this morning to begin their spacewalk, a spacewalk that has been highlighted by the flawless installation and electrical and data cable hookup of the new international docking adapter to which the SpaceX Crew Dragon and Boeing CST-100 Starliner commercial crew vehicles will link up to in the years ahead.
We got a pretty good view of the WVS.
Okay, excellent. Good work.
All of that work sailed by without incident, with the exception of 1 or 2 stubborn connectors that finally were coaxed into operation. But everything went by the book, and a hard mate of the IDA to pressurized mating adapter number 2, the former shuttle docking port, was achieved at 9:40 a.m. Central Time. The crew did all of the other associated work with the IDA installation, installing 2 docking targets on either side of the new docking adapter, removing a thermal cover from the end of the IDA to which the new commercial crew vehicles will link up to in the future, and putting a cover over an old docking target on pressurized mating adapter number 2 that is no longer required. Kate Rubins is moving back out to the Harmony module to string another cable that will be attached to a handrail at the far end of the Harmony module. That cable will ultimately be used in the installation of the next international docking adapter that will be launched on a SpaceX Dragon cargo craft in late 2017 and attached to the space-facing side of the Harmony module onto pressurized mating adapter number 3. PMA-3 currently is located at the port side of the Tranquility module. It will be detached in the future and relocated to the zenith side of Harmony, and that will be the docking target, if you will, for the next IDA that will be launched on a SpaceX Dragon craft in the future. We're standing by to see what get-ahead work might be in the offing for Williams and Rubins. That decision has not yet been made. We're expecting that shortly.
That's great.
As he was heading back to the Quest airlock a short time ago, Jeff Williams paused for a moment and offered birthday greetings to NASA Administrator Charles Bolden, who is celebrating his 70th birthday today. Let's take a moment to replay that soundbite with the associated words from Williams to spacecraft communicator Tom Marshburn.
Hey, Tom, while we have a moment, I wanted to take an opportunity to wish our administrator, Charlie Bolden, a happy 70th birthday. I've known Charlie now for almost 30 years, 29 years. It's been an honor to work with him in a previous capacity in the astronaut office and now as our administrator. So happy birthday, Charlie.
Jeff, thank you much. We will make sure we pass that on.
Thank you.
4 hours, 12 minutes into
on ESP2 now.
today's spacewalk. Jeff Williams en route back to the Quest airlock, offering birthday wishes for NASA Administrator Charles Bolden, celebrating his 70th birthday today.
Can be to give the most amount of slack to go forward on the lap. And hopefully you should be able to see that in my WVS.
We copy, Kate, and yeah, we got a great view there. Thanks.
Again, that was a replay of comments a short time ago from Jeff Williams on the occasion of the 70th birthday today of NASA Administrator Charles Bolden. Back with the spacewalk, taking a look at work that is continuing, in this case by Kate Rubins, to string a final cable that will be used in the future installation of the next international docking adapter. Only one of these docking adapters, the one that was installed and hard-mated today, is required for the advent of the arrival of the commercial crew vehicles. But a second docking adapter will be attached to the station to provide redundancy and multi-port capability for the future use of U.S. commercial crew vehicles.
You see a beautiful sunrise, Tom.
You got the best view. That's great.
Kate Rubins commenting on the sunrise, the International Space Station flying 254 miles over the South Pacific, flying to the east of New Zealand on a path from southwest to northeast, in orbit inclined 51.6 degrees to either side of the equator.
Tom, you probably see it. J3 does not have a cap.
We copy. We can see it at the bottom of the screen there. And we'll go ahead and take your calls on the inspection as well.
Okay, Tom, I have 249 on the forward standoff with the wire tie. And the actual cable and the place that the wire tie was is about 3 inches short, but I've made the wire tie stretch to the end. I can't move the wire tie along the cable because of the little ties that prevent the loop from sliding. The shortest path is going back to the Y, and it is as packed down to the lab as we can make it.
Kate, go ahead and press on. We've seen it on the WVS, and thanks for the words as well.
Okay, and we'll just confirm for you again that my safety tether is not routed underneath the cable.
Copy, and Kate, you're looking for the handrail just forward of the lab window, 257.
257, and I see it going back to the cable bag.
And again, Kate, that'll be the forward standoff as well, Kate.
I'll be forward standoff 257.
A4 to P4, pins are good, no FOD, good EMI band.
Well, Kate Rubins is laying out the cable for the next international docking adapter at the forward end of Harmony. Jeff Williams is at the Z1 truss of the International Space Station and is in the process of mating an Ethernet cable for a multiplexer demultiplexer, essentially a computer relay box, to another Ethernet cable that will be used for the multipurpose laboratory module, a Russian module that will be launched in the not too distant future. This another one of the get-ahead tasks that the crew has been able to press ahead and tackle due to the accelerated work that they did earlier today on the installation and outfitting of the International Docking Adapter.
No FOD, good EMI band.
We copy, Jeff.
Mated, the over center, handles forward over center.
And Jeff, because of the four of those cables that were nadir there, we just wanted to make sure, especially with the one with the missing cap, if you could read off the cable labels from the nadir pair that we've connected.
Remember? So far, all I see is J3 and J4. You want to get the wiring harness label?
Jeff, that's good for us. Thanks for double checking the labels there, and we'll take some closeout photos when you're happy with the work site as well.
Okay.
And Tom, for you, I've got my green hook at 238, which keeps my safety tether in a good known config going back to the airlock.
We copy, Kate, and just in your future as you move forward, a caution for you, do not use the EWIS antenna, which is lab nadir forward, as a handhold. It's on the incone.
Understand. Copy.
Once again, with the International Docking Adapter firmly in place and open for business, thanks to the efficient work today by Jeff Williams and Kate Rubins. We're approaching the 4-hour, 45-minute mark into today's spacewalk, and Kate Rubins is in the process of stringing a cable down the Harmony module that will be used for the ultimate attachment of the next international docking adapter to be delivered in late 2017 on a SpaceX Dragon cargo craft. That will be attached to the space-facing side of the Harmony module. The IDA that was installed today is now hard-mated to the forward end of the Harmony module onto pressurized mating adapter number 2. Jeff Williams is completing work with the routing and hookup of a multiplexer demultiplexer cable for an enhanced processor system that will also include the Ethernet capability routed towards a Russian module to be launched in the future called the multipurpose laboratory module.
That's right, Jeff. First a glove and hap check, as always, and then, yes, sir, you'll be getting the big bundle.
You got WVS now?
We do.
There's a little cut in my RTV. It's just like RTV.
And Jeff, we copied. If you could, we just couldn't quite see if you could confirm the RTV looks good and no Vectran.
No Vectran. Hap check is good. Okay, so
Copy.
Cable bundle. I'm removing the adjustable equipment tether, correct?
That's affirmed. Now, the first one you're going to wire tie to is 6011, which is just to the left of where the adjustable is. So it's your call whether you just want to leave it there for that first wire tie.
Okay.
And Jeff, I am at lab 257, which is just forward in the lab window, and I'm working on laying down another wire tie there.
Copy.
We copy, Kate.
Williams and Rubins are working on their respective get-ahead tasks, are in the process of gathering some of the equipment, making sure that their tethers are properly configured at the 4-hour, 47-minute mark into today's spacewalk.
We'd love to hear those words.
I'm highly incentivized.
Copy and understand. And Kate, that long taped wire tie will release each little segment as you need to without releasing the entire bundle.
Yep, and I see that. It's a beautiful job. The folks that packed it. Okay, and Tom, again, with the complete amount of slack The Sharpie mark is about this time and 6 or 7 inches too short. I cannot slide the wire tie along that in the middle of the handrail, which is slightly less than ideal, and keep the cable taut, or I can undo the wire tie, or I can tie it on the aft standoff of 257. Your choice.
We understand the options and we're talking. Take the bundle across the rat's nest and then come back.
Okay, Tom, and I think my next will be jumping the gap over node 2, and I plan to go the Zenith route underneath the camera group and then local tether and pass the cable bundle to myself. I'm going to go the nadir route and then pass the cable bundle myself, Zenith.
That sounds exactly what we need. Thank you. And just a reminder, Kate, if you come across the wire tie labeled 0274, we do not want to attach that at this time.
Understand.
And Jeff, you're looking for handrail 6010.
Copy. I found 6010. I'm going to keep on going. Oh, maybe not. Maybe I will. Just stand here.
And Jeff, you can use the wire tie that's already securing the already laid down white-green cable for that handrail.
Copy.
I'm looking on the other end of it. Stretching this thing all the way across the station.
Kate, we thought that was a very nice pass.
Thank you.
Jeff, your next handrail is the same one on the port, just on the starboard side, but otherwise same location.
Okay.
And Jeff, you're looking for 6006. Looks like you've got it.
Okay.
This is Mission Control Houston.
And Jeff, just a heads up, that will be the final location for your bundle. But you can use, just to lay down the cable, you can use the wire tie that's already there.
Okay. Let's see, I don't know if you can see my WVS, I have a trailing connector there that was on a short cable coiled up with this one. Might have to go release that one. And
okay, we're looking at the WVS. Thanks for the words.
This view on the International Space Station of Kate Rubins as she's continuing to work with Jeff Williams outside. We're approaching the 5-hour mark into today's spacewalk. Williams and Rubins
what to do with the rest of that big bundle once you're done.
Are cleaning up a number of cables and other tools and tethers that they worked with during the course of today's spacewalk to install the first international docking adapter. They're just wrapping up work with a couple of get-ahead tasks to string a cable for the next IDA that will be delivered to the International Space Station about 1.5 years from now, as well as the routing of an Ethernet cable that will be used to route enhanced processing capability for a Russian laboratory module to be launched in the future. The spacewalk continues to proceed about 20 to 30 minutes ahead of the timeline. We're still waiting to see whether or not there are other get-ahead tasks that will be prescribed for the crew by the lead flight director here in Mission Control, Zeb Scoville. The International Space Station is approaching the west coast of Mexico, moving from southwest to northeast on a track that will carry it just to the northwest of Houston a short time from now.
Thank you. How's it going?
It's going. I'm messing with the bundle right now.
And Tom, you might have predicted this, but since they're so short, I'll try to work the wire tie forward.
And Kate, we copied. Confirm you have the 374.
Well, that's a good surprise. No, that was the lab 274. Thank you.
Confirm that wire tie labeled node 2.
It's labeled node 1, handrail 0137, and it's taped.
To recap today's spacewalk, Jeff Williams and Kate Rubins were up in the wee hours this morning, suiting up for this excursion, the 194th spacewalk in support of space station assembly and maintenance. Working ahead of the timeline, the crew got out the door at 7:04 a.m. Central Time, placing their suits on internal battery power to mark the official start of the spacewalk now just 5 hours ago. They went to work almost immediately, getting things together, collecting all of their tools, and moving to pressurized mating adapter number 2, where they hooked up a number of connectors and cables. The robotics officer here in Mission Control had previously moved the new international docking adapter to just about 2 feet away from PMA-2. And while the crew was in their pre-breathe procedures before exiting the Quest airlock, the robotics officer moved PMA-2 into a seating position, surface to surface against PMA-2. The crew took over, grabbing manual control after installing tethers that they cinched in place to draw the IDA into closer contact with the PMA surfaces. And Takoya Onishi from a command panel inside the International Space Station sent commands to close 2 gangs of hooks, 12 hooks in all, that formed a hard mate between the IDA and the PMA. That hard mate noted at 9:40 a.m. Central Time.
We copy, Kate. And as you can tell, that's just zenith of the grapple fixture on node 2.
Copy, thank you.
Once the IDA was hard mated to PMA-2 to form this new docking port for future U.S. commercial crew vehicles, the 2 spacewalkers, Williams and Rubins, went to work installing a cover over a reflector, a docking target, if you will, on PMA-2, no longer required. They also installed a cover on the grapple fixture on the IDA, to which the Dexter Special Purpose Dexterous Manipulator affixed itself on Wednesday to extract the IDA from the trunk of Dragon. They removed the forward cover on the IDA and routed a number of cables that will now provide power and hook closure capability for the forward end of the IDA for when the commercial crew vehicles do dock to the International Space Station.
6010 is good, Jeff. Thank you.
Try again.
And Jeff, he said 6010 is good. Thank you. You copy me?
Yes, okay, got it. So the cable as configured was good.
And Jeff, as you come back out of the rat's nest, we have a request for another glove and hap check from you.
Okay.
And with this one, we'd like to verify that you see no Vectran.
Copy.
And Jeff, to be specific, we want to hear the words no Vectran damage, if that's what you see.
And Tom, at 3:38, do you want that on the forward or aft standoff? On note 2.
And Kate will take 338 aft.
Copy. Jeff, you copied Tom about the glove check and the vector check.
Yes. Thank you. Okay, Tom, I'm looking right now. I see no vector end damage. Gloves look good, and hap check is good.
Thank you, Jeff. We copy.
Okay, Tom, I have the cable bundle. It is sitting zenith of handrail, the 2 handrail 0338, tied off on the aft standoff. And if you guys agree, I will work my way back along the cable and check if lab 274 is needed, check if CP13 is not clobbered, and also there's a width that we need to make sure the cable's not running fast.
Right there. Kate, we're talking. So, Kate, we'd actually like you to take some pictures of that bundle there. Be advised, we think the lens cap came off of the camera and is floating around, so you can check that as well. But the rest of your plan sounds ideal. Thank you.
Okay, understand. And work.
Tom, I'm dropping off the cap keeper in the crew lock bay.
And Jeff, you can use that cap keeper for the Spitz caps if you like, and you'd be picking up the EVA scissors. It's your call on the caps.
Okay. Sounds good.
This is Mission Control Houston, 5 hours, 6 minutes into today's spacewalk. The Spitz cap removal that was referenced a moment ago for Jeff Williams.
Before you get pictures, we have one more word for you on that bundle because it seems to be just lying there against the Node 2. It'd be great if you could put it a little bit more forward, the bundle itself, on that handrail. One more wire tie just to make sure it's secure to the handrail.
Okay, understand, and I'll get pictures for you in the pre-fixed condition, and then I'll get some in the post. I got the pictures before you.
And you can use the wire tie if you'd like that's already there.
See.
Spacewalk communicator Tom Marshburn here in Mission Control talking to Kate Rubins, who you see on the Harmony module of the International Space Station. Right behind her, the SpaceX Dragon cargo craft that was launched a month ago, delivering the first international docking adapter to the International Space Station.
Okay, understand the white-green wire tie that's already there. There's a lot of wire ties here.
Good copy. Thank you.
Again, Jeff Williams is wrapping up some cleanup work with bundles of cables, tying them down outside of the station. He likely will do a quick procedure to remove some caps from some of the connectors that used to be associated with what is known as the Station to Shuttle Power Transfer System, or SPITS. This was the power transfer system that was used after shuttles would dock to pressurized mating adapter number 2 during the shuttle era to transfer station power to the shuttle while the shuttle was docked to the International Outpost. Of course, that's no longer needed with the International docking adapter now attached to the station. PMA2 is simply a intermediary
Kate, we love it from the WVS
tunnel extension between the IDA itself and the Harmony module of the International Space Station for the future arrival of U.S. commercial crew vehicles.
How's your cable?
I'm working on the cable's done. Working on the first Spitz.
Excellent.
Sounds like your cable's going well.
It is, I would call that cable task close to complete, pending the 274 on the lab check.
Very nice.
And Tom, I got photos for you. You get some bonus photos in there.
We copy, Kate. Thanks.
Lens cap is back on the camera. And if you guys agree, I will leave the forward work site and work my way back checking the cable.
We agree, Kate, and we like your plan of going back and checking aft.
Okay, I'm tethered to both caps. Now I'm going to get the scissors out and do some cutting.
We copy, Jeff. We've been watching. And Jeff, we think you've got the idea, but make sure you just cut one side of the loop so we don't have any FOD.
Happy.
And Tom, on the zenith side of the CP13 antenna, this cable is laying nicely. I don't think it needs the wire type, but I'm right here and I'm happy to do it if you need it. Just gonna do it once here.
Hey, Kate, we'll take the wire tie.
I got one loop in it. I'll just kind of hold it a little securely. You can see that in my WVS.
Yeah, we've lost WVS just now.
Okay.
First one's cut off.
And I copy Jeff.
Second one is cut off.
And Jeff, if you could read off the number of those cables, that would be great.
First, I'm going to safe the scissors.
And for Kate, we're cleaning up our steps here. Could you verify you got 3 twists on the wire tie for the cable bundle?
I did get 3 twists for the wire tie for the cable bundle. And actually, let me double check that. Got 3 twists onto the node 2 handrail. You want 3 twists over the top of the cable bundle as well? Now I have, looks like 2 twists and a loop back over. I think the bundle is fairly secure. 2 handrail 238 is not going to come undone.
Okay, we copy. You're in a good config. Thank you.
Okay, and I did put down the lab handrail 274 to keep that sucked back into the lab, and that allowed me to route it zenith of the camera group and not interfere with the base of the camera station if we ever are in RNS.
We copy. Thanks, Kate. You're good.
Actually, both of them are Whiskey 9010. And then there's I guess the serial number 101. Go look at the other one. Both say serial number 101.
We copy, Jeff.
That's sufficient.
We're checking. And Jeff, we're good.
You're blocked again, Todd.
Said we're good.
Okay, good.
And Jeff, if there is any exposed end of the lanyard, just warning, do not touch the cut end of that.
Copy.
And Tom, I am headed back. I'm checking the cable as I go. I'm back to my green hook near the IDA kit bag.
And Kate, your next step is to get that IDA cable bag and bring it back to the airlock. And for Jeff and Kate, we're discussing get-aheads. Just wondering how you feel about pressing on with those.
What's our time looking like, Will?
So we're good on consumables over 7 hours, and we're at 5:15 PET at this time. So partly depends on how you guys feel.
Okay, that sounds great to me. I'm happy to go do some get-aheads. Let's get this IDA cable bag back in the airlock and double check that we're all good meeting back in the airlock, and that sounds like a good plan.
True.
We copy.
Okay, Tom, for final bag inventory, I see one adjustable on the lid, an adjustable to the socket caddy, a large small ret on the inside of the lid. I've got the bag itself. On the outside, I've got a large small ret, and I've got a small ret on the loop of the bag.
We copy, Kate. Sounds great. You'll go to retrieve the bag.
Work.
This is Mission Control Houston, 5 hours, 18 minutes into the spacewalk. The crew has completed all of the nominal tasks on the timeline, of course highlighted by the installation of the International Docking Adapter and the hookup of cables that now have set the stage for the IDA to be used as the docking port for future U.S. commercial crew vehicles. With the crew running about 20 minutes ahead of the timeline or so, and with plenty of consumables and with their suits operating so far to perfection, Flight Director Zeb Scoville in conference with the lead EVA officer, Glenda Brown here, they determined and radioed up to the crew that they're good to go for a few get-ahead tasks, one of which Kate Rubins will take into her bag of tricks. That will be the tie down of brake handles on a CETA cart. That's a crew equipment cart that resides out on the port truss of the International Space Station. The brake handles will be tied back to facilitate the crew members on future spacewalks moving up and down the truss of the station. The other task that Jeff Williams will undertake will be to move to the far side of the starboard truss of the International Space Station to take photos of the alpha magnetic spectrometer. That is the huge science instrument that is that resides on the starboard truss of the station since its delivery to the outpost in May of 2011 to study dark matter in the universe. An effort is underway to determine the best methodology in future work and the development of possible future spacewalks to replace a somewhat degraded cooling system on the alpha magnetic spectrometer, as well as fraying insulation covering the AMS. So photos taken by Williams today as part of this get-ahead work will be used to verify and document the current configuration of the work sites around the AMS, as well as its current condition.
Okay, Jeff, this is Ground IV, and I read you loud and clear.
Okay, I think I lost my right ear cup just a minute ago. I fractured my left ear, not my right.
We copied you think you lost your right ear cuff. Does it help if I speak louder and slower like this?
I think I lost audio in the right side.
Jeff, we'll take another HAP check from you as well.
HAP check feels good. Nominal HAP.
Copy that.
Got a nominal HAP as well.
And I hear Kate only on the left side as well.
And I copied that, Jeff. I'm guessing they're discussing.
Okay.
And Jeff, we believe you made a call and we did not copy.
All I said was I answered Kate saying okay.
Copy.
I've got the crew lock bag. I'm working my way back to the airlock.
We copy, Jeff.
And I copy you as well. I still have the IDA bag. I've got 4 corners to undo, and I'm putting it on my BRT.
Okay, good.
This is Mission Control Houston. With all of their prime work having been completed in successful fashion, Williams and Rubins now will tackle a few get-ahead tasks. Williams moving to the starboard truss of the International Space Station to take a number of photos of the alpha magnetic spectrometer in assessing the current configuration of AMS and its work site areas. This for possible use for a series of spacewalks that might be undertaken in the future to replace the AMS's degraded cooling system.
If the ground is discussing right now, my preference if your comm is degraded is to not press forward to get ahead.
Yeah, that's probably, I concur, and it's probably where they're going.
And as I have just indicated that they're pressing with get-aheads, Flight Director Zeb Scoville is going to call off the get-ahead tasks due to some broken communication that Jeff Williams is experiencing at the moment.
And for Jeff and Kate, while you're at the airlock, we believe we copied you saying you did not want to press on with any get-aheads. Jeff, we do have broken comm with you at this time.
Okay, Tom, I can copy Jeff completely, and I hear him clearly. We did have that discussion that we would prefer to not go forward with get-aheads if he has degraded comm, which it sounds like he does.
And it was degraded, and now it just popped back in. But it's still suspect, I guess you could say. But give me another comm check, Tom.
And Jeff, this is ground IV. How do you read?
Okay, I had you for a few seconds nominal on both sides, and then the right side went away again.
So we're standing by now to make a final determination whether or not the right earpiece in Williams' comm cap that he's wearing will permit any type of get-ahead work that had previously been approved by Flight Director Zeb Scoville.
Tom, are you copying any of Jeff's calls?
And we're only copying you at this time, Kate.
Okay, I do not have degraded comm with Jeff. I can hear what he's saying. He's back at the airlock. I can see him. He's on the circular handrail.
And I can hear both of you.
He can hear both of us. I've got the IDA bag on my BRT, and I am headed back to the airlock.
And we copy that, and we're discussing.
Here in Mission Control, Zeb Scoville, the lead flight director, is still discussing whether or not we want to press ahead with the get-ahead tasks. They had been approved. Rubins was going to tie down brake handles on a crew equipment tool cart out on the truss. Williams was going to move over to the starboard truss to take photos of the alpha magnetic spectrometer, and then he developed some communications problems with the right earpiece and his comm cap. No water in the helmet. Everything is dry as a bone. The rest of the suit systems are functioning perfectly.
Hey, Kate and Jeff, we appreciate your words. And so we believe, we agree with you, we should be looking at a nominal ingress, and we're done for the day.
Okay, copy. I have the IDA bag on my LRU bag, and I'm going back to the airlock.
Sounds good, Tom. And how did you hear that, Tom?
And Jeff, we heard that. Thank you.
And because of the slight breakup in communications with Jeff Williams, the decision was made to call off any get-ahead work at this point and to call it a day with all of the work to install the international docking adapter having been completed in perfect fashion. So the crew now will gather all of the rest of its equipment and make its way back toward the Quest airlock.
And I do hit off the beat.
ahead.
Okay.
Follow toward you or no? Okay.
It's coming right back.
Yeah.
I'm going to work my way around aft.
Okay. Looking good, Kate.
Right. Just checking the safety tether.
Okay. You want to turn the other way, turn to your left. There you go. And then the overhead handrail.
About 2 minutes from nighttime as well.
Okay, I'm going to open the thermal cover.
Copy. And thanks for the turn help there.
Yeah.
Level.
Yeah. Oh, you got a local, you got a grabber daddy there. Okay.
And I got the IDA cable back to get in the airlock.
Okay. You want to release it from your BRT?
Yep, that is. It's all of it. And I'm starting my BRT.
Okay. Which way are you going to turn?
I am thinking about that.
Okay.
You got words?
I want you to turn toward your safety tether.
Turn. Gotcha.
There you go. Take your time.
Working my way in here.
Yeah, take your time. Visors up.
And Jeff and Kate, we've been following along just to confirm. It sounds like the comm has been pretty good at this time. Do you agree?
Yeah, I'm my left side only.
We copy.
And I'm getting my waist tether on the airlock here.
Okay.
Let's see if I can make that a beacon face. There we go.
No rush.
This is Mission Control Houston, 5 hours, 34 minutes into today's spacewalk. Just to recap the last few minutes of conversation between spacecraft communicator Tom Marshburn and Jeff Williams and Kate Rubins outside. Williams developed a minor intermittent issue hearing communications out of the right earpiece and his communications cap.
extender locked.
This would normally not be an issue if critical tasks still were required outside, but with all of the objectives of this spacewalk having been completed, the only issue was would they press ahead with a couple of get-ahead tasks that can easily be scheduled on a future spacewalk and not critical at all for the time being. So the decision was made, and the crew was informed by spacewalk communicator Tom Marshburn to complete the spacewalk as planned now, the crew running well ahead of the timeline.
You can retrieve Kate's safety tether anchor and attach it to your waist tether.
Copy.
Okay, the IDA cable ORU bag on the
Again, all of the other suit systems for Jeff Williams as well as Kate Rubins have been working perfectly, but because of a slight intermittent problem with Williams hearing communications out of his right earpiece in his communications cap, the decision was made not to press ahead with non-critical get-ahead work that would have involved some photos of the alpha magnetic spectrometer and the tie down of brake handles on a cedar cart, a crew equipment cart that is parked on the truss of the International Space Station, on the port truss in this case. So the crew is back at the airlock. Everything else went by the book perfectly. The crew working well ahead of the timeline today as they installed the international docking adapter, hard mated it to pressurized mating adapter number 2. We now have a docking port all set to go, ready to accept U.S. commercial crew vehicles in the years ahead.
I'm going to release my red to my BRT.
I'm ready for that.
I'm ready for that as well. I'm releasing.
Oh, okay, sorry, you wanted me to release it.
Yeah.
Work.
Okay.
Your BRT ret is coming towards you.
Okay, got it.
20-second handover in 15 seconds.
Copy, I see 3 bags in the airlock.
3 bags in the airlock, that's a good sign. All right, let's review the tether protocol.
I am waist tethered to the airlock D-ring extender. It is locked black on black to my right D-ring extender, and the large hook is locked black on black to the airlock D-ring extender. So I'm in a safe lock configuration to the airlock.
I concur. So I'm going to release your safety tether.
Understand.
Released, and I'm going to daisy chain to it on my right waist tether. And I got 2 bails closed, hooks locked, black on black.
Copy.
And we copy on the ground,
Tom,
Jeff.
are you copying Jeff's safety tether calls?
And we copy on the ground, Jeff.
Okay. So now I'm going to release my safety tether. We are daisy chained.
Copy.
We copy, and Kate, when you're clear, you can give Jeff a go for ingress.
All right, Jeff, you are go for ingress, and I will work my way towards the hatch. The ID hatch and get out of your way.
All right. I'm coming on in.
See, come in, I'm phoning at my mini workstation. I'm out of your way. and direct me wherever you need me.
Okay.
See the hatch thermal cover coming close.
Thermal cover's closed. I just secure the Velcro here.
And I'm starting work on my SCU.
Okay.
Can we copy you both on the ground? Good words.
Hey, Tom, we're inside.
And we understand you'll be connecting up your SCUs next and checking that it's locked.
Okay, EV2 SCU is connected and second monitor.
And EV1 is working on his.
Yeah, I'm just working the offload here. Got it offloaded. Trying to get it locked.
5 hours, 42 minutes into the spacewalk. Williams and Rubins are back at the Quest airlock, preparing to make their way inside.
2 minutes after you take your water to off, each of you, and expect a message.
Okay, and I don't have my SCU locked yet, so let's pause here. Trying to get the last little bit where it's got the TMZ interference.
Got it.
I'm off.
The crew is in the process of making their way inside the Quest airlock.
Yeah, up and away from me.
With the team having called off a couple of minor get-ahead tasks that originally were being considered, but then were taken off the table when Williams developed a slight intermittent problem with the right earpiece in his communications cap. So with everything else having gone by the book and all other suit systems in good shape, the decision was made to bring this spacewalk to an end. And we're standing by now for the hatch to be closed and for the crew to begin the process of repressing the airlock, the crew lock section of the Quest airlock that will mark the official end of today's spacewalk.
Yeah, that's exactly what I'm doing.
So I'm lock it in place.
It hits the front of the DCM.
And try taking it off and lining it up again.
Let me see if I've got too much.
Yeah, take one coil out of it, maybe. That coil preload.
With the crew back inside the Quest airlock, they're getting positioned to prepare for the repressurization of the crew lock section of Quest. They have not yet closed the outer thermal cover or the hatch to the Quest airlock.
Sometimes it takes a lot of pressure to compress the MOI to get that closed. And we understand you're working the side loads as well.
Affirmative.
We're out of range of a downlink television signal from the International Space Station for about the next 11 minutes or so.
Okay. If you can. I don't know if you can. Let me see. Push your hose out, push the line up. If you get. That's what I was getting. Keep it memory. Try one more time. I'm gonna try taking a loop out and going a couple different ways. Yeah, I don't think that's it. I think it's it. Pull the handle toward you. Toward me? Yeah. Try to lock it in place. Locked. You got a pull test on it? There it is. Okay, thank you. I see you down and locked. Okay, we have 2 SCUs downed and locked.
Yeah, we copy. You got them both locked.
Yes, affirmative.
Great work. We were working on other steps, but you beat us to it. So now you can both take your water to off, expect a message, and then we'll wait 2 minutes.
EV1 water off. EV2 water off.
And Jeff, while we're waiting for the 2-minute clock, you can just look around, verify the outer hatch is clear, and the handle is in position as per the decal.
Copy.
Williams and Rubins back inside the Quest airlock, preparing for the beginning of the repressurization that will mark the official end of today's spacewalk that began at 7:04 a.m. Central Time.
Loco.
And to minimize time for your cooling for you both, you can take your TCV to a setting of 8 to max cold.
Copy. Good work. And EV2 is at 8.
Copy, Kate.
Once the crew lock section of Quest is repressurized, Waiting on the other side of the hatch to the equipment lock section of Quest will be Japanese astronaut Takuya Onishi and Russian cosmonaut Anatoly Ivanishin, who will help the crew back into their respective positions on either side of the equipment lock walls to begin the process of doffing their helmets. We'll be continuing our coverage through the time the crew is back inside the equipment lock.
And it's been 2 minutes. You go to close the hatch. Close and lock.
Copy. I've got my get out of the way for you. Tell me you're easy. Take myself a smile here.
All right. So what am I? Right here. There we go.
10 seconds to 20-second handover.
Okay.
20-second handover.
Copy.
Is that you?
Let me try moving and see if I can orient. Does that help?
And Kate and Jeff, we're back with you.
Okay.
Copy. Here's your foot. Yeah, keep going towards the IV hatch. There you go.
There we go. I need to get the pouch out. It's out.
Pull the feathers clear of the hatchway.
Okay. Latch. It's latched and locked. Hatch is latched and locked.
We copy, Jeff. So we have a series of checks just to verify everything we've done so far. For you both, check the SCU is connected to the DCM.
Connected.
EV2 connected.
Check your water is still off.
Water off.
EV2 water off.
We understand the EV hatch is closed and locked. And Kate on the UIA, check the oxygen for EMU 1 and 2. 2 valves are open.
Oxygen EMU 1 open and oxygen EMU 2 open on the UIA.
Copy. Kate, switch power for EVA 1 and 2. 2 switches to on, and check the 2 LEDs and read us the voltage.
Okay, EV1 power, I'm sorry, EV1 power on, LED on, EV2 power on, LED on. EV1 is 18.5 volts, EV2 18.
The crew reading up various suit measurements to Spacewalk communicator Tom Marshburn here in Mission Control. The hatch to the Quest airlock closed about 2 minutes ago at 12:57 p.m. Central Time. The precursor for the start of the repressurization of the crew lock section of Quest that will be coming along just a couple of moments from now.
Power and SCU.
Okay, EV2 power and SCU.
Copy on the DCM, O2 actuator to press for you both.
2 actuator to press.
R2 actuator press.
And Jeff, we might have missed your call.
R2 actuator to press.
Copy. So for you both, you will be switching.
Hold on a second.
Stand by.
Hold on a second. Now I got a failure, actuator failure. So let me clean the here.
Have a failure or it didn't hit the
I'm sorry, I got the message. R2 actuator needs this slightly out of its P10.
Okay, copy slightly out of its P10, not an actual failure.
Exactly. Yeah, O2 actuator fault is what it says. It's clear now. The message is not clear. Let's see. Okay, O2 position press. I'm good now.
And Jeff, just verify your O2 actuator is in press, and we're following along.
It is in press, and now it's reading press.
Okay. Next step is to switch the comm mode to hardline, and Jeff, we're going to ask you to do a comm check with talk.
Copy, going to hardline now.
Houston airlock on 1, I have a good comm with EV crew.
Takoya Onishi and Anatoly Ivanishin in the equipment lock section of Quest. Just beyond that hatchway are Williams and Rubins. The hatch is closed to the airlock, the outer portion, the crew lock section, as we stand by for the repressurization of the airlock. And the repressurization of the crew lock section of Quest is now underway. With the start of the repressurization at 1:02 p.m. Central Time, the spacewalk has concluded with an official elapsed time of 5 hours and 58 minutes. Again, the repressurization of the Quest airlock beginning at 1:02 p.m. Central Time for an end to today's spacewalk by Jeff Williams and Kate Rubins at 5 hours and 58 minutes. This is Mission Control Houston. Once again, the repressurization of the crew lock section of the Quest airlock is underway. The repress began at 1:02 p.m. Central Time to mark an official end to today's spacewalk at 5 hours and 58 minutes. Some statistics, this was the 194th spacewalk in support of space station assembly and maintenance, the fourth in the career of Jeff Williams, spanning all the way back to May of 2000. His 4 spacewalks now have totaled 25 hours and 7 minutes of spacewalking time. 4 EVAs for Jeff Williams, totaling 25 hours and 7 minutes. This, of course, was Kate Rubins' first spacewalk, 5 hours and 58 minutes. The 194 spacewalks in support of space station assembly and maintenance have now totaled 1,210 hours and 46 minutes, 1,210 hours and 46 minutes, or the equivalent of 50 days, 10 hours and 46 minutes of spacewalking time. So the spacewalk complete. Jeff Williams and Kate Rubins back inside the crew lock section of the Quest airlock as Takoya Onishi and Anatoly Ivanishin wait for a full repressurization so that they can open up the hatchway and bring Rubins and Williams back inside the equipment lock to help them begin to doff their spacesuits.
With the crew safely back inside the airlock and the international docking adapter successfully installed, that is going to be the end of our enhanced coverage for the day. We hope you learned a lot about the adapter and about the commercial crew vehicles that it's going to allow to dock to the International Space Station in the near future, as well as about spacewalking in general. We'd love to hear what you thought about today's show, so if you want to drop us a comment via social media, we'll definitely pay attention to those. And if you can't just can't get enough of this stuff, please don't forget that you can get a behind-the-scenes look at today's spacewalk by following NASA on Snapchat or going to the @ISS account on Instagram. That, again, will be a behind-the-scenes look at today's spacewalk that you don't want to miss. Now we're going to leave it with Rob Navius and Mission Control Houston for continuing coverage as the crew wraps up their activities for the day. Thanks so much.
Back here in Mission Control in Houston, you're looking at the equipment lock section of the Quest airlock. Anatoly Ivanishin in the blue shirt, Alexei Ovchinin joining the crowd inside the equipment lock along just out of the field of view on the very right side of the equipment lock. That's Anatoly Ivanishin, the Russian cosmonaut. They are waiting for the full repressurization of the Quest airlock. The crew lock section that will enable them to open up the hatchway and bring Jeff Williams and Kate Rubins back inside. So everything went by the book with the installation of the international docking adapter, the new docking port that is now permanently attached to pressurized mating adapter number 2 at the forward end of the Harmony module. Williams and Rubins worked well ahead of their timeline throughout the course of the day and completed all of the cable routing and reconfiguration of cables outside that now are providing both heater power and other data power and electrical capability to the new international docking adapter for the future arrival of the SpaceX Crew Dragon and the Boeing CST-100 Starliner commercial crew vehicles. After a quick pause at 5 pounds per square inch, the repressurization of the crew lock has resumed. Williams and Rubins safely back inside. A very happy team of flight controllers here in Mission Control as the era of U.S. commercial crew capability to the International Space Station took one giant step today in the right direction with the attachment of the first of 2 international docking adapters at the International Complex. To repeat those statistics that I provided just a moment ago for those just tuning in, the spacewalk ending at 1:02 p.m. Central Time with the start of the repressurization of the crew lock section of the Quest airlock. Takoya Onishi and Anatoly Ivanishin standing by at the hatchway to the crew lock as they wait for the full repressurization and their ability to open up that hatch to bring Williams and Rubins back inside the equipment lock section. The spacewalk ended at 5 hours and 58 minutes. Jeff Williams, 4 spacewalks now totaling 25 hours and 7 minutes of spacewalking time. The 194 spacewalks in history to support space station assembly and maintenance now totaling 1,210 hours and 46 minutes, or 50 days, 10 hours and 46 minutes of spacewalking time.
Station Houston on space to ground 1 for talk when convenient.
The crew lock section of Quest is now fully repressurized, and Onishi is now turning the handle that will open up the hatch to enable our two spacewalkers to return to the equipment block.
Houston, go ahead.
Hey, Talk, we have a couple deltas for you on your post-EVA procedure, so give us a call when you'd like to copy those.
Okay, can I first remove safer and put them in the EDA?
And Talk, we do have one step for you that's before the safer doffing.
Okay, so I'm ready to copy.
Just like a report if EV1's right ear cup ever recovered audio, and also the volume intensity on the DCM.
The hatch now open, and Onishi and Ivanishin will help the crew members back inside.
Hey, welcome back.
That is Kate Rubins first back inside their safer backpacks, the jet backpacks that are used only in the unlikely event that a crew member would become untethered outside of the space station. They would be able to propel themselves back to the safety of the station. Those jetpacks will be removed so that the crew members can be mounted on either side wall of the equipment lock as they begin to doff their suits. The delivery of the International Docking Adapter to the International Space Station, years in the making. And the spacewalk today that installed the IDA as the new docking port for U.S. commercial crew vehicles in the future went off without a hitch. Everything went by the book, the crew working ahead of the timeline throughout the day. And Jeff Williams now moving back to his respective position on the sidewall of the equipment lock section of the Quest airlock. Williams today with the completion of his 4th spacewalk, now 25 hours and 7 minutes of spacewalking time. Next Wednesday, Williams will surpass Scott Kelly's
airlock on 1.
Go ahead, talk.
I don't remember exactly which one is volume, but all knobs are around between 4 and 5.
Copy. Volume was around 3, 4, 5.
Either 4 or 5.
Copy. 4 or 5. Thank you.
That call checking on the volume setting for Jeff Williams' ComCap right at the end of the spacewalk with the possibility of a couple of get-aheads in the offing. Williams developed a slight intermittent problem with the dropout in his right ear cup of that communications cap. Of course, no impact to the spacewalk since all of the objectives had already been completed and the get-ahead tasks that were being considered by the flight control team here in Houston will be placed on a future timeline.
Okay, Houston airlock on 1. I'm ready to copy the deltas.
Okay, thanks, Talk. In step 11, we have some extra steps on the glove inspection and photos. Please take photos of both the loose thread on the left pinky that was reported and the RTV cut in the right index finger. How copy?
That's for AV1?
That's affirmative.
Left hand pinky and index.
Good, read back. And our last delta is in step 22. Please take photos of EV1's ComCap and embeds and report if there's any moisture noticed around the embeds.
Copy. Again.
So as Takuya Onishi and Anatoly Ivanishin, along with Alexei Ovchinin, work to get the helmets off of Kate Rubins and Jeff Williams, first order of business as is always the case after a spacewalk, is to take detailed photographs of the gloves and other areas around the suit, just to document the amount of wear and tear those suits go through during each spacewalk. This is Mission Control Houston, continuing our coverage as we watch work to document the spacesuits of Jeff Williams and Kate Rubins, which is typical for a post-spacewalk time frame in the equipment lock section of Quest. The spacewalk having ended at 1:02 p.m. Central Time with the start of the repressurization of the crew lock section of Quest. Both crew members back inside the equipment lock. They'll be doffing their helmets and the rest of their spacesuit hardware a short time from now. This is Mission Control Houston, photo documentation continuing by Takuya Onishi of the spacesuits of Kate Rubins and Jeff Williams. This is par for the course following any spacewalk. A nice overhead shot here in the camera mounted at the very top of the equipment lock section of Quest. You see Anatoly Ivanishin at the hatchway between the equipment and crew lock sections of Quest. A short time from now, the crew will doff their helmets. And we will begin to wrap up our coverage with a quick highlight clip of the major events of today's spacewalk. Rubins and Williams will have very little time to rest up. Another busy week ahead. Next Wednesday, Williams will be surpassing Scott Kelly's record for most days in space by a U.S. astronaut as he eclipses the 520-day mark that Kelly established during his one-year mission aboard the International Space Station. Williams will return home on the night of September 6th U.S. time, the morning of September 7th Kazakhstan time, along with Alexei Ovchinin and Alex Gripochka on the Soyuz TMA-20M spacecraft, with a total of 534 days in space, putting him 14th on the all-time endurance list. A week from today, on August 26th, Williams and Rubins will be at the workstation, the robotic workstation in the cupola, as they use the Canadarm2 robotic arm to release the SpaceX Dragon cargo craft that brought to the station the international docking adapter that Williams and Rubins helped install and outfit today. That Dragon spacecraft due to be released at 5:10 a.m. Central Time next Friday morning. Our coverage of its release will begin at 4:45 a.m. Central Time, a week from today, Friday, August 26th. And there's one more spacewalk on tap for Williams and Rubins, that being on Thursday, September 1st, just 13 days from now. The crewmates will move outside of the Quest airlock and retract a thermal control radiator that was deployed as part of a reconfiguration of the station's cooling system a few years ago in an effort to isolate a leak in the cooling system of the complex. With that leak having been traced to a different component and fixed, that thermal radiator needs to be retracted, and that'll be the first order of business for Williams and Rubins on September 1st, followed by other work to install the first of a series of enhanced high-definition cameras outside of the station on the truss of the complex. We will hold a briefing to preview that spacewalk, that next spacewalk by Williams and Rubins, on Wednesday, this coming Wednesday, August 24th at 1 p.m. Central Time on NASA TV. The spacewalk itself scheduled for Thursday, September 1st. And the crew members' helmets now being removed.
Station Houston on Space to Ground 1 for talk when convenient. And for the crew in the airlock, we'd like to add a step. We see that you are taking off the comm cap, and as you're doing so, could you please verify how the connector is seated, please?
Jeffrey is saying that it's not a complete failure and he can barely hear it. And it looks like connection is just nominal. it's not loose, but we see some condensate water. It's just dry. Huh? Yeah, you are on the comm, but probably not to Houston. To Houston. Oh, really? Yeah, I think so. Hello?
The crew members, along with Takoya Onishi, are checking out Jeff Williams' comm cap.
3, 2, 1. Comm check. 5, 4, 3, 2, 1. Comm check. 5, 4, 3, 2, 1. Okay, so here's some airlock on one, so yeah, sounds like he can barely hear us on his right side, but doesn't have any issue with the left side.
Okay, we copy. He can still barely hear on the right, no issues on the left, and good connection. Did you verify all the various connectors were seated properly?
Check.
Thanks, Todd.
This is all part of the analysis of that comm cap. Jeff Williams experiencing some problems hearing out of the right earpiece in that comm cap during the final minutes of the spacewalk that eliminated any possibility of doing a couple of minor get-ahead tasks. No impact to the spacewalk and no impact to the next spacewalk. There are other comm cap components that can be used by Williams for the next spacewalk. So we've lost our downlink video from the Quest airlock. The crew safely back inside after a 5-hour, 58-minute spacewalk in which they accomplished all of the major tasks that had been planned. The spacewalk today saw the two crew members suiting up, conducting some light exercise in the equipment lock. Kate Rubins on the left, Jeff Williams on the right, as they prepared to move into the crew lock section of Quest to have the hatch closed behind them and to depressurize the crew lock section. The crew placed their suits on internal battery power at 7:04 a.m. Central Time and quickly made their way outside of the Quest airlock to begin to set up all of their tools and equipment for the major task that lie ahead, that being the installation of the first international docking adapter to pressurized mating adapter number 2.
Copy that. Thanks for the photos.
The crew made their way towards the forward end of the Harmony module to which PMA-2 is located and used to serve as the docking port for visiting space shuttles. At that point, as you can see, Kate Rubins on the bottom of your picture, Jeff Williams on the top, began to hook up connections for hook power and heaters between pressurized mating adapter number 2 and the international docking adapter itself. That paved the way for commands to be sent from a control panel by Onishi inside the Harmony module to close 2 sets of hooks, 12 hooks in all, that hard mated the IDA to pressurized mating adapter number 2. After that was over with, the crew took a moment to document all of the activities and complete the reconfiguration of connectors in the international docking adapter that will accommodate power to the forward end of the IDA that will accept the arrival of U.S. commercial crew vehicles in the future. One of the big steps, of course, was the removal of a large thermal cover by Rubins and Williams to expose the actual docking port to which the SpaceX Crew Dragon and the Boeing CST-100 Starliner vehicles will link up to in the years ahead. All of that work was completed very early on in the EVA with no problems at all, and finally allowing Kate Rubins to string yet another cable along the Harmony module towards pressurized mating adapter number 2 at the forward end. That will accommodate the installation of the next international docking adapter that will be launched in late 2017 on a SpaceX Dragon cargo craft that will be mated to the space-facing side of the Harmony module of the International Outpost. With all of their work done, the crew finally called it a day with the approval of the flight control team here in Houston, and the spacewalk ended at 1:02 p.m. Central Time with the repressurization of the crew lock section of Quest to bring the spacewalk to an end at 5 hours and 58 minutes. And just a moment ago, you saw both Kate Rubins and Jeff Williams get out of their extravehicular mobility units. They are in great spirits as they will make their way for a meal and call it a day. After a busy day, they'll spend the weekend recharging those spacesuits for use on September 1st in the next spacewalk that they will conduct out of the Quest airlock to retract a thermal control radiator and install the first of several enhanced high-definition cameras on the truss of the International Space Station. So once again, the first international docking adapter, the gateway for U.S. commercial crew vehicles, was installed in a milestone spacewalk today that lasted 5 hours and 58 minutes. The IDA is now a permanent fixture on the International Space Station. The stage is set for the SpaceX Crew Dragon and the Boeing CST-100 Starliner to arrive at the International Outpost. And our final image of the day from the spacewalk, high fives being exchanged by Kate Rubins and Jeff Williams, smiles all along as they made history today, as they made the transition to a new era of commercial space transportation for astronauts to the International Space Station. We'll wrap up our coverage now with one programming note. On Monday, we'll be able to recap this spacewalk and take a look at all of the future activities of the crew on the station through Space Station Live that will air on NASA television at 10 a.m. Central Time, 11 a.m. Eastern Time on NASA television. For now, thank you for joining us throughout the course of the day. A successful spacewalk by Jeff Williams and Kate Rubins. This is Mission Control Houston.